Let's now understand one of the most important concepts in Node, streams. Let me just say that if it wasn't because of how streams are handled in Node, Node wouldn't be as popular as it is right now, not even close. So it's of utmost importance as a Node developer that you truly understand this concept and how Node.js Streams work. Now, I see a lot of people who say it's hard to understand streams. I keep going through different tutorials about streams, and I feel like I know streams, and at the same time, I don't know streams. While I have to say that it's not harder to understand them, it just takes a little bit more time to understand them. You first need to have a foundation of knowledge of Node and some concepts to be able to understand streams properly. And that's exactly what we're going to do in this video. If you're just here to see some examples of streams and just know what they are, this video is not for you. Our aim here is to truly and deeply understand streams, so much so that you could just use them in your applications and feel confident that you are creating highly performant and memory efficient applications. And to be honest, that will take some time. So let's take a look at what we will do in this video pretty quick. We're first going to learn about how to use an existing Writable Stream in Node. Now, the stream could be in one of the native Node.js modules itself, or it could come from a package that you installed. So we're first going to learn how to use these Writable Streams, and then after we learn how to use them, and after we understand them, we're going to learn about how to develop our own Writable Streams in Node. And after we're pretty much done with the Readable Stream, we're going to move on to the Readable Stream. So we're first going to learn how to use an existing Readable Stream, and then we're going to learn how to develop our own Readable Streams. And these two different types of streams are the fundamentals of these streams. So after we understand them, we will be pretty much done with understanding streams, at least for the most part, and then we're going to learn about duplex and transform, which are just a readable and a writable, but they are implemented in some special ways, but we're going to get into all of them later in the video. Now, if you don't know what is a writable stream, what is a readable stream, what is a duplex, and what is a transform, don't sweat it. We're going to talk about all of them in great detail later in this video. This is just like a quick, kind of like a table of content for this video. So after we're done with learning how to develop our own Readable Stream, we're going to learn how to implement our own duplex streams. Now, a duplex is just a stream that has a writable and a readable in itself. So if you understand those two, understanding duplex will be really easy. So we're first going to learn how to develop a duplex, and then we're going to learn how to use a duplex by using that duplex stream that we just created. And after we're done with duplex, we're going to do the same thing, but now with a transform stream. So we're going to develop a transform stream first, and then we're going to learn how to use that transform stream that we just developed. And the transform stream that we're going to create is a decryption and encryption application. So we're going to learn how to work with the raw binary data with the zeros and ones and modify them in a way so that we're going to have an encrypted file, and then we're going to do the same thing but in the opposite direction, so that we will change our encrypted file into a decrypted file, which will give us back our original file. So we're going to write a lot of code in this video. For each one of these, we'll possibly create some simple applications, and we will gradually enhance our knowledge of streams, our understanding of streams, step by step. So we have a lot to cover. There are a lot of concepts that we need to unwrap and understand, well, which means that this video is going to be pretty long. And please don't try to do this whole video in just one sitting, in just one day. That will be really counterproductive. Please instead do it in different portions. Maybe do it in 50-minute sittings or something like that. So watch the first 50 minutes right now today, watch the next 50 minutes tomorrow, or the next hour, whatever feels most comfortable for you. So do it in different sessions and different sittings, and not just all in one day, because there's a lot that we need to learn about, and doing it all in one day, I'm sure it's really not going to be helpful, and you will really end up confused at the end of the day. So please do it in different sessions, and don't just say, okay, I'm going to fast forward, I'm going to skip this part, I'm going to skip this part, and do it all in just one day, and boom, now I understand streams completely. Definitely not. Do it in different sessions, in different days, and I'm sure that you will really take your knowledge of streams and Node.js to the next level after you're done with this video. So do it in different days, write code with me, follow along with me, create some applications, do the challenges that I'm going to give you, and afterwards I'm sure that Streams would be something really easy for you to use, and the quality of the applications that you're creating will really increase. Alright. And we are also going to write some code that might not be really related to Streams at the first sight, but they will really help us to understand the bigger concept here, Streams. So we're first going to write some programs that are not really related to Streams directly. What we're trying to do is to build a background and then really see how useful Streams are, and know exactly where you should use Streams. So we're going to use what we already know, buffers and the file system module, to do some things with them and benchmark our programs and push what we can do with them to the limit. And gradually we're going to introduce the concept of Streams. Now I also want to say that buffers are at the core of Streams. And if you don't understand buffers, to be frank, you won't understand Streams at all. It will be really hard. So please, if you don't know anything about buffers, go ahead and watch my video about buffers here in this course and this playlist. And we're also going to build on our current knowledge of buffers right now in this video. Alright, so let's get into it. I'm going to open up my terminal, and on my desktop I'm going to create an empty directory called Streams. And here in this folder we're going to write all of our code related to this video. We're going to create a whole bunch of different files, so we need a folder for that. So please make sure to do it and follow along with me. So now that I've created my Streams folder, I'm going to cd into it. And first I'm going to create a file called, let's call it writemany.js. And I'm going to open this folder up in my code editor. Now in this file writemany, we're going to write some code that is associated with writing something to a file many times, right? So let's see what we can do. Now, first I'm going to give you a challenge. I know we're just starting, but I want you to think about it and see how you can do this problem. So I want you to create a file here in your directory, whatever you want to call it, it doesn't matter. And I want you to go on ahead and write something to that file 1 million times. Okay, so it could be anything. It could be just numbers from 1, 2, 3, 4 up until 1 million. Or you could just simply write one character, maybe character A or a character B or anything, or maybe a portion of a text, a sentence. It doesn't matter. The point is that you write something to that file. You could name it, for example, test.txt. The point is to write something to this file 1 million times. Right, so I want you to go on ahead and see how we can do it. You should be able to do it if you have watched my video about the file system. You could just open the file and then you could just run a loop and then write something to it 1 million times. And I also want you to benchmark your code and see how long it takes. And the way that you can benchmark your code is using console.time. So you could just run console.time and name for it, for example, writemany. And then at the end, you should run console.time end with that exact same name. So if I just try to do one operation here, say let a equals 2 plus 2 and run this code. So I'm going to say node writemany. I'm going to see that this piece of code, so from this point to this point, this code took this much, 0.034 milliseconds, which is a very short amount of time. So I want you to write your solution and execute it and benchmark your code and see how long it takes. Right, so now let me show you how I'm going to do it. So I'm going to first require the fs module. So const fs equals require node fs / promises, because my code will look cleaner. And right here, because I want to use the syntax async await, I'm just going to write an immediately invoked function like this. And I'm going to mark this function as async. Alright, so right here, I'm going to first open a file. Okay, so I'm going to open a file. In this case, I have created this file already, so it's called test.txt. I want to open it as write, because we're going to write to it. We need to write something to it 1 million times, so definitely it's going to be write. and I'm going to save it to a variable. I'm just going to call it file handle. And now here I'm going to create a loop. So for let I equals 0, I less than 1 million, so 6 zeros, I plus plus. And now I'm going to write something to this file handle. So I'm going to say file handle dot write, and I could here specify a string or a buffer. So I'm just going to actually specify this I variable. So I'm going to create an ES6 string, and I'm just going to inject that I in. So I. Super simple. Now, if I run this code, I'm going to open this file, test.txt, and I'm going to write this string to it 1 million times. And before I run this code, I'm also going to benchmark the code. So right here, I'm going to run one console.time, and I'm just going to say console.time write mini, and then console.time end here after our loop ends dot time end. And I'm also going to mark this as wait because it returns a promise. Let's wait for it to resolve. All right, so now let's oops, semicolon here, and there we go. All right, so let's run this code and see how long it takes to finish this process. So I'm going to say node write mini, and it's probably going to take some time, so I'll wait. All right, so it's done, and it took 8 seconds to run. If I take a look at my file, you can see that it starts from 0, and it should end at one number lower than 1 million. So 6 nines. And that's the end. That's the last number. And as you can see here, it took 8 seconds to complete. Let's run it a couple of times and see what other results we'll get. So I just ran it for 2 more times, and as you can see here, the results are pretty consistent, around 9 seconds. We're not going to get this exact same result, maybe like 8.111 and 8.111 the next time. It's going to be different. The disk speed might be different from time to time, and the computational power, your CPU speed, might be a little bit different from time to time. But the point is that they are consistent around 8 seconds for something like this to happen. All right. And just a note, if you run this code one more time, it's just going to write from scratch because we're not appending to that file. We're writing from scratch, so the content will be overwritten. Every time you open, the content will be overwritten. But here in this for loop, because we're keep writing to it, we're not actually overwriting anything. We're just adding at the end. All right, let's try to run this application a couple more times and take a look at how much CPU power and memory usage this application is using. So I'm going to open up my activity monitor application, and let's try to run this application a couple of times and see what's happening. Now, if you're on Mac, I encourage you to do the same thing, and actually on any other operating systems. On Mac, you could just open your activity monitor application. On Windows, you can open Task Manager, which is a similar application to this one. Well, it's a little bit different, but it's roughly the same thing. You could see the whole list of all your processes, and I think you could filter and see how much memory and CPU, disk, network, and all the rest, how much all these resources are being used by different processes. And if you're on Linux, you could make use of the top command, or you could install htop, which is a little bit more user-friendly than top. And I assume if you're on Linux, you know how to install that, so I'll leave that up to you. But still, you could just use the top command. And to be honest, it gives you more information comparing to what Activity Monitor gives you, but this one is more user-friendly, so I'm going to stick with this one throughout the course, at least most of the time. So what I'm going to do is to just search all my processes by the one that I care about, which is Node. Now, if I open any applications using Node, meaning if I run Node, I'm going to get a new process here. So if I just say Node, a new process. Now, when there is nothing going on, it's using 0% of the CPU, which is expected because we're not really executing anything. It's just an idle application. It's an idle process. And memory usage is around 12 megabytes, 12 megabytes. So let's now run our tiny program and see what will change. So I want to say node write, and let's first monitor how much CPU we're using. So if I run it, the process is going to pop up here, and you can see that it's around 100%. Now, we might be asking, why is it 100% here? But in the idle, it's only around 60%. So it means that 60% of my CPU is not being used, and only it's here, it's saying 100% it's using. Well, the reason is, it's because my machine is an 8-core machine, and each CPU corresponds to 100% of the usage. So if I see one processor using 100%, it means that it's using only one of my cores, but to its full power. If I see a process that's using 200%, it means that it's using 2 cores, but at their fullest power. So I see the process happens, and I see 100 usage, but I still have a huge amount of idle CPU on my machine, which is something that you need to care about later on when you're deploying your application. We're going to talk about this way more later in the course. But the point is, it's 100%, but it means that it's only using 1 core, because Node.js is single-threaded and it's only using one of the cores. If we want to use more than 1 core, we have to use clustering or the worker thread module, which are the things that we're going to talk about at the end of the course. Now let's monitor the memory usage. So the CPU was 100%, only 1 core. If I run my application and I monitor here the memory, you could see that it starts at 20 and then it goes up to 40, so 50, it hovers around 50 megabytes. So it's safe to say that it uses only 50 megabyte of my memory. So we could say here, this piece of code, it takes 8 seconds to run, uses 100% of the CPU, and here I could say 1 core, and memory usage is around 50 megabytes. Now let me just make it more consistent, so I'll say CPU usage 100%, meaning 1 core, and execution time is 8 seconds. Right, looks better. Now let's try to see how much we can make this code faster. Now if you recall from my previous video, we said that the callback versions in Node are usually a little bit faster, and I mean in the file system module. And that's what the Node.js documentation says. So let's try to change this code to use the callback version and see how much faster we can get. So I'm going to copy paste this code, and I'm just going to comment this first code out, this first portion, and let's try to do it using the callback version. So instead of using the promise version, I'm just going to say fs.open. Same 2 parameters are the same, but at the end we need to specify a callback function. And the callback, the first parameter is our, let's try it again, because I wanted to see this pop up, because I don't really remember. Actually, I'm not getting the pop-up because I'm not including the write module. So if we want to use the callback version, we shouldn't include from the promises. Instead, we should include from the regular fs module. It means that we need to drop this promises at the end, and now we're using the callback version. So so the first parameter is going to be the error, and the second one is just going to be a file descriptor. And I think we talked about it in the previous video. File descriptor is just an ID. It's just a number that is associated with an opened file, and it's unique. So each open file has a unique file descriptor, which is just a number. And to write to it, we could use the function called fs.write, which accepts the file descriptor, which is fd, which is right here, and then we need to specify a buffer, or it could be a string. So I'm going to move my for loop here inside, and I'm just going to use the exact same thing that I did previously in that promise version. And this one accepts a callback, but you can imagine that it's not really going to work, because then we need to call the next function inside of that callback. And because we're running it a million times, it doesn't really make sense to do something like that. And we don't really actually need to do anything in the callback anyway, so I'm going to omit the callback and change the syntax to use the synchronous version. So I'm going to say write sync. And let's move our console at time ends after the loop. And we actually don't need this piece, but let's keep it there because it doesn't really matter. Because let's try to make them as close to each other as possible. Now let's run this code and see how long this one will take. So I'm going to delete this test.txt just to be extra sure that something is actually happening. So now I'm going to run the code. And as you can see, it only took like 2 seconds, which is a lot faster than the previous version. Now to confirm that we're getting the exact same file, I'm going to open this one up, and it starts at 0 and it should end at 1 million. And that's right, 6 nines. So we're getting the exact same file, and it's actually executing 10 times faster, not 10 times, but maybe around 5 times or 6 times. So it's a lot faster, but we actually didn't use the callback version. Let me just show you what will happen if we use the callback version. So we're not executing anything at the end, but we still need to keep it, right? Now if I run it, well, it roughly, actually it didn't take 1.4 seconds because you saw a little pause, because at the end, after the for loop finishes, it's just going to log this, and we still have some callback functions in our event loop. So even if we reach the end, the event loop is still working. Now, if we open this file, you're going to notice that we're getting all the numbers. I mean, if we get the file size of this one and compare it to the previous one, it's the exact same size, but as you notice here, numbers are not in order. So here I have the last number, but right before that one I have 90. And if I run it another time, it will be different. For example, here I might have 97, and then here I might have 98, and then here 99. And the point is, they're not in order, and it's because we're pushing so many different events to the event loop, and they're not really actually getting executed at the same time. So we can't really be sure that the first callback that we're going to push is going to be executed faster than the callback version that's going to be pushed after this one. So there's no guarantee in that, and we can't be sure of the order of the numbers, which is different from our previous version that all the numbers were in order because we're awaiting those promises. Now what is really interesting here is that if I run this code and if I monitor my application, so I'm going to look for my node, and if I just run it, let's take a look at our memory usage. You see the memory usage is around 500 megabytes, 600, 700. It really jumped to 700 at one point. So let's run it again and take another look. Here you can see 500, 700, and it's a lot. If you compare this one to the previous one, which was only 50 meg, it's way more. It's like maybe 10 times more. So even though it's executing faster, it's occupying so much more memory, which is again different from the synchronous version. If you try to do it using the synchronous way, it's not going to occupy like 700. It's going to be like, again, just 500. And if I change this one from 1 million to maybe 10 million, I don't think so that it's going to work. Let's try this. And let me open my activity monitor. See, my memory jumped to 2 gigabytes, now 3. It's going higher and higher for 5. I only have 8, so I don't think so that it's going to go higher than 8. To 7, and let's just wait for a couple more seconds. Yeah,
when it reached 8, now our application crashed, and I see I reached heap limit, allocation failed, and JavaScript heap out of memory. So we ran out of memory. If you take a look at my memory pressure here, these orange lines and indicate my memory pressure. It's that period of time that I ran that application. So be careful when you're pushing so many different events on your event loop. Now I know it is a very extreme example, but these things might happen. You might end up in a situation that you're pushing so much events to the event loop, and you might quickly run out of memory. So I'm just going to change it back to the synchronous version and move with that one. So I'm going to remove the callback, and I'm also going to change the function name from write to write sync. Alright, now let's run it again. So yeah, around 1.5 seconds. Now let's take a look at the activity monitor and see how much memory we're using. So I'm going to run it again. So I say around 30 or 40. It's definitely a little bit lower than 50, maybe just slightly lower than the previous version. Let's also take a look at the CPU usage. If I run it, it should be the same thing as 100. Yeah, it's 100. We're not exactly seeing 100 because, you know, there are some latencies here and there, and we are not even sure about the memory if it's like 30. It could be a problem here in my activity monitor because it doesn't get updated as soon as that application ends. So what we can do is to just say the exact same things, but the execution time is now a lot slower. It's around maybe only let's just say 2 seconds, just round it up. CPU usage 100%, still 1 core, and memory usage, let's just say 50 megabytes. It doesn't really matter that much. Now let me also try to make this code a bit more explicit, because I don't want you to think that we're writing a string to that file. What we're doing here is that we're converting the string back to a buffer, and then we're going to write it. So what we can do is to create a new buffer here and then keep writing that buffer to that file. So let me actually just run it a couple more times and just benchmark it, because I paused the video for a second and ran it a couple times, and what I noticed was that the results are pretty consistent and they're around 1.6. Now here it got to 1.8, but it's safe to say that this code runs at 1.6 seconds. So I want to change it to 1.6. Right? But now, to make it more explicit, what we can do here is to either specify a character encoding, and that means that converts this string back to zeros and ones using that character encoding, or I could just define a buffer here. So I say const buff equals buffer dot from this string, and then the character encoding, which is by default UTF-8, but nonetheless I'm going to specify it. And then I just need to pass that buffer in here. If I run this, it should still be the exact same thing. Not the exact same thing. It will be a little bit longer, like 1.8, as you can see here. And the reason is because now we're defining a new const variable every single time in each loop run, whereas before we would just pass the string and Node.js itself would convert it into a buffer. So the previous code is a bit faster because there we don't define a new variable every single time, but not something that we really care about. I mean, if we were to specify this here at the top and don't create our buffer every single time using Node, and let's just say maybe A, and pass this buffer here, so we're not creating our buffer every single time in our loop, this code will now be slightly faster, even to the previous example where we were specifying a string here. So it's around 1.5, 1.6. You can see that these are faster than this one, which was 1.6. It didn't really get to 1.5, but here it did. So if you don't create buffers every single time, it will be slightly faster. But again, these are not things that we really care about. All I want to say is that I want you to know that we are writing a buffer to this file and not writing a string. So let's keep it like this one, and let's just also change it to 1.8. Alright, so we're creating our buffer and then we're writing it to our file. And we're getting the exact same result. Nothing is really different in terms of the file that we're going to get. Exact same size, everything is just the same thing. And they're all in order. Alright. Now, at this point, do you think it's possible to make this code even faster? What do you think? Do you think it's possible to maybe make it twice as fast, or make it 3 times faster? Or, I don't know, just make it faster in any way that we can. Not maybe by a slight amount, but by a significant amount. So, I mean, make it twice as fast or something like that. Well, the answer is not really without using streams, but most definitely yes, if we want to use streams. So without streams, we can't really make this code any faster, but with streams, we can really make it a lot faster. And we're going to see that in just a second. So what I'm doing right now is to write the code to do the exact same thing, but this time around using streams. So we're not really going to talk about what streams are at this point. I'm just going to show you an example, and then we're quickly going to jump into the concepts and really understand what streams are. So I'm going to copy this code out to the first solution using the promises version, and I'm also going to comment the second solution out. So I'm going to paste the code in and uncomment it. Actually, these 3 lines need to be commented, but now we don't have the time. CPU usage is still going to be 100%, so I'm going to keep it that, but the memory usage, we're not sure. So let's see how we can do the same thing, write 1 million times to this file, but now using streams. So the way you can do it is to first create a write stream of this file. So let's do that. So I want to say const stream, or a write stream. We have different kinds of streams, but we'll get to them later on. For now, just know that it is a stream. So stream equals file handle dot create write stream. Notice that we also have another function which is called create read stream. You would use this one if you want to read, and you would use this one, create write stream, if you want to write. In this case, we want to write, so I use the create write stream. And now that we have the stream in place, what we can do is to just write to it. Alright, so I understand that you don't know what a stream is at this point, but let's see first how to use it. So the way you can do that is to just say stream.write, and here we have to specify our chunk, what we want to write to the stream. Now our chunk could be just like before when we were writing to our file. It could be a buffer or it could be a string. So in this case, I'm going to use a buffer just like before. So I'm going to create the buffer like here. Where is it? It's here. I'm going to copy this code and paste it right here. So we have now our buffer, and I'm just now going to write it to our stream. And I'm going to remove this last line. All right. So now we're writing to that file, but this time around we're using streams. So let's run this code and see how long it'll take to execute and how much is the memory usage. So I'm going to delete the file first, and let's first make sure that it actually works as expected. So I'm going to run the code. Well, it was quite fast, but let's take a look at our file and see if we're actually getting the same file. And well, the answer is yes. We're getting all those numbers starting from 0 going all the way up to 1 million. So we are creating that same file, and well, it's way faster. It's only 200 milliseconds. It's not seconds. It's not 2 seconds like here, or 8 seconds. It's way faster than both of these solutions. Way faster. I mean, this one was 1.8 seconds, and this one is just like a fourth of a second. And the results are actually pretty consistent, all around 270 milliseconds. So we could say that the execution time is 270 milliseconds, like this. Now, what about the memory usage? Let's try and take a look at the memory usage. So I'm going to open the activity monitor, and this is going to be a pretty fast execution, so I hope we can see something. Oh, actually we can't, because my frequency right now is like, where is it? If I go to view and update frequency, it's very often 1 second, but that application is running only 200 milliseconds, so I can't really get that process here. But what we can do is to increase that number, or maybe use the top command. So I'm going to create a new window and just run top. And I don't know if we can really filter, but if I run, let's see what we can get. Well, actually, it appeared here at my activity monitor, and for just a second you can see that the memory is around 150 megabytes, which is a lot. I don't know if I'm getting it here, but actually it looks like that we got it here in the activity monitor, so I don't care about top right now. But if I keep writing, executing it, we could see that for just a second it appeared and was like 200. So let's just say 200 megabytes, which is a lot more than this one. Now, I really want to say something, that this code here is not a good practice. I'm just gonna say it right here. Don't do it this way, okay? And this is not a good way to work with streams. And one of the problems that you can see is our memory usage. It jumped to 200 megabyte, which is a lot. If I just add one number to this one and make it to 10 million and run it right now, you can see that my memory usage is now around 2 gigabytes, which is a lot. So don't try to run this code in production. And we have to take care of some of the things with that stream to make it way more memory efficient. But you can see that it's way faster than the previous example. It's way faster, around maybe 10 times or 9 times faster, which is a lot, which is a huge deal when you're creating applications. If we can make your code twice as fast, or even 20% faster, that's a lot, let alone making it 10 times or 9 times faster. It's a huge deal. So let's now try to really understand what streams are, and then we're gonna get back here and fix our problem with memory usage and make it both super fast and also super memory efficient. So let's jump right in and see what streams exactly are. Well, let's first take a look at the definition of streams in the Node.js documentation. Now, Node.js says that stream is an abstract interface for working with streaming data in Node.js. And that's it. That's what streams are. It's something that helps us with data streaming. It makes data streaming way more efficient. Now, you might be asking, what exactly is this streaming data? When we say streaming, things like video streaming, game streaming, Netflix, or in general media streaming might come into mind. But it's a lot more than that. Whenever we have data flowing, we can say that we have data streaming. The definition of stream in the English language is just a continuous flow of something. It also means a narrow river, which is also relatable, but here in computer science it's closer to that continuous flow. So if I say, for example, a stream of people is coming to the school, maybe for the graduation party, I don't mean that 500 people are coming in through the door at one chunk in 1 second. No, I mean that people are coming in gradually. For example, 5 people will come in, and then another minute, 10 more people, another second, 2 more people, and over time they will gather, and then we're going to have a total number of maybe 1,000 people in the school. So that's the same concept in computer science. Data streaming just means that you don't move the whole data in one chunk. You move it over time in different chunks. So you break it down to different chunks, and then you send those chunks over, and then at the end you just combine them together, or maybe not. The point is that you're sending it in different chunks. All right. So let's take a look at one example. Let's say you want to do a copy paste. So you have a file on your computer, on your laptop maybe, that's 10 gigabytes in size. And you want to copy this file and paste it somewhere else, maybe on the same laptop or on another disk, on your server, on a USB drive. It doesn't matter. You just want to do this action of copy pasting. Now, what you could do, and by that I mean your operating system or the program that's supposed to do this copy pasting, it could just move this whole file in your memory first. So your memory is going to be occupied for like 10 gigabytes, and then it's going to do only one write and create this one file. So that's one option of doing it. It's like moving 500 people through the door all at the same time in just 1 second. You might be saying, well, that's really fast. We're just gonna get all the people in 1 second rather than waiting for like maybe 5 minutes or 1 minute or two. But the problem is that you also need to build this huge door that will allow 500 people to come in all at the same time, which is really not ideal in a lot of cases, and it's really not efficient to build that huge door just to be able to move 500 people, maybe just for a graduation party or something like that. It's not something that's really ideal in our world. And the same is true in computer science. It's not ideal to move this whole file in your memory and then do one write. Although that's possible and you could do it, it's not really ideal. Let's say that somebody is on their mobile phone and they only have like 1 gigabyte of RAM and they want to do a copy paste of a file that's like 500 megabytes. If they do that, they're going to occupy half of their memory, which is already full in a lot of cases, and that's really going to end up in a lot of different performance issues, and it's not really something ideal. You don't want to do something like that. Instead, what you need to do in your operating system or the application you're creating, you need to set up a stream of data between these 2 points. So in our case of doing this copy paste, rather than just moving this whole file into memory and then do just one write, you're going to just send different chunks. Maybe send them in a chunk of 16 kilobytes, 20 kilobytes, 1 megabyte, or something like that. Now, yeah, you are technically doing more writes, but it's way more memory efficient, and also in terms of speed, it's close to that previous example. It's not really as fast as that one, but it's really close. Now, in the case of Node and our previous example of writing many times to a file, what we did was that we wrote 1 million times to that poor file. But after using a stream, we reduced that number. So using a stream, if we set up a stream, we wait for the data to gather and get big enough to be equal to the size of our chunk, and then we write. Now the size of our chunk by default is 16 kilobytes, so that's what streams use in Node.js by default. So we wait for the data to gather, and I mean each time we write, we're writing to that buffer, and then if it gets big enough, then we're going to do a write. And we're going to get into this concept just a bit later, but this is how it's roughly done. We set up a stream and then we keep writing to it. Keep waiting for the data to become available, and then we do a write. Now, writing and reading from files isn't the only place where Node.js is using streams. A couple other examples would be, for example, here. Imagine that you have your Node process and also another process called ffmpeg, which is an application that you can use for editing files, actually editing video files, like cutting them out or adding a text, just usually normal video editing operations. So let's say that you want to make your Node.js process to talk to this one. You're creating an online video editing application and you're constantly receiving the data, for example, cut from this portion, or change text here, or change the effect here, or things like that. So you keep getting those data, and what you need to do is to set up a stream between your process and ffmpeg and keep sending those data in chunk. This is going to be way more efficient than, sending all of these in one go. Like in our previous example that we did 1 million writes, and then we managed to reduce it down to way less number of writes, which again, we're going to get into that later. But you can imagine that this is another example where using streams will make sense. We have a flow of data. We keep sending information to this ffmpeg, and this is a very good example of using streams. Now, you could also use many different streams in your Node application. For example, you could have another one that will talk to the network card. So as you receive requests from the clients, you read those requests off of your network card, and then you do processing on them. Or you could also send responses back to the network card to go to the outside internet. So this is another example where using streams is extremely efficient. And in fact, if you're using the HTTP module or the net module, or pretty much if you have created any network applications in Node, you have used streams. Now those packages are using them behind the scenes for you, but that's what is really happening. There's a stream there, and it's keep reading from the reading from the requests and writing to the responses. You could also have another stream to your storage. So you would receive the files, for example, MP4 files, and you save them to your storage using a write stream. And then using another write stream, you talk to FFmpeg to say, all right, go ahead, grab that file and do these operations. Once done, FFmpeg might use another stream to send you the information to say that I'm done and here's the new data. Now you would receive those data in a read stream rather than a write stream. And then you would just send a response back to the client using a write stream because you're writing to the network card. So these are just some examples where Node is heavily using streams, and this is making your Node applications way faster. Now let's talk about the different types of streams that we have available. Now, mainly we have two streams. We have a writable stream and a readable stream. Now, a writable stream would be a stream that you could write to, like that write million times example that we wrote. We were writing to a file, so we used a writable stream. Now, a readable stream is a stream that you would read from. So you could imagine that you might want to, for example, open a file that's very huge, like 10 gigabytes, and you want to read from it, and then using another write stream, you want to write that to another file. So that's where you would use a readable stream. Now, in our previous, if I go back to the previous slide, here you could see that this is a writable stream because we're writing to FFmpeg. Now, there's another one from FFmpeg to Node, which I haven't actually drawn here, but you could imagine another stream from FFmpeg to Node, but that is a readable stream because Node.js is reading from that. Now this one from Node to network card, again, we could have both a readable stream and a writable stream. If you're reading from the requests, we're using a readable stream. If we're writing to the responses, we're using a writable stream. So if we send a request back to the client, we are writing, and if we are reading the requests coming from the client, we are reading. Now in terms of our storage, because we're just saving those files on our hard drive, it will be just one writable stream. Or multiple write streams because we could be handling many requests at the same time, so we will be writing to different files simultaneously. But yeah, these two are the fundamental types of streams in Node. We also have two more streams, and one of them is Duplex, which is just a stream that's both writable and readable. We also have a transform stream, which is just like Duplex, but it also transforms the data. Now we're going to get into these two later. If you understand the writable stream and the readable stream, understanding these two will be really easy. So whenever we have a flow of data, streams are an incredible option to use. So this flow of data could be between nodes and another process, or node and an underlying resource like hardware, or it could just be really any kind of data flowing. And by data, we just mean zeros and ones, all right? So for example, let's say that you have this piece of data and you want to encrypt it. So you want to do some operations and make this data encrypted so that nobody could access it unless they have access to secret code. Now what you could do is to create a map and say, whenever I have a 00 and a 11, I'm just going to change it to a 111 and a 000. So we're going to look for in the data and see where we have these patterns. And just to note, these encryptions and compressions and things like these are actually working with the raw binary data with these zeros and ones in most cases. So what you would do is to just find those keys and then just do a replace and end up with something that's really not meaningful to somebody that doesn't understand this map. So this part will be something gibberish. If someone takes this data and runs it through a capture encoding, they're going to end up with some gibberish because we have done a replace here. Now if you give this to the right user and now they want to decrypt it, what they could do is to just use that map and do another replace, go backwards and then get the original data. Now in real-world encryption applications, it's actually more complex than this. There are a lot of prime numbers involved, a lot of discrete math, so it's not just doing a replace on one portion of the code and then leaving the rest as they are. It's just more like doing an encryption on all of the data using some mathematical formulas. So it's more complex and also way harder to crack. But this is also a valid example of an encryption. You just have to make sure to keep an eye out on those keys so that you know that this is an actual key and you have to do the replace and it's not part of the data. But anyway, now this is an example of data flowing. Imagine you want to encrypt a huge message that's hundreds of megabytes or maybe a couple gigabytes or even more. It's not really memory efficient to just move all that data into your memory and then do your encryption. What you would do instead is to just try to get different chunks out of that original message, be it a file or a response. It doesn't matter, just be it any kind of data. It doesn't even have to be a string, just some raw binary data. So you want to get different chunks out of this file and then do these operations and make it encrypted and then write it to a destination. And this is a good example of using a transform stream. So we'll just read the data, transform it, and write it to a destination. Another example would be if you want to compress a data. Now in this case, you would kind of go the other way. So you keep looking for patterns, you keep looking for repetitions, and you try to condense them down to something smaller. For example, you want to have a map like this, and say, whenever I have this many ones and 00 and then this many ones, I'm just going to condense it to 010101. And then you're going to look for those patterns, which we have 3 here in this binary data, and then you're going to do your replace. So what's going to happen is that you're going to end up with a file that's much smaller in size comparing to your original file. And then using this map, you could just get the original file. Now you might compress some data and the file size might not really change, because there might not be that much repetition or that many patterns to condense them down to something else. But some cases, especially if there is a ton amount of repetition, you could really reduce the file size by so much. But again, it really depends on the data that you're working with. But here could be another example of using a transform stream. The point is, whenever you have this data flowing, you could use streams. You could use the readable stream to just read. You can use the writable stream to just write, duplex if you want to do both, and transform if you want to modify the data in any way. Alright, so now let's understand what happens inside of a stream object. Now that we know what streams are, let's now see how they work. More specifically right now, let's talk about a writable stream. So let's say that this is our writable stream object, and we can get this by running something like fs.create write stream, something that we did in our previous example. We wrote that code and then we got a stream object, and this is our object. This is our writable stream. Now inside of this writable stream object, we have an internal buffer, and its size is 16,384 bytes by default, which is specified by the high watermark value. And we're going to see that in action later in the code. But this is the default size, and you can change it, but this is by default how much of a buffer will be allocated to each stream in Node. Now, apart from this internal buffer, each stream object, each writable stream object, also has some events, properties, and methods available on it. Now, one of the most important methods is this stream.write method. Now, whenever you call this function, this method, what's going to happen is that you're going to push some amount of data into your internal buffer. Let's say you try to write a buffer that's of size 300 bytes. Now, this data here should be a buffer. Now, you can also specify a string but Node.js later on will use the character encoding specified to convert this data, this string, to a buffer and then do the write. So this data, think of it just like a buffer. Although you could specify a string, but think of it like that you could only specify a buffer, just to make it easy for you to understand how this works. So you push some amount of data into this internal buffer, and you keep pushing. So you push another chunk, another one, another one, another one, and you keep going until your buffer is completely filled. So now that we have our buffer completely filled, what the stream will do in this case is that it will do a write. So it will now pull all of this data out in one chunk and do one write. This is how a writable stream works in Node. Now, the reason that it's so efficient, one of the reasons actually, is if you take a look, we wrote 8 times. So if you count these, there are 8 different chunks. So we wrote to that stream object 8 times. Now in our example, we had that loop and we kept writing these numbers to our file. So we wrote a space, a number, and then a space. So let's say if that string is like 5 characters, so 5 characters, each character is 8 bits, so 5 times 8 is 40 bits, way smaller than this 16 kilobytes, that is the size of this buffer. So we kept pushing those small data to that stream. So in this example, we wrote 8 times, but the important point here is that we only write once. So we write to our stream 8 times, but we only write once. Now when you write, you're writing to an underlying resource, like a file, for example, or your network card. Now this is way more efficient because you're writing now in your memory, in your process, in your Node.js process, and then once the data is filled, you're just going to do a write. Now an example of that for loop and writing those numbers. Now without streams, we're writing 1 million times to our underlying resource. But if we use streams, what will happen is that we will keep gathering the data and then do one write. So we will significantly decrease the number of writes that we do into that file, which is way more efficient. Now you might be asking, what will happen if we try to write to the stream an amount of data that's way bigger than the internal buffer? And not just way bigger, just slightly bigger. Let's say that here our last write was 2,177 bytes. Now what will happen if we try to write a data that's maybe like 3,000 bytes for our last write to completely fill this buffer? Now what will happen is that Node will push this amount of bytes to our internal buffer and then buffer the rest of the data, which is going to be around 800 bytes. Now that 800 bytes will be in memory. It will keep track of it, and once the internal buffer is emptied, it's going to push that again to this internal buffer. Now, if you think about it, in this case we're going to have a problem. What if you keep writing to this internal buffer without letting it to get emptied? Now what's going to happen is that Node.js will keep buffering all of this data. And by buffering, I just want to say this one more time. A buffer is a location in memory that holds a specific amount of data. So if you create a buffer that's 400 megabytes in size, you are quickly filling your memory by 400 megabytes. So whenever you have a buffer, whatever its size is, you have allocated that much size off of your memory. All right, so if you keep buffering data, it's going to be a problem because you're going to run into some memory issues. For example, if you try to write a data that's 800 megabytes in size, what will happen is that, well, first of all, the buffer will get filled, and we're going to have this 16 kilobytes in our internal buffer, but Node.js now will keep the rest of the data in memory, right? Which is going to be a huge problem. And in this case, where our memory usage will jump up to 800 megabytes, which is not something that we want. We're using streams to try to lower this amount as much as we possibly can. But if we try to do this, if we try to run this code, if we try to say stream.write and put a data that's very huge, we're going to have some memory issues. Or not just doing one write, but you keep writing without letting the buffer get emptied. like our previous example. We kept writing to that stream, but we didn't really let it to get emptied, right? We just kept writing, and Node just kept buffering all those incoming data so that we had that huge amount of memory issue. I guess it was like 700 megabytes, I don't recall, but it was a huge amount, which is something that we don't want. So what you need to do is to first wait for this internal buffer to get emptied and then do another write. Now this time, this process that the stream does to empty this buffer is called draining. And we have to keep an eye out on this event, and it's actually an event. So you say a writable stream dot on drain, and then you do your code. We're going to see all that in code, but I just want to say that you have to wait for this internal buffer to get emptied, and after it's completely empty, you are now safe to push more data into this internal buffer, or I should say write. So this is how a writable stream works in Node. It's just an object that has some events, properties, and methods, and also this internal buffer. Let's now take a look at the readable stream object. Let's see how this works. So again, we have our readable stream object, and we can get this by running something like fs.createReadStream. And what we're going to end up with is this object. Now, just like a writable stream, we have an internal buffer, size of which is that high watermark value, which is by default 16,384 bytes, or just 16 kilobytes. Now, again, just like a writable stream, we have some events, properties, and methods available on this readable stream. The way that we can push data into this readable stream is by calling stream.push and then some amount of data. So we keep pushing into this internal buffer, and what's going to happen is that once it's filled, we're going to get an event. And the event is called stream.onData. So the event's name is data. So you need to run this code on your readable stream and keep looking for these data events. So once the internal buffer is full, we're going to get an event called data, and we're going to get this data all in one chunk here in this callback function. So we're going to pull the data out, and we're going to do whatever we want with it in this 3 dots section. Maybe you want to write it to another writable stream, or you just want to read it. It's up to you. So this is a readable stream, and you use this readable stream to make a huge data, a huge message, into different chunks. So let's go back into our previous example. Here, let's say that you have this 800 megabytes of data. Let's say it's a message coming to your network card. Maybe it's a request, or if it's a file you want to read. So what should you do in this case? What do you think? Let's say that I want to write a data to a readable stream, excuse me. Maybe it's a file, and this data is so huge. What should I do in that case? Well, what you should do is to first create a readable stream off of this data, be it a file or a request, anything. You first create a readable stream, and then when you create a readable stream, you're going to get the data in chunks of this size, this 16 kilobytes of size. So you get the data, and then you write to this writable stream. So this is what you should do if you have a huge amount of data and you want to write it somewhere. First create a readable stream, and then you write it. Right, so this is really how this writable stream and readable stream work. Now, what about duplex and transform? Now, they're just like these two. A duplex is just a stream that you could both write to and read from. So a writable stream and a readable stream, they only have one internal buffer, only one. But a duplex has two. A transform has two, one for reading and one for writing. So these are all the streams that we have in a nutshell. Now let's jump right into our code editor and try to use these streams, and let's see some interesting results. Let's first fix our problem with that memory issue. Alright, let's try to work ourselves through this problem by some of the basic things that we know. So first of all, I'm going to copy paste this code because we're going to have a new solution to this write many problem, and I'm just going to comment this portion of the code out. I'm also going to copy this include line. It's going to be the same, but still. Alright, So this is our stream object, that blue rectangle we talked about in the slides. So let's try to see what is happening here, and let's see how we can fix this memory issue problem. Now you might be thinking, is it possible to get the internal buffer of this stream? Well, it's not really recommended and it's not really documented in the Node.js documentation, so we're not going to do that. Instead, what we're going to do is to use two properties that we have available on the stream object that will indicate how much of that internal buffer is filled. So I'm going to comment the for loop out, and I'm going to just log these two properties. The first one is stream.writable high watermark value, actually writable high watermark, and this is the size of our internal buffer, which is by default 16 kilobytes. So if I run this code, I want to get that value that we talked about in the slides, 16,384 bytes. Now, it is possible to change that value, but you don't really need to do that in a lot of cases unless you are implementing your own streams, which is something that we're going to get into a little bit later in the video. Alright, so let's try to log another value, which is stream.writable length. Now, this value indicates how much of this buffer is filled. So if I log it, I should get 0 because I haven't called stream.write until this point. So let's try to write and then get that value again. So I'm going to say stream.write. Let's just write this. Okay, really simple. And let's log this writable length after this string. And actually, you know what? I'm not going to write a string to our stream because you are not limited to just writing strings to streams. You could write anything, any zeros and ones. You could write an image, a video file, anything. So what I want to do is to just first create a buffer out of the string and then write it. In that case, I think it will be easier for you to understand what's happening. So I want to create a buffer first, and I'm going to say buffer.from this, or actually just string. And then I'm going to write this buffer to my stream object. Now let's run this code. Alright, so this log, that is 0, we haven't wrote anything yet. But after we wrote this buffer to our stream, now our writable length is 6. And if you're wondering to know why is it 6, it's not because it's 6 characters. Well, actually yes, but it's more like that each character is represented using only 1 byte. So if I just log the buffer, so log buff, you can see that I have a buffer that has 1, 2, 3, 4, 5, 6. So this buffer's length is 6 bytes. I write this buffer to my stream, to that internal buffer, and now this writable length is 6. If I try to write some more things to this buffer, if I try to write the same thing but multiple times, if I save and run it again, now the writable length is 30. So what's happening at this point is that we're just pushing these buffers to that internal buffer, to this stream object. So we are gathering data, right? So you can imagine what's happening inside of this loop. We keep writing to this buffer and we keep increasing this writable length value. But the important part here is what happens when this writable length gets the same size as the writable high watermark value. So this is going to be 16 kilobyte. What will happen at that point? So what we need to do is to check and see what this write method returns. If it returns true, it means that we are safe to write more to our stream. It means that our internal buffer is not full yet. But if it does return false, it means that our internal buffer is now full and we should now wait for the stream to empty that data and do the final write, which is to write to our underlying resource, which in this case is just a file. So what I'm going to do right now is to, let me first zoom in a little bit and also comment out all the logs that I have. So I'm going to comment this for loop again and also this time end, and I'm going to remove all these writes. I'm also going to remove our writable length at this point because we know that it's 0. I'm going to keep the high watermark value to remind ourselves what this value is. And what I'm going to do right now is to create a buffer that has the same size as this high watermark value. So the way I can do that is to just say buffer.alloc and then specify size. Whatever size I specify here in bytes, now my buffer will have that exact same size. So this is how we allocate a buffer, how we create a buffer. This is one way of doing it. And you could also here specify an optional parameter which specifies how to fill this buffer. So if I just say character A, it means that fill all of my buffer with this character. Or you could specify a number or another buffer or actually nothing. So let's just do a quick recap on buffers. Let's create a buffer that has a size of 100 megabytes and fill it with this character A. Or actually just a number. Let's just say a number, maybe 1 or 10 actually. And I'm going to specify 100 megabytes. Now, if you want to convert between megabytes and bytes or kilobytes to bytes or whatever, just do a quick search on Google and that will pop up. So just say MB to bytes, for example. And here we get this converter on Google. So if I want to create a buffer that has a size of 100 megabytes, just say 100 here, and then I get that number in bytes. Now, if you're not familiar with this notation, this is how we specify big numbers in computers. It means 1 times 10 to the power of 8. So you could either specify this in your buffer to get 100 megabytes, or you could just specify it with those zeros. So you have to specify 8 zeros. 1, 2, 3, 1, 2, 3, 1, 2. Now I create a buffer and fill each byte with 10. Let's log this buffer and see how much memory usage we have. Now if I log it, you're going to see that we get these numbers. And I'm just going to write these here at the top in case you were confused. So 8 bits is 1 byte. And each bit is either a 1 or a 0. Now 1000 bytes is 1 kilobyte. And 1000 kilobytes is 1 megabyte. Alright? So if you want to create a buffer with the size of 100 megabytes, you have to work yourself through this chart. So 100 megabytes means 10 to the power of 2 times 10 to the power of 3 times 10 to the power of 3, which will be 10 to the power of 8. So 10 to the power of 8. And then you're going to get 100 megabytes. Or you could just use this converter here and convert between these values back and forth. All right. And one more point. In this buffer, when you log it, you're going to get these numbers in hexadecimal. And each hexadecimal value equals to 4 bits. So if I have this hexadecimal value of, let's say 1A, each number corresponds to 4 bits. So 1, 2, 3, 4, 1, 2, 3, 4. Now this is not the exact value. If you want to get the exact value, you could use a calculator or do it by hand, if you will. And you have to switch to a programmer calculator and just put 1A, and the value is 0001, 3 zeros and 1, and then 1010. Alright, so this is our buffer. Its size is 100 megabytes, and it's filled with this value, with 10. So 0A is 10. If you just put A and then switch to digits, you're going to get 10. So 8A in hexadecimal is equivalent to 10 in decimal format. Anyway, so let's create our buffer and take a look at our memory usage. We're logging it, and let me just put in a set interval function here at the end so that our process does not exit right after it's done. So now I'm going to run the application, and I want to take a look at the activity monitor, and sure enough, if you take a look at the memory usage, it's 100 megabytes. Around 12 megabytes is for the whole application, and this buffer is allocating 100 megabytes. And you notice that the memory usage jumped back to 16 megabytes, and it's just this garbage collector thing that Node.js does behind the scenes. Because we're not using this buffer anymore, Node.js will delete that. But if I run it one more time, you're going to see that the memory usage is now 100 megabytes. So whenever you're creating a buffer, you're allocating some amount of your memory to that buffer. And we have a warning here. Well, it says that we need to close the file, and it's actually right. We're creating the file here, but we're not closing it at the end, which is bad practice. So I'm just going to close the file here at the end once we're done. So file handle.close. All right, let's now create a buffer of that size of high watermark value and then write that to our stream. So I'm just going to specify this value, which is, should have it in our logs, which is 16,000 something. So I'm just going to paste it here. So I have created a buffer with this size. And now let's go ahead and write this buffer to our stream. So I'm just going to say stream.write buffer. And what will happen at this point is that because our internal buffer is now full, because we're creating this buffer that has the same size as that internal buffer, this function now will return false. So if I just log it, say console.log this, I think we still got that warning, but we're going to troubleshoot that later. So let's run it again, and now you can see that this value, this method returns false. If I try to create a buffer that has even 1 byte less than this value, so I change 4 to 3, now if I run it, this function now returns true. So the important point here is that we need to check every time this function returns false, we need to wait for it to get emptied. Otherwise, if we keep pushing to it, we are buffering that data, and what will happen is that we're going to get some back pressuring. So it's something that we're going to talk about. It's actually this thing that we're talking about right here. In our for loop, if you take a look, we'll keep writing to this buffer, to this stream, this buffer. So we keep writing this buffer to our stream even though we reach this high watermark value. And we're not letting the stream to empty itself. So we're having some back pressuring here, and we're not handling it quite well. We're putting a huge amount of pressure on this stream, on that internal buffer inside of this stream. So how could we let the stream empty itself? Now what we can do is to just listen for an event called a drain. And whenever this event happens, I can't type, right? Whenever this event happens, it means that the buffer is now emptied, that internal buffer is now emptied, and now we're safe to write more to that stream if we want. So let's say that we write this to our stream, and then let's write one more thing to our stream. And in this case, I'm gonna allocate a buffer that has a size of 1 byte. So now we get to this high watermark value. I'm just gonna fill it in this case with just character A, and let's write this one. So this first write call should return true, but the second one should return false, because now we reach this value, this high watermark value. So if I run it, I'll get a true and then a false. But because it's now false, the stream will now take some time to empty itself, and once it's done, it's going to emit this drain event. So if I just log something, we are now safe to write more. If we run it, we're gonna get, actually we haven't got that log. Actually, we're not getting this log because we are closing our file right after this code. So we reach this point and then we quickly close it, and that's it. We're not getting to this point. And when we close this file handle, we are actually also closing our stream. So let's comment this line again, and we're going to get back to this close afterwards because we have to talk about some of the other events like finish and so forth. But let's now focus on this drain event. Now if I run this again, now I'll get that log that says we are now safe to write more. So our first write returns true, second one returns false because at this point we completely fill that internal buffer, but now the stream will emit this drain event. If I don't do this, if I don't completely fill my internal buffer, and if I run this, I'm not going to get that log because, well, at this point my internal buffer is not full, so we don't need to wait for the drain event. So you should always wait for this drain event. If you don't, and if you just keep writing to that internal buffer, and if I log the stream.writeLength, writable length, this value should never exceed this value. So this is our high watermark value, and this is our writable length value. And as you can see, this is bigger than this one. You should never let this happen. Whenever this one returns false, you should immediately stop writing to it and instead wait for this drain event. Otherwise, you're going to buffer this data. And we saw what happens when we keep buffering something. If you just buffer something, if you just create a buffer, you're just immediately going to allocate some amount of memory. So you should never let this value get higher than this value. That is a bad practice. That's an awful practice. And you're going to have some memory issues, some performance issues, so do not ever let this happen. Always check for this value, and always, most importantly, check for what this stream.write method returns. If it returns false, you should just stop writing to it anymore. Wait for this drain event to happen, and once the event drain happens, it means that now you could move on ahead and write more to that stream. So if I just, at this point, write a couple more things to my stream, so I just write 1 byte to that stream, and if I just log this writable length value again, now what I'm going to see is I want to get 1 because now we emptied our buffer. So writable length, which indicates how much of our buffer is full, is now 1 because at this point we have completely emptied the buffer. We have wrote to this test.txt file, and now we could just move on ahead and write more to it. And we don't see anything here because this number, it doesn't mean that we're writing 10. If it was a character, it would mean the same thing. If this is confusing, you gotta learn more about buffers. Watch my video about buffers, but just to make it easier for you to understand, I'm going to change it to just an A. I have to scroll all the way down to get those A's, and these A's are these ones. But if I just change 10 to A, save, run a code, and open this up, I'm going to see a whole bunch of A's. Alright, so let's recap. This drain event happens when our internal buffer is full and when it's emptied. Alright? So if we do something silly, if we try to allocate a buffer, if we try to write to the stream a value that has the exact same size, we're going to get into some issues. Because in this case, we're writing again to our stream, but we're making it full again. So this code will eventually lead to the stream object to emit this drain event again, and then we're going to get into this callback, and it keeps happening in a loop. So if I run this, we're going to get a whole bunch of logs because this code keeps happening over and over again. The stream waits for that internal buffer to be completely emptied, and once it's done with that, it's going to emit this drain event. We're catching this drain event here and stream it on drain, and then whenever it happens, we're executing this callback. But in the callback, we're writing again to that stream. So this code will again emit another drain event, and this callback function will keep happening and happening over and over. So with this knowledge in place, now that you understand how draining works, and that you should never write to a stream once it's full, and you could find it out when stream.write returns false. Let's now go back to our loop and fix our problem. So I'm just going to first remove all these codes. Or actually, I'm just going to keep them for your reference later on. And let's now work in the for loop. So I'm going to uncomment the for loop out. And let's see what we can do here. So what we need to do is to check for this value. If it returns false, it means that we need to stop the loop. And then listen for the drain event. And then after the drain event happens in the callback function, we need to do something to continue on with this loop. So if you want, pause the video right now and give it a shot. It's now all about your JavaScript and programming skills. You need to stop the loop and then resume it if it's true. Actually, you need to resume it in that drain event. But anyway, you get the idea. See if you can do it. And if you can't, it's fine. I'm going to show you my solution in just a minute. All right. So what I'm going to do first is to, well, if we want to check for this value, so we need to have an if statement. And if this if statement is false, actually if this expression here returns false, so what we need to do is to just break out of this loop and then in that drain event do some stuff and somehow resume this loop again. So the way we can do it is to move this code inside of a function and also move this I outside of the scope of that function. So in that case, in the drain event, we could just call that function, and because we have our I value outside of the scope of that function, we could resume the loop. So we could create a new function here called write_many, and hopefully I'm not defining any other things with this variable. Well, nope, we're good. So this function will have this for loop inside of it. And we also need to define our I variable here outside of the scope of this function. So let I equal 0 and I less than 1,000,000 I++. And you know what, because we are defining this I variable outside, we could just change this for loop to a while loop. The logic will not be different at all. It's just instead of a for loop, it's now a while loop. And now what we need to do is to increment our I value here after we do a write. All right. And also I'm going to call this function right after it's defined. So write_many, and now we're good. Now this code is just like before. Nothing is really different. The only two things that are different is that we now have our I variable here outside of this function, and we also have this function which we're calling right after it's defined. Now in this case, what we can do is to just break out of this while loop if this returns false, and then in the drain listener, which we're going to define right here after this write_many, we could just call this function again. And what's going to happen is that we already have our I variable at that number that it was previously, so we'll just continue with the loop rather than just starting from scratch and start from I0 and then go all the way up. So let's now define our drain event. So I want to say stream.onDrain. So notice when we get to this point, it means that our internal buffer in the stream is now full. So we need to stop writing, and here we need to wait for the internal buffer to get emptied. So by the time that we get to the callback and we are executing the callback, we are now sure that our internal buffer is now empty. So what we can do is to just call that write_many function again, like so. And now we need to do our if statement check. So if stream.write_buff, if this returns false, so now if this expression returns false, we're just going to break, and that's it. Or because it's one line, I could just remove these curly brackets and do it in one line. So this should now be our solution, and it should work pretty okay. So let's now run our code and see if it works. So I'm just going to delete this text.txt file, and now I'm going to run this code. So node write many, and now we have our test file, which starts from 0 and goes all the way up to 6 nines here. So our code is working pretty okay, and if we take a look at our memory usage, let's try to run it a couple times. It's pretty fast, so we can't get the process. Well, we did for a couple of seconds, but the memory usage is around maybe 50 megabytes, right? So it's not 200, something that we saw previously. It's definitely not 200 because now we're doing a drain, but in our previous example here, memory usage was 200 megabytes. It was really awful. You should never do this. So we managed to reduce this number down maybe by 4 times, and let's also benchmark the code and see how long it takes. Notice we can't do this right here, because if we do, it's going to run sooner than some of these callback functions. So a good place that we can run this time end function is when our stream is done. So when we're done writing to this file, we want to emit an event and say that, all right, we're done writing, that's it. This is going to be our last callback function that we're going to write, and there it will be a good place to both call the time end function and also close our file handle. So the way we can do that is to check for this I variable and say if it's equal to the last number, which is going to be 6 nines, we're just going to end the stream. So let's do that here. So I'm going to say if I is equal to, and notice we can't just say I equals to 1 million, because we're not ever going to get to this point, because if I becomes 1 million, we're just going to break out of the loop. What we can do is to just say this variable but -1. So 6 nines. So if you subtract 1 out of 1 million, you're going to get this variable. So if we're in our last write, let me just put a comment here. This is our last write. And I'm also going to say if stream.write returns false, stop the loop. Okay. And for this one, I'm going to write resume our loop once our internal buffer is, once our stream's internal buffer is empty. All right. So now let's do our last write, which is going to be stream.end. This is another method that we have available on the stream object. So using write, you could just write, but when you call the end method, you're going to indicate that this is going to be my last write. So you could also specify a chunk, which I'm going to. So I'm going to specify that buffer, and this is pretty much it. Now, if we run this method on a stream, it means that we're done. If we try to write any more to that stream, like this, this is going to return an error. So when you run the end method, it means that you're done with the stream and you should no longer write any more to that stream. Now, this end method is also going to emit a finish event, which is something really useful that we can sometimes use. For example, in this case, we could, in that finish event, we could run our time end function and also close our file handle. So let's listen for that event. So stream.on finish. Then here, we're going to move our time end function and also close the file handle. Alright, now let's try this code and see how long it takes to run. So I'm gonna run the code, and well, looks like we have an error. Let's see what the error is. Right after end. Well, yeah, it's because we need to return this, because if its I is this, then we are calling this, and then we're moving to this right. So we are getting this error that says you should not write after end, which is something that we just talked about, right? So just return, and that's it. I think this should be pretty much it. Let's run it again. And yeah, it's right. So this function now takes around 300 milliseconds to run, which is the same number, I guess. Yeah, it's slightly the same thing. Maybe this one is a little bit faster, but we can't really say that much faster. It's just by maybe 2% or something like that. So not something that we really need to care about. Now, this code might be slightly slower, but notice that it's because our memory usage is not that big. So if you try to, maybe instead of a million, try to write 100 millions, or maybe a billion, I'm sure that this execution time is going to be slower than this one, because then you are having a huge memory issue. But also the most important point here is that our memory usage is now 200 megabytes, but here in this solution it's roughly around 50 megabytes. And this is going to be more significant if you increase this I variable. So you could now use maybe a billion, 10 billion, and you're still going to get a pretty good memory usage, somewhere around maybe 50 megabytes or 100 megabytes, really something really much lower than our previous code. Now, let's see how many times we are draining. So I'm just going to add a log here and say training. And let's count and see how many drains we get. What do you think the value will be? So let's run the code. And we're getting a lot of logs if I scroll all the way up. So let's try to count them, and the way we can do that is to just, one way we can do it is to just select all these text and do a copy and then paste it in our code editor. And now here you could take a look at the line number, which is 481. So it means that we drained our internal buffer, our stream, 400 times. Do you think this number makes sense? Well, the answer is yes. And you can get this number by doing a little bit of math. So let's get the file size of our test and see how many bytes we wrote to it. So it's 7 megabytes, but we don't care about that. We want the exact size. So I'm gonna right click on it and click on get info. And right here, you can see exactly how many bytes this file has, or this file size, but in bytes. So I'm going to copy this number, and I'm going to open up my calculator, and I'm going to switch to basic mode. So view basic, and I'm going to paste that number in. So this is exactly how many bytes we wrote to this test file, right? Now, if we divide this number by that high watermark value, by the size of the internal buffer, we should get to this number, 481. So let's get that value. I don't remember. Okay, here we have it in our terminal. So it's 16,300 and something. So I'm just going to copy this and paste it in my calculator. And now I'm going to hit the equal sign to see the result of this division. And sure enough, it's 481. Notice that we also have a remainder, which is expected. So in our last write, we are writing something to our file, but that chunk that we're writing is smaller than the size of the internal buffer. So we're not doing another drain. So we are writing 482 times, but we are draining 481 times. Because in the last time, we don't need to drain because the value is less than the internal buffer. And you know what? This could be kind of confusing because we're logging training,
but when we get to this point, we are done draining. So it should be drained, right? Because we're doing the draining before this event happens. So right before this event happens, the buffer is getting emptied. But once this event happens and we get to this callback function, at this point, we are done draining. So now we have our internal buffer completely emptied. So it should be drained, and then we could just do our writes again. If we try to log stream.readable length, here we should get 0. So if we just try to do it right here, it should be 0. But right before this event, it should be 16,000 something, size of that internal buffer. Or also it could be slightly higher than that, because maybe our last write that will fill the internal buffer could have a value that's slightly bigger than the amount of space that we have available in that internal buffer. So it could be just slightly bigger, but it's not something that we really care about, because it's just a couple of bytes, nothing really too crazy. All right, so at this point, we are pretty much done with the writable stream in Node, and we covered some of the most important things that you need to know about a writable stream, like the drain event, the end event, write, and that high watermark value. Let's now take a look at the Node.js documentation and try to do a quick recap there. And then we're going to move on to discussing the readable streams. So I'm going to open up my browser and just search for Node.js, and I'm going to go into the docs. And also notice that now we are using Node.js version 18. When we were starting out, I installed version 16. But now, at this point, Node.js has pushed another version out, version 18. So I also switched to Node version 18, which is something that I recommend you to do as well. Now, if you followed along with the course, you installed NVM. And if you have NVM installed, it's pretty easy to change your Node version. Now that we are on version 18, if you want to install another version, you just say nvm install 18 point whatever. Now, in your case, if you are on version 16 or something, just run this command, nvm install 18.12.1. At this point, this is the latest LTS version, but go to the Node.js docs to see what's the latest version of Node for you. And after you install the latest version, you just run nvm alias default 18 point that version that you just installed, and then your default Node version will change to that one. That's something that I just wanted to point out. If you're on version 16, it's still fine, I guess, but this is how we could change versions, and really it's not that difficult. So in the Node.js documentation, I'm going to open up the section that says stream, and here you could see that we have one API for stream consumers and one API for, if I scroll down, for stream implementers. Right now we're discussing the first one, stream consumers, but later in the video we're going to move on to the second API as well. Alright, so in the API for stream consumers, you notice that the first code that Node.js gives you is an example using the HTTP module. Now I just want to say this right now. In this video we're just going to stick with the FS module, but the concept is just the same thing. So if you understand how to work with streams in the file system module, if you then move to HTTP module or the net module or any other modules in Node that use the stream object, you're not going to have any problem whatsoever using those streams. For example, here, if you take a look, we have requested on data. Now this is something related to a readable stream, which is something that we're going to get into in just a minute. But this res object is a writable stream. So if you take a look, we are writing to this response object, and then at the end we are just calling the end method, which you could also specify a chunk to specify that this is going to be the last chunk to write to the response object. Or you could just not specify anything and indicate to say that this response is now done. So the same concept, the same things, they're both inheriting from the same stream module. So if you understand streams using file system, the rest will be easy. Now here's Writable Streams, and here are examples where in Node this writable stream is being used. One example that we looked at specifically in this video is FS write streams. But it's also used in the HTTP module
Zlib, crypto, TCP sockets, and the child processes standard in and standard out. In the FS module, we're reading and writing from files in HTTP and this TCP socket. We are reading and writing to our network card. And Zlib and crypto, we're just working with some data. In some cases, it could be a file or just something in memory. And child processes, and these process that standard error, standard out. Here we are talking to different processes. So you understand the concept using the FS module. You are understanding how to use streams in all the other modules. Now, first you could see the list of events that we have available on this stream.writable. Now, they are pretty self-explanatory. If you just read them, you'll understand what they do. Here it says this close event is emitted when the stream and any of its underlying resources, a file descriptor, for example, have been closed. So if let me just jump back into my code editor. So if we try to close this file handle, this stream is going to emit an event. So I'm just going to write it pretty quick. So stream.on close. And I'm just going to say stream was closed. And let's just also comment all these code out. You don't have to do this, I want to just demonstrate how this event works. So if I just close that file handle, so file handle.close, now the stream will emit this event, and we're going to get into this point. So let's run it pretty quick. So node write many, and sure enough, we get stream was closed. I want to back up. Okay. So you could just come here and read these different events, and they're really, really easy to understand. At least most of them. I got lost. Where were we? All right, here. So yeah, this is the close event. And also I just want to say, always read the description of these events and methods and properties before you use them, because it's really hard to memorize them. And in fact, you don't really have to memorize them because there's so much. Just come to these documentations and read them, and then you'll understand what they do. So you could sometimes find some interesting stuff here in the descriptions. Now here we talked about the train events, and this is the example that we wrote, writing 1 million times to something. Now in this case, it's not specifying the writer. The writer could be a stream that's off of a file, or it could be a response object or a request object or any other thing really. So let's see what else we have. We have the error event. Again, pretty self-explanatory. Just read it and you'll understand what they do. We have the finish event. We talked about it. This event will be emitted after we call the stream.end function. And also, all the data has been flushed to the underlying system. In our example, it means that it wrote to the file itself rather than keeping the data in memory. We also have pipe. Now we're going to talk about pipe and unpipe after we talk about the readable streams, so let's move on. Then we have cork. Now this is, if you run this, it's going to buffer all the data in memory, and it's not going to clear anything or do any final write, meaning writing to those internal resources. So sometimes it could be useful. Here we could see that the primary intent of this method is to accommodate a situation where we're writing very small chunks very rapidly, kind of like that for loop that we did previously. So you could make use of this one in some cases like these, but I don't know, I haven't really used cork, but if you want, go ahead, play around with it. It's not that hard to understand. It's actually super simple. When you write it, when you call this cork method, you're just not writing to that underlying resource anymore, and you're just buffering all the data in memory. And also you got to make sure to call the uncork function. Where is it? It's right here. Call this uncork method after you're done. We also have destroy, which again destroys the stream. And then you have some properties like writable.close. It's true if the close event has been emitted. So we can see that some of them are really easy to understand, and you need to actually come and read what these do whenever you want to work with streams. .end, we talked about it in great detail. Here it says calling stream.write after calling stream.end will raise an error, which is something that we saw. we also have a writable.set default encoding, which is really useful if you are just dealing with text, like a text file or an incoming request. But if you're dealing with other types of data that are not text, like an image, a video file, an application, anything that's not text, it's not really useful. Actually, it's not useful at all. I mean, you don't want to run this method on a stream that is dealing with an image file. If you do that, you're going to mess up your data. So only use this method if you are just dealing with text information. Then uncork, which is just like that cork, that corks means that it keeps buffering all the data. If you call this method, it will just stop doing that and flush all the data to an underlying resource and do one write. Then we have another property, which is writable.writable, which is true if it's safe to call that write method. And that means that if the stream is not destroyed, errored, or ended. We also have an experimental property here, which is writable aborted, which is indicating it returns whether the stream was destroyed or errored before the finish event. Again, easy to understand. Writable ended, writable corked, errored, finished, this high watermark value, length. Now this one could be quite interesting, writable need drain. And it's true if the stream's buffer is now full and the stream will now emit a drain event. So whenever we get to that point, this property will be true. And yeah, I guess this is pretty much it. And now here we're done with the writable section. And now we have to talk about the readable streams. So we're pretty much done with the writable streams. Now we're going to talk about the readable streams, and then we're also going to use these writable streams later in the video and also later in the course. This is a pretty important concept, and we're going to use this pretty much, I think, in every video from now on. We're going to have an example of streams, not in every single one of them, but definitely it's going to be highly used from now on in the course. All right, let's now talk about readable streams. So in a readable stream, we read possibly from a huge file and we get the data in chunks. So in a writable stream, we write, and in a readable stream, we read. All right, so let's see an example. Let me first clean up here. So I'm going to close this write many file, and I'm going to move all these files to a new folder. So I'm going to create a new folder and call it write-many. And I don't know if you guys have this des.txt file or not. I guess I was just experimenting. So I'm going to delete it, and I'm going to move my test.txt file and also my write-many.js file to this write-many folder. And now I'm going to create a new file, and actually a new folder, and I'm going to call it read-big, meaning that here now we're going to read from a file. So I'm going to create a new file, call it readbig.js. And what we're going to do is to read a file that we created using this write-many code. So we're going to create some huge files using this code, and then we're going to start to read them here in this file. So I want to first include the fs module. So const fs equals require node.fs/promises. And I want to create one of these immediately invoked functions. And here I'm going to first create my file handle object. So file handle read to indicate that we're going to read from this file. So wait fs.open. Now let's copy this file and paste it here in this readbig folder as well. So I'm going to paste it, and let's open this file first. So test.txt. The flag should be R because we are reading and we're not writing or appending or anything, we're just reading. And let's now create our stream. So const stream equals file handle read.create read stream. All right, so now this is a readable stream as opposed to a writable stream that we had before. So the way that we can consume data that will come to the stream is by adding an event listener on this stream, and the event is called data. And once the event happens, we're going to execute a callback function, and the first parameter, the only parameter that this function has, is a chunk. So we're going to get the data in this chunk. So let's just try to log it and see if we are getting these chunks. So console.log chunk. I keep doing this. I need a semicolon here so that my prettier works well. And now I'm going to open up my terminal, navigate to this read big folder, and I'm going to run the application. It's chunk and not chunks. And as you can see here, we are getting different logs. So we're getting the data of this file in different chunks. So I just add one more log and just say maybe add a divider like this and run it again. You're going to see that we're going to execute this function multiple times. So rather than getting the whole data, the whole 7.9 megabyte data in one chunk, which is going to occupy our whole memory, we're getting smaller, different chunks like this. Now, one thing that's different, if you log the length, it's not going to be that default 16 kilobytes. Rather, it's 65 kilobytes. So if you use this create read stream to create a readable stream off of a file, the default high watermark value is going to be 65 kilobytes. So if you go to the Node.js documentation in the FS module, if I can find it here, file system, and if you just search for create read stream, which is here, if you take a look at the options, you could see that high watermark is defaulted to 64 kilobytes. So here it says, unlike the 16 kilobyte, which is the default for a stream.readable, this one uses a high watermark, which is 64 kilobytes. Now we could change this by specifying the high watermark value here. So high watermark, and whatever you specify here is going to be the size of your internal buffer. So if I just say maybe 400 bytes, and if I run the code again, so node read back, now you can see that my chunks are coming in length of 400 bytes. But I'm going to change it back to 64 times 1024, which is 64 kilobytes. Alright, so this is how a readable stream works. You just create your stream, and then you add the data event handler on that stream, and then you're going to get the data. Now, a readable stream could have 3 different states. When you first create your stream, you're not reading anything. As soon as you add this data event, what's going to happen is that the stream will start to read from that internal resource, and then you're going to get the data in chunks. If I remove this event, then what's going to happen is that the stream will be in a paused state and will no longer give me any data. And also I have one more event available on the stream, which is stream.onEnd. And if I call that, the callback function will be executed when we are done reading that source. Now let's try to read all the file and then write these chunks to another file. And let's see if we are getting the exact same file. So let's try to create another file here, and I'm going to call it dest.txt. And using a writable stream, I'm going to write these chunks to that destination. And I'm also going to change the name of this test to source to make it more clear what we're doing. So file handle read is going to be source.txt, and I'm going to create another one. So const file handle write equals await fs.open dest.txt, and the flag should be write because we are going to write. So the flag should be W. And I'm going to create my next stream. So I'm going to first name it to stream read, and I'm going to create the second stream and call it stream write. So file handle write dot create write stream, and now that we have our Readable Stream, I'm just going to write to it. So stream.write that chunk. So let's first see if we are getting the file. So our desk.txt file right now is empty. Our source starts from 0 and it goes up to 6 nines. And the file size should be, if I reveal it in my Finder, file size is 7.9 megabytes. So let's run this code, and I also need to use this here, and this should be stream write.write. All right. So if I run this code, well, it looks like it ran without an error, and if I take a look at my destination file, well, all is good. And let's also check the file sizes to make sure that we're not losing any chunks. And no, we're not. So both of them have the exact same size, as you can see here. But notice that this is not something that you should do. You shouldn't just write. Now, typically hard drives have a higher read speed comparing to a write speed. So here we're having some back pressuring. We're getting a huge amount of data, or we're not getting a chance to write them. So Node.js will keep buffering the data, just like we saw previously in our for loop, right? So our memory usage will be really high using this solution. So we need to use that drain event and pause and resume reading from the stream. Now, to demonstrate how much this pressure is, let's try to create a very big file using this write mini code and try to read that and do the same thing and benchmark our code. So I'm going to change this. And actually, you know what? I'm going to create a variable for this value because we keep changing it. So I'm going to say const number of writes. And right now it's 1 million, so 16 zeros. And I'm going to use this here and just say -1. So now here we're writing 1 million times. But let's change it to 10 million times to get a bigger file. So I'm going to run this. So node, I have to first go into that directory and node write mini. It will take a while, possibly a couple of seconds. Yeah, it took 2 seconds. But now let me take a look and see how big the file is. The file is now 90 megabytes. So now let's try to do this again, but instead of using that small file, try to use this test.txt file, which is quite big. So I'm going to copy it, and I'm going to paste it, and I'm going to remove, I tried to open it, so now my computer is freezed, because it's quite big, it's 90 megabytes, and if you try to open it, what is happening is that you're trying to move it all to your memory, and that's why it's going to be stuck. So I have to, well, I guess I had to open my code editor, so be careful not to open this test.txt file. So now I'm going to delete that source and change the name to source.txt. So now we have a quite big file here. Size is 90 megabytes. So let's try to do the same thing, but let's also take a look at our memory usage. So I'm going to open up my activity monitor and search for Node here, and let's run the code. So I'm going to navigate to that folder and run the application. Well, looks like that it was quite successful and was quite fast actually. Let's see if we are doing the copy correctly. So I'm going to reveal in Finder, and yep, we are. So the reason is actually we're not doing that many writes comparing to that for loop. That the for loop took a little while here to complete, and the reason is we're writing in very small chunks. Now each chunk is possibly just a couple of bytes, maybe 5 bytes, but here our chunks are very big. They're 64 kilobytes. So we're doing a very low amount of writes, but still we are having that memory pressure. Now, if I try to create a very big file, so this is right now 10 million. Let's try to add in 2 more zeros to it. And what's the number right now? So it's a million, so it's 1 billion. So let's try to write 1 billion to that file and get a very big file, a gigantic file. and try to do this again. So I'm going to save, and I'm going to do that whole process again. And this is now going to take a while to complete. So I'm now going to fast forward this video. Alright, it's been a while. I have been waiting for like 2 minutes. So the CPU time of this process is now 2 minutes. And well, we're writing it so many times. So it's really going to take a couple minutes to complete. But the good thing is now you can really see the power of the streams. My memory usage is really consistent at only 50 megabytes. So it's pretty good and it's quite fast. I'm creating a huge file. I don't know how big the file will be, but if I go to my disk, so far the process has written 7 gigabytes of data to my disk. So the file is probably going to be like, I don't know, maybe 10 gigabytes or something around that number. So it's going to be quite huge, and we're writing 1 trillion times to a file. So you can see how powerful streams are, and nothing is really lagging. CPU is only at 100%. It's not, well, 100 is a lot, but I'm only using one of my cores, and everything in my computer is just working as expected. My computer is not slowed down, my memory usage hasn't jumped up to something really crazy, and everything is just working as expected. So let's wait more for this process to finish. Alright, so now we're done, and you can see that the code took 5 minutes to complete, which I know is a lot, but well, we're writing a billion times, so it's expected. It's definitely going to be huge. Now let's take a look at the file size. We're gonna really be careful not to click on it accidentally and try to open it. Now we can see that the file size is 10 gigabytes, which is a lot of data. Now let's try to move this file to this read big folder and try to do this process again, but using this file. So I'm going to change its name to maybe text gigantic. So a very huge file, and I'm going to delete this source and now move this file over to that read big. Alright, I accidentally clicked on it. I guess after I moved it, it tried to open it, and my code editor just crashed. So I had to pause the video for a sec there. So let's try this out. So the source will be text-gigantic, and this is going to be my destination. I'm gonna save, and let's try this. I'm not even sure if it's going to work. I think we are going to crash. So let's see. I'm first going to open up my activity monitor and switch to the memory tab, and now I'm going to run the code. So let's see what is going to happen. So I'm going to run it. That was quite intense, and if you take a look at my memory pressure, it jumped all the way up. I mean, my computer just froze. I couldn't even move my mouse. Hopefully it didn't tamper with my recording. I don't know, maybe it did. I'm going to remove it in the editing later if it did. But you can see that it did not work. So it just crashed. My memory usage really jumped up to 1 gigabyte, and I think it kept going, and my computer just froze. But we managed to copy 7 gigabytes of the data. So definitely not a good option to do it this way. So what I'm going to do right now is to use that training and try to optimize this code. So here's how we can do it. Now remember, we said that this function will return false if our buffer is full. And if it's false, you should never ever write to this stream again. So if it's false, you have to wait for the stream, let it drain, let it empty the buffer, let it do the write, and then you're free to write again. So I'm going to say if this returns false, in my code, I'm going to pause the stream. So I'm going to say stream read dot pause. So if our buffer is full and this stream needs some time to drain itself, while it's happening, I'm going to pause the read stream. So it means that we're not going to get any more data, and we're just going to pause. And I'm going to add the drain event right here. So stream write dot on drain. Now here, what we're going to do is to just simply resume the read stream. So I'm going to say stream read dot resume. And this is another method that we have available on a read stream. So using pause, you could change the mode of your read stream to a paused state. So it's no longer giving you data. It's no longer reading from the source. It's now paused. But when you resume it, it's going to resume. It's going to start from where it was paused and then start to read the data again and give you the chunks. All right, so now let's try this code and see if we could get the copy successfully. So I'm going to save. I'm going to delete the destination file and I'm going to run it again. I'm also going to monitor it using my activity monitor. So let's see if we could do it successfully. So I'm going to run it. Now, looks like we're doing the copy. If you take a look, our memory usage is fairly low at only 30 megabytes. And if you go to the disk, you can see that we're writing 90 gigabytes. So it's pretty much done. If it gets to 10, it means that we're done. And yep, we're done. So the process was ended successfully and we managed to copy the file. Let's also check the file sizes and see if we are getting the right numbers. So my destination is 10 gigabytes and the source is also 10 gigabytes. So we're getting the exact copy. So if you take a look at the bytes, you could see that they have the exact number of bytes. The end is 400 bytes, 411 bytes, and here it's also 411 bytes. So we're not losing even 1 byte in this copy operation. And you can see that it was very, very fast. It only took a couple of seconds. And also our memory usage was extremely low. I think it was only 30 megabytes. I'm not sure if it got higher than 30 megabytes, but it was at that number. Way, way better than that 1 gigabyte of memory usage that we got. My computer just freezed, but now nothing really happens. I mean, if you try to write this code, if you create a file that's like 100 gigabytes in size, so instead of writing 1 trillion times, maybe write thousands of trillions of times, and then try to do this again, you could just let it happen in the background and then continue on with the rest of your day. So you could let this application run and try to copy a file that's 100 terabytes and then just do your daily things. Maybe check the news, check your emails. Nothing is going to be slowed down that much. So this is pretty good. And you could see how streams could be very powerful. Now here we're just dealing with files, but you can imagine that these files could be requests, or they could be messages that you're trying to send to another process, or they could be something that is coming out of your database. So you could really easily deal with huge amounts of data. I mean huge, really terabytes of data, hundreds of gigabytes, and nothing is really going to be that bad. So actually it's going to be really good. Yeah, that's right, your CPU usage will be 100%, but that's fine, that's what you want. The point is to keep that memory usage as low as you possibly can. Now, with this in place, let's also try to do something a bit fancier. So what I'm going to do is to, as we're reading these chunks, let's try to extract only some values. So let's try to only extract maybe prime numbers or even numbers. And instead of writing the whole chunk, only write those numbers.
So if you take a look at this text gigantic, now I can't open it because my Visual Studio Code is going to crash, but if we try to take a look at the content but using a stream, so what we can do is to just try to open this file, but just like a stream, just like what we did. So we need to move one portion at a time into our memory. Now if you use the cat command, it's just like that. It's going to open a file, but using a stream. So I'm going to say cat text gigantic just to take a look at some of the numbers that we have. And as you can see, my computer is not crashed. I'm not slowing down. It's just everything is just working as normal, and this application is also working for itself in the background. So we're moving one chunk at a time in our memory and then logging it, so we're not having any memory issues here. Whereas if we try to open it using Visual Studio Code, it's going to crash because it's going to move it all into your memory. And that is not really going to work in this case because the file is huge. Now I want to hit Control-C and stop this process. And as you can see, we have quite a lot of numbers. Well, we have 1 billion numbers here, and we counted until 100 million, around 100 million.
So what we need to do is just read them just like here, one chunk at a time, but only extract even numbers. Only write these even numbers to our destination. So we don't care about odd numbers, and we're going to dismiss them. We only care about even numbers, and the way we can find out if a number is even or not, you just get the remainder by 2. If it's 0, it's even, otherwise it's odd. So the total number of numbers that we're going to have in this dest file, which will only have even numbers, is going to be, I think, 1 billion divided by 2, because we have an even number every other number, right? So if you divide all the numbers by 2, you should get how many even numbers you should have. So let's try this out. So I'm going to first, let's first log the chunk and convert it into a string. So these chunks are now in zeros and ones, so I'm going to first convert them into a string using a character encoding. So I'm going to say chunk.toString, and the character encoding that I'm going to use is UTF-8, which is by default, but I'm going to specify it nonetheless. And UTF-8 means that each character will be represented using only 8 bits. So each one of these characters, maybe a 3, maybe a space, maybe another space, maybe a tab, or maybe a new line character, they will all be represented using only 8 bits. So 8 zeros and ones, like this. So each character corresponds to this many bits, just 8 bits. So I'm going to first convert it into this, and also I'm going to split by a space, because I want to convert each chunk into an array and have each number as its own individual element. So I'm going to say .split space, and the way split works is like this. So let me show it to you pretty quick. So if I create an array, so let array equals, actually I first have to create a string, equals maybe 1, 2, 3, 4, 5, and if I say str.split, and you could split by any character that you want. If we split by comma, we're going to get an array 1, 2, 3, 4, 5. We also have some spaces here which we need to count for. Now you could remove these spaces by something like this. So if you say maybe string equals a space and then a number and then another couple of space and then end. Now if you just run the trim function on it like so, it's going to remove all the spaces before and after it. So we're going to use these two methods to populate our array. So I'm going to first split by this y space, and let's just log this and see if we are getting the right number. So I'm going to say const numbers equals this and just log numbers. All right. Now I'm going to run this code. Alright, so we're going to need all the numbers, but let's just hit Control-C and exit because we don't need to take a look at all of them. But now, as you can see, it's not really working as expected. We've got some of these empty spaces, and wait, what does this do here? So it's not really working as we want it. And if you take a look here, well, all these numbers are correct, right? But the number that starts at the beginning of each array is not really correct. So let's first try to account for these empty strings. Let's see what's going to happen if we try to split by 2 spaces. I think, yeah, now we're getting the numbers correctly. Because if you open the file, we are using 2 spaces to separate the numbers, not 1. That's my mistake. So we should split by 2 spaces and not 1. If we take a look at the right many functions, we are here, we're putting 1 space and then another space and then our number. So the next number will have another space at the beginning and then its whole number. And each character, so 1 character, and this number is going to be a couple characters, and then 1 character at the end is going to be represented using 8 bits or 1 byte. So 8 bits is equal to 1 byte. Right, so now we have our numbers, but notice again that still we have some problems here at the beginning of some of the arrays. Here we have a 0, which is definitely not expected. Let me also take a look at the first array, so I'm going to run and quickly exit, and nope, we couldn't get it. But you could see that all the first elements are not correct. So we need to somehow fix these first numbers. So if we do that, if we fix the first elements of all these arrays, or maybe possibly the last elements, because we can't take a look here, right? And we could try to log it by saying numbers, so numbers dot length -1, and this way we could take a look at all the numbers. So let's also try to log them like this. So these numbers should be in order. If not, it means that we have a problem. And as you can see, we definitely have a problem, and it's not really expected. Okay, so this is the one element before the last element of our array, and this is our last element, right? And as you can see, all the last elements, well, this one is correct, but most of them are not correct. So if we could fix this and somehow get our first elements and last elements correctly, then what we're going to end up with is an array of all the numbers that we need, right? And then all we need to do is to just loop through each array, extract these values, convert them to a number, and then check whether or not they're even. If they are, we're going to write them to our stream. If not, we're just going to dismiss them. So let's first try to fix this issue with these starting and ending numbers. So let me now jump into my whiteboard and show you what is really happening here. Alright, so we're getting our numbers in this format. So we have our first array, and our first number is 0, goes 1, 2, 3, and all the way to a last number, which we could calculate if we wanted to, because we have the file, we have the size of our buffer, and we also know that each character is represented using 8 bits, so we could calculate what the last number would be. But I'm just going to say something randomly, so maybe 32,000 and then 182. But notice that this will not be the case because we're getting the data in chunks. So we could maybe get the first two digits, first two characters, maybe we could get 32, and then we're not going to get the 8182. We're going to get that in the next chunk, right? So we're going to have a problem here. Now if you take a look at the next array, now this next array, because we didn't get the last 3 digits in the first array, we're going to get it right here. So we're going to lose some digits, and we're going to get 182, and then we're going to move forward with our array. And also here we have a problem because we have some lost characters. So the last element of this array also is going to be maybe 62,000 and then some lost characters. So we're going to have a problem here as well. And then next array, just like before, we're going to have a problem at the beginning and also at the end. Now, we could also not have a problem. We could get the last number, but completely complete and without any lost characters. But notice that it will rarely happen. In a lot of cases, we're going to have some lost digits at the end of the last elements of an array, and also at the beginning of the first elements of an array, like here and like here. Now, the last array, our first element again is going to have some lost digits, and we're going to have a problem here. But for the last elements, we're not going to have a problem, right? So imagine that we're dealing with that first file that was 7.9 megabytes, and our last number was 6 nines, so we were writing 1 million times. Now, the last array is not going to have any problems, right? Because we're not splitting, we're just getting all of the end of the data in just one chunk. So our last element is just going to be completely okay. Just like the first elements of our first array, that is completely okay, the last elements also of our last array is totally fine, and we don't have to do anything about it. So what we need to do is to somehow manage these missing characters. Now, one thing that we can do is to just get the last element of the chunk that we're dealing with, and then append this last part to the first element of the next chunk that we're going to get. And we're going to see how we can do this. Now, to really understand why we can do this and how actually we can do this, let's first try to talk a little bit about binary. So keep this in mind, all right? Just gonna put it here at the right bottom of my screen. Now, let's say that this is our file. That first file was 7.9 megabytes, and we were writing 1 million times. So we have a huge amount of data here. Now, if you get the file size, it is 7.9 megabytes, right? And if you get the exact file size, if you just right-click and click on Get Info or Properties if you're on Windows, or any other way that you can get the exact file size, now I have it opened up on my Mac right here. So it's 7,000,892 and then 693 bytes. So this is exactly how many bytes we have in our file. Now, if you multiply this number by 8, you're going to get the number of but in bits. So if you do the calculation, so 7,892,693 times 8, you're going to get the number but in bits, because 1 byte is 8 bits. So the number is roughly around 63 million. I'm not going to write all the number, but I'm just going to say roughly 63 million bits. All right, so we have around 63 zeros and ones in this file right here, in our file that we created. Now let me just say this because I know some of you might just forget it. So 1 byte is equal to 8 bits, right? And also, each hexadecimal character is represented using 4 bits. So I'm just going to put down 4 zeros. Now it could be 4 zeros or 4 ones or any combination of that, but one hexadecimal number is equal to 4 bits. Each hexadecimal number is representing 4 bits. Now, the character encoding that we're using is UTF-8. Now, this 8 here means that we're representing each character using 8 bits. So, UTF-8 means each character, so one character is representing using only 8 bits. So we could have 8 zeros and ones. Now I'm just going to again put down 8 zeros, but it could be 8 zeros or ones or any combination of that again. So also keep this in mind. I'm just going to put it right here. All right. So now, the important point to take here is let's take a look at one JavaScript array. So let's say that this is our array. We have 1, 2, 3, and that's it. So this is our first index, which is 0, and our second element, which its index is 1, and then the last element, which its index is 2. So this is a typical array. Now, a buffer is just like this. Now, a buffer is a unit 8 array. It's a subclass of a unit 8 array. It means that if it is our buffer, each element of our buffer holds 8 bits. I'm just going to put down 8 zeros. So this is our first element of our buffer. And then the second element is just like before. Now, in this case, I'm just going to say maybe 001 or 0010. So let's say that we have a buffer that only holds 2 elements. So it only has 16 bits or 2 bytes. So here we have a 2-byte array. Now the chunks that we're getting are 64 kilobytes or 64,000 bytes. All right, so 64, I don't remember what the number was exactly, but I'm just going to say 64,000 bytes. So we're getting the chunks and these values. But let's say that we have a buffer that is only 2 bytes, right? So say we only have this buffer, and let's see how this buffer is representing our data. So as we said, each element of the buffer holds 8 bits. So this is our first index, or our 0 index, and this is our 1 index. So index 1 corresponds to the second element, index 0 corresponds to the first element. Now if you try to log the buffer in, you're not going to get the values like this in zeros and ones. For the sake of simplicity and so that you could easily look at the data, they are represented using hexadecimal numbers. And we said before that each hexadecimal character represents 4 bits. So this 4 will be 0, 0 because we have 8 zeros, and each one of these will be a 0 in hexadecimal numbers. Now the first one is quite different. So this number, if you do it on a calculator, on a programming calculator, you're going to get 1 and then 2. So this is how you will see the buffer if you try to log it onto your screen. Now you could do these conversions using a programming calculator or just using math. If you learn how to do it using math, I guess it'll improve your understanding of binary numbers and binary data and all of this stuff, but you don't really have to. You could just use a programming calculator and the rest will be easy. Right, so this is how we are getting our buffers. Now I want you to really notice something here. We are getting data in different buffers, and these buffers have this much size. So we're doing some splittings, but we're not doing the splits maybe at here, right? This does not work. We're splitting maybe at here or maybe at here. Now if we take a look at our array, we cannot split at half of 1. This doesn't work, right? It just doesn't make sense. You cannot say split my array at index 1.5, right? You can't say that. You could just split at concrete numbers. Maybe you could split at 0, you could split at 1, you could split at 2. You cannot split at 2.5. Same is exactly true when you're dealing with buffers. You could split at index 0 or index 1, but you cannot split at maybe 1.5. So you cannot get one of this elements in one buffer and then another one in another buffer. If you convert this into a unit 4 array and make it so that each element of the buffer represents only 4 bits rather than 8 bits, then you can do that. You can split at maybe here. But you first have to convert it into a 4-bit array like this, and then you could do those splits, right? So here, this is a unit 4, meaning that each element of this buffer is represented using only 4 bits. But here it's a unit 8 array. It means that each element of the buffer is represented using 8 bits. Now, something to keep in mind here is we talked about this UTF-8, and we said that in UTF-8, each character is 8 bits. Now, what's really neat here is that in our buffer, because each element holds 8 bits, it means that each element of our buffer corresponds to 1 character, right? So in UTF-8, you can have maybe any characters, really. You can have numbers, so 1, 2, so many numbers, and you can have letters, so maybe A, B, you could have them capitalized or lowercase, it doesn't matter. So many different characters, millions of characters, and also you could hold some special characters, like maybe a space, or a new line character, or a tab character. So if you put this character in your file, it indicates that you need to go to the next line. It's just like an enter. So if you hit enter in your text editor, you're actually putting a new character into your file. Your text editor will not show slash and then n, will just show a new line. But again, the neat thing is that each character, now in our file we only have letters and spaces, but each one of these are held in one element of a buffer. So when we are splitting and we're getting the data in different chunks, we are splitting by characters. So if this is maybe one element, if we are at this point, maybe 22, and then 3, 4, and then some numbers before it and after it, we cannot split this 3 in half. It just doesn't work. But we could split at this location, and we could split at this location as well. So I really want to make this extra clear that you cannot split maybe 4 in half. You could have done this if you were representing a buffer using 4 bits rather than 8 bits, and then you were using UTF-8. Then in that case, well, sure, you could maybe do something to get half of the data of this character in one buffer and then half in another buffer, which is really unpractical, and then you would have to do a lot of work to add these numbers together. But because we're representing each character using only 8 bits and we're using UTF-8, each element of our buffer is only one character, and we're splitting add elements just like an array. We cannot split add half of an index or a quarter of an index. We're just splitting at each index. All right, so now that we know this, let's take a look back again at our array. Let me also erase these. And let me try to make it a bit bigger. All right. So what we need to do is to first find out where we have a split. So here we have a split. So what we want to do is to put the split in a variable. So maybe we could define a variable called split and save that variable in it. So in this case, it's going to be 32. We're not getting 182, we're getting it in our next chunk. And then when we are moving to our next array, so we're getting the next chunk, we check whether or not this number is correct. And we could do that by adding 1 to it. And if we add 1 to it, we're going to get the next element. If we get the next element, it means that we're not having any splitting issues. We're getting the number completely. But if we add 1 to it and then we don't get the next element, it means that we have a split issue. So what we're going to do is we're going to take this 182. This is the first element of that, our second chunk. So 182. And we're going to add that split value to it, which is 32. And we're going to do this in a string and not a number, right? So we're going to get 32182. So we're going to get our complete number. So this is what we have to do. We have to check the end of the arrays if they're not complete, and then if we subtract 1 from the end of the elements, if we subtract 1 and get the element before it, it means that we are not having a splitting issue. But if we subtract 1 and we don't get the elements 1 after it, before it, it means that we have a splitting issue. So we have to save the last elements in a variable, maybe called split, and then in our next array do the check and see if we are having a splitting issue. If we do, we're just going to add these two numbers together and we're going to get the correct number. So this is how we can deal with those numbers that are not complete. This is how we can attach them together and then get the right numbers. And then when we do get the right numbers, we're just going to convert them into a number and then do our checks. Maybe check whether or not the number is even and then write it, or maybe check if the number is prime or anything. We could just do anything that we want. But the point is we're getting the numbers as we want them. All right, so let's now implement this in code. So what we can do is to just do a quick check. So I'm going to remove these lines, and right here I want to say if the last number is not equal to the number before it in each chunk that we get, it means that we're having a splitting issue. So if numbers at length -2, now this will give us the last number before the last element of an array. So if I add 1 to it, and if I don't get the last number, numbers.length -1, now if this returns false, then it means that we're having a splitting issue. Or if it returns true, actually. because we're doing not equal. Now, these numbers that we're getting are actually strings, so we need to convert them to a number as well. So like this. You could just use this number constructor to convert any string into a number. So if I say number, maybe this string, it's going to give me a number. So if I add 1 to it, it's going to be this. Now if we just try to do the same thing but define a string and you try to add 1 to the string, it's not going to work. You're just appending 1 at the end of the string. But if you first convert it into a number and then add 1, you're adding it to that number, but you know, correct math. So if it is the case, what we're going to do is we're going to pop the last element. So we're going to remove the last element of our current chunk and save it into a variable. So I'm going to define a variable here, and I'm going to call it split. It's going to be initialized to an empty string. Now, if this is the case, I'm going to say split equals numbers.pop. Now, if you run this .pop method will remove the last element of an array. This is our array 1, 2, 3. If I say array.pop, it's going to give me the last element, and it's also going to remove that last element off of that array. So I'm going to use this method to remove that last element and save it into my split variable. All right. So now using this, we're taking care of the last elements. Now let's take care of the first elements. So I want to say if numbers, the first element of the number is not equal to the element after it minus 1. So numbers 1 minus 1. If this is not the case, and I also need to convert them into a number like this, now if this is not the case, we want to do a check. Say if we do have our splits from the previous chunk, we're just going to say that numbers, the first element of our array, we're just going to replace it with our split, and I'm also going to run the trim function on it. So with our split plus the first number, and also the trim function. We might not need it, but just in case. So now at this point, we have our numbers exactly as we need them. So let's just try to log the numbers. So log numbers. So, and actually we're not getting the numbers correctly, and well, it's because we need to change the order of these two if statements. So we need to cut this and paste it here. So because we're checking the split from the previous chunk and not the current chunk, so if I put this after this if statement, what's going to happen is that I'm going to update the split with that current chunk, which is not something that we want. We want to check the split from our previous run, and if that's the case, we're going to do our splitting. Actually, we're just going to add them together and replace the first elements. Now let's try it again. And now in this case, we are getting the arrays correctly. And as you can see, this number is exactly 1 before the next number. Also notice that here we have a space, but we're doing the trimming. Now, these cases are because the numbers are correct in the first place. So we're not doing this check. So this will not return. We're not getting to this point, and therefore we're not really adding anything to them because they are already correct and we don't have to correct them. But these numbers are the ones that we have actually corrected. So here we have another space. It means that this number was correct before we even got to that point. Alright, now let's also try to take a look at the last two elements and see if they are correct. And I guess these trims are redundant. If that's the case, it would be better to remove them because we're doing 2 less operations and we're also dealing with a huge amount of data, so doing 2 less operations could save us some good amount of time. So I leave this up to you to figure out whether or not these trims are redundant or not. If they're redundant, just remove them, we don't need them, but I'm gonna leave them just in case. All right, so now our numbers are exactly correct. So what we can do at this point is to just loop over these numbers and only write the even ones out to our stream. So let's try to do that. So I'm going to say numbers.forEach, and this for each will run, and in the callback we're going to get each number. So I'm going to first convert the number into a number because this number is now a string. If you take a look, this is a string, so we have to convert it into a JavaScript number first, and we can do that using this number. So number, lots of numbers. Hope I don't say number another time. Now we say if n, if its remainder by 2 is equal to 0, it means that it's an odd number. Actually, it means that it's an even number. So we're going to write that to this string. So I'm going to cut this and paste it here. Now, rather than trying to write the whole chunk, we write space plus n plus another space. And if it returns false, it means that we need to drain. So we're going to stop reading from our stream and then let it drain. And then once the draining is done, we're going to resume reading again from that file. So let's try this. So I'm going to, well, actually, let's try it with a very simple file because we're going to need to open it and check it out. So I'm going to switch to that right folder, and instead of writing a billion times, actually I had already done it before I recorded this portion of the video, but you could go on ahead and do it and change this number to 1,000,000 and then run it, and then you're going to get this test.txt file, which just like before should start from 0 and ends at 6 nines. So let's try to copy this file and paste it in our readbeg folder, and let's go with that file. So instead of reading the whole text gigantic, I'm just going to read the normal text. And the name is test, so let's change it to text dash small. So text dash small. So this is our big file, very big file, 10 gigabytes, and this is our tiny file, only 7 megabytes. So let's run this and then check our destination test.txt file and see if we are getting all the even numbers out. So I'm gonna run the code, node readbeg, and it took a second, and let's now take a look at our test.txt file. And as you can see here, we're getting all the even numbers, and I doubt that we are missing even one number. So we're getting all the numbers. Last numbers should be 5 nines and then an 8, and yep, we get the number, and then one before it is the even number before this number, and so on and so forth. Now the file size should be roughly half of the text small file, which is actually the case. So this is, if you round it up, it's 4 megabytes, and if you round this up, it's 8 megabytes. So it's half the size of this text small. So we're getting the even numbers correctly. Cool. Now if you want, you could also just get the numbers that are divisible by 10, just like this. Run it again, we'll run pretty quick, and our destination, we're getting all the numbers that are divisible by 10, meaning they have a 0 at the end of them. All right, perfect. So this code is now working pretty good. Now this isn't the testing that you should do. If you want to do this, just don't try to look at it and say, okay, it looks good, so the code works fine. You gotta do some testing. So maybe try to go over this file one element at a time and then add 10 to each one of them. You should get the next element. And if you don't, it means that we are missing a number, or maybe something else, or maybe we have some logic errors. So I encourage you to, whenever you're doing this in production and you want to ship something to the real users, really try to do so many testing. Don't leave your code up and say, all right, it looks fine, and that's it, I'm gonna go with this. Absolutely not. You should do some rigorous testing and really make sure that you're getting the right numbers. Now, we're not going to do this in this video, but if you want, you can do that. And for example, if we were getting the even numbers, just get each number, add 2 to it, and then you should get the next element. All right, so now we're pretty much done with a readable stream. You could just get the data in chunks, and then you could process the data and then maybe write it or just read it. It's up to you. Now, instead of just reading it, we could have, maybe added to our database or something like that. It's really up to what you want to do. The point is, you can read a huge file. Now, if you try to do this with that text gigantic, it will work with no issues. In fact, let's give it one more shot. So text gigantic, and if I run it, now it will take a while because we're doing some operations here. Now, this is where I told you if you try to optimize your code, maybe remove these trims or anything else, maybe find something that you could convert numbers that's faster than this number constructor. Now, I don't know if there is one. I tried one of them, and this one came out to be the fastest, but there might be some ones that are even faster. So if you could just optimize this code maybe a little bit, it will really add up and become something pretty big. You could save maybe minutes, seconds. It could be a huge time saver if you just try to optimize even a couple of microseconds or milliseconds. It's really going to be a lot. But if you take a look at the activity monitor, you can see that our memory is only 50 megabytes. So we're doing a whole lot of operations. Not a whole lot, this isn't really a lot, but we're doing some operations and we're doing a lot of readings and writings. So if we go to disk, you can see that bytes read is 8 gigabytes and bytes write is 800. Now, if this bytes read gets to 10, we are done because our file is 10 gigabytes. So I guess I have to wait just a couple more seconds and that's it. But the point is, our memory is pretty good, only 50 megabytes, and we're reading a file that's 10 gigabytes. And I guess we're done now. Yep, we're done. So if you take a look at the console, we're done with no errors whatsoever. Now, if you want, you could time your code, and the way you can do it is to, well, there's no way for us to figure out our last write. Well, technically we can, but what we can do that's quite a bit better is to try to add an end event on our read stream. So this will happen when we're done reading. So I'm just going to log and say done reading. So first, let's take a look at our destination file and see if all the numbers are even. So I'm going to say cat des.txt, and let's stop it right now. And as you can see, we are getting all the numbers correctly. Now, in this case, we are getting the numbers that are divisible by 10, but you could change it to any other number. You could get the even numbers, odd numbers, anything. It's all up to you. But if you just take each number and add 10 to it, you should get the next number, or vice versa. If you take each number and subtract 10 from it, you should get the number before it. So yeah, it looks like it's working pretty good, and the size is roughly 1/10 of the size of our gigantic file. So it's 10 gigabytes and this one is 1 gigabyte. Perfect. Now let's try to time our code and see how long it takes. So right here I'm going to say console.time read big, and here I'm going to say console.time and read big. And I'm also going to read from text small because I have to wait for possibly a minute for it to finish, but this one is quite fast. So node read big. Oops, an error. Stream read is not a function. Yep, I forgot to call the dot end. Let's try it again. And cool. So it's done reading, and read big took 100 milliseconds. So this is also a good thing to keep in mind. Now notice that in a readable stream, we used the finish event, but we don't have access to this one on a read stream. In a read stream, we instead have an end event. Now you could get to this point, the finish event, by calling write stream.end. So stream write.end. And when you call this, then you're going to indicate the stream is finished, and then you're going to get to this point. Now in a readable stream, this is not something that you can do. It's automatically done for you. So when the readable stream is done, so it will figure out whether or not it's done, and if it's done, it will automatically emit this end event for you. Now, if you're trying to implement a readable stream, which is something that we're going to get into in a couple minutes, when you try that, the way is that if you push a null character to your readable stream, so say stream read dot push null, that indicates that your stream is done, which is something that we're going to get into in just a little bit. But yeah, at this point, I have to say that we're pretty much done with API consumers. Let's take a look at the documentation again and go over what we have. So here I'm going to find the readable section. So we were done with the writable, if I can find it. This is all about writable, and here it is, readable streams. Now here again, you could see some of the examples. Again, they're just like before HTTP, but they are different. For example, in the previous writable, it was FS write stream, but now it's FS read stream. Same is true with HTTP requests. For example, here, HTTP responses on the client. Now, a writable stream, it will be HTTP responses on the server. So there are some things back and forth, but you get the idea. Now, here it says that we have two reading modes, which is really important to understand. One is flowing and one is paused. Now, we did just this. We started to make our stream into flowing mode by adding that data event, and then we paused it when we were draining, and then we resumed it again when we were done draining. And here you could see that it says all readable streams begin in paused mode, but can be switched to flowing mode if you do one of these. So if you add a data event handler, if you call the stream.resume method, or if you call the stream.pipe method. Now we're going to get into pipe in just a minute, but keep that in mind. And then you could also switch back to paused mode by calling stream.pause or by removing all the destinations. Now we could get these states by calling readable.readableFlowing. You could see that if it's null, it means that you haven't done anything. If it's false, it means it's in paused mode. And if it's true, it means that it's flowing. I hope I was right. I don't quite remember, but I think that was the case. Yeah, it says when readable.readableFlowing is null, no mechanism for consuming data is provided. So if you just create the stream and you try to log this, you're going to get null. But if you start to make it into a flowing mode by adding a data event, you will change it to true. And when you pause it, it will be changed to false. Now here also says that you should choose only one API style. Now there are two ways to read. One is to add the data event, and another one is to add the readable event and then read by calling a read function, which is not something we're going to get into in this video, but you could read that here in the documentation. And if you understand this data event, this one is just like this one. You will understand it. Then we have some events like the close events, which is kind of like before that close events for the writable. Then we have the data events, which we talked about in great detail. Now you're going to get a chunk, which is going to be a buffer, but if you specify the set encoding, you could also get strings. We have the end event, which is emitted when there's no more data to be consumed from the stream. And the end event will not be emitted unless the data is completely consumed. And here it says sometimes that you are done with the data, but there's still data you're not going to get into the end. Now sometimes you might just read a portion, do some work with that, and then you're done. But this event will not be emitted. If you want to get into this emit end event, what you need to do is to just switch it to flowing mode until all the data is done, and then you're going to get into the end event. Now you could use this function if you add that readable event on your readable stream. We have the error event, we have the paused event, which will be emitted when you call that pause method. Now this is that readable event, which is just like that data event. Now we should only stick with one. If you are going to use this readable, you shouldn't use the data event again on this stream. Just stick with one. Now the way that you can use this one is to add the event listener first, and then here's how you could read from it. And you could also optionally specify a size parameter to this read function. And here it says that if you use both of them, this one will take precedence and flowing. But you shouldn't really try to do this. Just stick with one. And he also talks about what will happen if you remove these listeners. The resume event, destroy. Now here we have some properties. Closed, which is true if the close event was emitted. Is paused is another method. It's kind of like that variable we talked about, but it only indicates if it's paused or not. This is how we can pause a stream. We talked about this one. Now piping, well, we're going to get into it in just a minute. Now piping is just like that first thing that we did. Now before we add these operations, what we did was that we just copied the stream over, right? So we read from that text and we wrote to that destination. And we also took care of some draining things. So we paused the stream when we were draining, and we made sure that we're not having any memory issues. Now piping is just like that. You add a pipe to a readable stream and then you specify a destination. And Node.js itself will handle all that draining and pausing and resuming for you. We're going to see an example about this piping in just a minute, but that's basically what it does. And this read is if you add this readable event, then you can make use of it and specify a size option. And we also have this property, which is true if it's safe to call this, which means that the stream was not destroyed or emitted error or end. And we also have some experimental methods here. We're not going to talk about them, but if you want, read them and use them. Readable encoding. This will give you the encoding if you call that set encoding function. Readable error, flowing. A readable high watermark value, which is how you can get that, the size of that internal buffer. And unpipe, so you could pipe and then maybe after a while you could unpipe. Now shifting, we're not really going to talk about it because instead you could just use a transform stream and it's usually better. So let's skip this one, wrap again, we're not going to use this. Now here it says it will rarely be necessary to use readable wrap, but we still have it to make it more compatible with older Node.js applications. And then again, some more experimental methods. I encourage you to use them, but we're not really going to talk about them because they could change and they're right now experimental, but they're really easy to understand. For example, using this map, it's kind of like mapping on arrays, so you could map over your readable streams and see what you have. Or you can filter again like an array for each, and to array you could convert it into an array, and a couple more. So still more experimental methods. Reduce, and we're done. So we're pretty much done with a readable stream, and then we have to talk about duplex and transform. But let me first show you an example of piping. So I'm going to create a new directory, and I'm going to call it, show it right here. So new folder, and I want to call it copy. So here we're going to try to copy a file from one source to a destination. So I'm going to create a new file called copy.js. Now let's also try to put a file here to copy. Now this one is quite small. Maybe let's try to make this test a bit bigger. So actually I'm just going to copy this text gigantic over to my copy folder, and let's try to copy this. Did I paste it? Come on, copy and paste. Well, looks like it'll take a while, so I'll wait. Right, looks like it's done. It tried to open it, but it can't. So now let's try to do something. Let's try to copy this file to a new destination, maybe in the same folder, but change the name to text gigantic -copy or something like that. Let's try to copy the file, but without using streams. So let's try to put aside all these stream concepts that we learned about for just a second and try to copy the file with the current knowledge that we have from the previous videos. So we know how to read a file, and we also know how to write to a file. So we could technically be able to copy this file over. So if you want, pause the video right now and write some solutions, write some code, and try to copy this file. And please don't use fs.copy, because if you use this one, it's just going to copy the file using a stream for you. So without using a stream, let's see how we can copy this file. So I'm going to first include the fs module. Require node fs/promises. This function. So I'm going to first read the content of this file and then write it to a destination. So let's first open a destination. So const dest file equals await fs.open. I want to call it text-copy.txt, and I'm going to flag it as w to indicate that we're going to write. Now I'm going to read the content of this file, so I'm going to say const result equals await fs.read file, and I'm going to use this function now. Now this function will automatically open the file first for you and then return all the contents in one buffer. So read file, going to specify my source, which is text-gigantic, and now this is going to be a buffer. Let's first try it with a very small file. So this one is fairly simple, so it's only 70 megabytes. So let's first try it with the text.txt file and not that text gigantic. So I'm going to change it to text.txt. All right, let's now log the results. Switch to copy and run the application. Oh, not again. My semicolon. All right, there we go. No such file or directory. I don't know what's happening here. Oh, it's test. So let me rename it to text. Alright, so as you can see here, when you call this function, it's going to return all the value in one simple buffer. Now we could specify an encoding if you want, but well, let's just deal with this buffer first. Now what you can do is to just say dest file dot write and then specify that buffer, and that's it. Now this is also a promise, so I'm going to say wait, and our text copy is now empty, but if you run the code, you will now get the data in the text copy. So this is one way you could copy a file over, but it's not really practical. It's actually not practical at all. If you're dealing with very tiny files, it's okay, you could do it this way. But still, even in that way, if you use streams, it's way better. And not just streams, this is really problematic with big files. So let's try to copy the text gigantic file. So I'm going to say text-gigantic, and I think it's going to crash. I doubt it's going to work. So node gigantic. Now this will definitely crash because we're trying to move a buffer that is, just copy, that is 10 GB in size, so definitely we're not going to be able to do it, but let's take a look. And as you can see, well, actually we're not crashing. So Node is returning an error that says the file size is greater than 2 GB. So it's figuring that out for you, but well, the point is, if you try to do it with a file that's less than 2 GB, what's going to happen is that you are going to, your memory usage will be the size of that file, which is not really good. So if we just add in 2 here and run this code. So write mini and then node write mini. Alright, it's done, and it took 27 seconds. So let's try to copy this one. I'm gonna reveal this in my Finder. Well, it's 1 GB, so we should be okay. So I'm gonna paste it here in copy and change the name to just text dash, maybe not small, but to maybe text dash big. All right, so let's try to copy this text big and see if we can do it. So text gigantic, text big, and we should be able to copy it, but let's also add a set interval function just so that my process doesn't exit. So interval, come on, interval, and I'm just gonna run it every second. And let's open up the activity monitor and check this one. So node copy, and well, you can see that our memory usage is around 900 megabytes, and it's still doing the copy operation. Actually, I think it's done with the copying operation. It's not exiting because we have the set interval function. But you saw that our code was really bad. Our memory usage was at 1 gigabyte. Now let's also try to time it. So console.time copy, one right here and one right here. So console.time and copy, and I'm just going to remove the set interval because we already know how much memory usage we're going to have. So I'm going to run it. So the copy operation was pretty fast, only at 900 milliseconds, but our memory usage is really high. We can't deal with that. Plus, we can't even copy a file if it's over 2 gigabytes. So what we can do, so let me just add in some comments here. Memory usage is around 1 gigabyte. And notice we can, now we could also add our CPU usage, but this is not how we usually do it, because when you're running an algorithm, a solution, or any code, your CPU usage will be at 100%. So adding CPU usage 100% is pretty useless. Now what we do usually is to report our speed complexity. Now we have two things to benchmark our algorithm and our code. One is speed complexity and another one is space complexity. Now space means how much memory your code is taking. Speed means how fast your code can do that operation. Now these are usually topics of algorithms and data structures, so I'm not really going to go over them. But in speed, the way that we report a code is like this. So we say it's big O, maybe n. And if it's big O n, it means that if we have an array of 100,000 elements, we're going to do 100,000 operations. Now if we say it's big O of n squared, it means that if we have an array that has 100 elements in it, we're going to do 100 to the power of 2 operations. So if you learn about these, you're really going to improve your programming skills. So I highly recommend you to learn about algorithms and data structures if you haven't already. There are some great algorithms out there to learn about. And it's not just all about interview questions. It's really all about how good you could code, you know, how fast your solutions are, how well they run, and things like that. So definitely learn about algorithms and data structures. They're really important. Every software engineer out there needs to know about these. They will really teach you how to create highly performant code and how to really try to make your code as fast as possible. So definitely keep that in mind. If you haven't already, just go ahead and check it out. There are great courses out there, great videos, tutorials, books. Learn about algorithms and data structures. So I'm not going to put my CPU usage here because it's definitely going to be 100%, but I'm just going to say execution time, which was around 900 milliseconds. Okay, now again, let's try to improve this code, but still not using streams. So let's try to come up with our own streaming solution. Let's try to use streams without using Node.js Streams. So the way we can do it is to create a buffer and keep filling it and keep writing it. So that's something that we can do to really improve our memory usage. So let's try that out. So I'm going to actually just copy the code out and comment this portion, and let's start from scratch. So I'm going to first get my source file, which is going to be wait fs.open text-big.txt, and we're going to read from this. And I'm also going to create my destination file, which is a file that I'm going to write to. So it means that I'm going to copy from this location to that location. So fs.open text-copy.txt. The flag should be W. So the way that we can do this copy operation is by calling this function source file.read. Now this function will return a small amount of buffer. It will return us a chunk. So let's try to log it. It also returns a promise, so I'm going to wait. And let's run it. So as you can see here, we're getting a value. Now this would look familiar too. It's 16 kilobytes. So this function is returning a chunk of our file. It's not returning the whole file like here. This read file is returning the whole file in just one buffer, and if it's more than 2 gigabytes, it's not going to work. But this will definitely work if I just try it with text gigantic. It will work no problem. But it will only return me a small chunk, a buffer that has a size 16 kilobytes. So what we can do is to just keep executing this function and keep writing the result, the chunks that this will return, to our destination file. And we basically are setting up a stream of our own. So let's try this out. So I'm going to save this into a variable. So I'm going to say const read result equals this. And I'm also going to get the bytes read out of it, equals read result dot bytes read, or bytes read. Now I'm gonna check and see, while this is not 0, just keep reading and keep writing to our destination. Because notice now, this is how many we read. Now when we get to the end of the file, it's going to be 0, which indicates that we're done reading and there's nothing else to read. So I'm going to wrap this code inside of a while loop and say while bytes read is not equal to 0, just keep reading and keep writing. And I have to, well, define this right here. So bytes read, maybe I say -1, because when we were starting out we haven't read anything, so I'm just going to specify it as -1. And right here I'm going to say let bytes read equals that result. So while it's not 0, we're going to keep reading. And then what we can do is just write this buffer into our destination file. So desfile.write read result, well, it was called buffer. So we're going to get the buffer out of it and write it to that location. All right. So this is how we can actually set up our own stream. Now, notice that if you're doing this in production, definitely take care of all the error handlings, wrap it around to try catch and handle the errors. We're not going to do it in this video for the sake of teaching and simplicity, but in production, definitely always wrap your code around to try catch whenever you're using this await and handle all the errors. So let's try this code, but using text. First, let's try it with text-.txt, a small file. It gets sometimes confusing, so text.txt, this is our small file, right? Yeah, it is. I want to change the name to text-small. Okay, so this is our 7 megabytes file, this text big is our 1 gigabyte file, and this gigantic is our 10 gigabytes file. So I'm going to say text-small. So let's try to copy this. Alright, it looks like it was successful. If I take a look, well, you see some weird characters here, some nulls, but apart from this one, the copy was successful, as you can see. Now the reason that we're getting some nulls is that our last read is going to be a buffer that's not complete, so we're going to have some zeros at the end of the buffer. So let's also try to log the buffers and see if we could get to that last log. Well, the last buffer is just 0 because we're not reading anything in that last read. But also if you take a look at the buffer before it, we're having some zeros at the end of the buffer, which is not really indicated here because we're just logging some of the elements. But if we try to maybe log this element, maybe at location this, you can notice that even in our last buffer, we get some zeros. So what we can do is to remove those zeros from our buffer so that we don't get this weird null characters. So what we can do is to add an if statement. Now, if I log this read result again, if you take a look, we can check this bytes read property and see if it's not this value, which is the value of our buffer, it means that we have some zeros at the end of the buffer. So we need to remove those zeros so that we don't get those null characters. So let's try this one. So let's check this bytes read. So I'm going to say if bytes read is not equal to 16, what was the number? I'm just going to copy it. If the bytes read is not equal to this number, now what we're going to do is to first get the index of not filled. So we're going to get the index of the last element that's not filled, actually the first element that's not filled in our buffer. And the way we can do it is to say read result dot buffer. So this is our buffer now, dot index of 0. And this will return the first 0, the index of the first 0 that happens in our buffer. Now we're going to create a new buffer. I'm going to say buffer.alloc. Now the size should be this one, index not filled. And now we need to do a copy in these buffers. So I'm going to say read result dot buffer dot copy. So it means to copy this buffer to a destination. So whatever I specify here is going to be my destination. So it's going to be a new buffer. And then I want to specify a 0, which is going to be target start, which is going to be 0, source start, which is definitely going to be 0, and then source end. Now, source end is going to be this index not filled. So I'm just going to write that in. So using this copy operation, we're copying this buffer to this new buffer that we just allocated with the right size, which is the size of those filled elements. So we're dismissing all these zeros, and we're copying that buffer over to this new buffer from these locations. So we're starting from 0 all the way until index of not filled. And then we're going to do our write. So dest file.write new buff. We're not going to write that buffer that came out. We're just going to write the new buffer that we just created. And else, in our else statements, we're going to do our normal write, where our bytes read is equal to the size of that buffer that's going to get returned. Now, if we run this code, well, it looks like we have a typo somewhere. So here it's called new buffer. So I'm just going to paste that in. What's called new buff, so it should be new buffer. If I try it, so we didn't get an error, which is a good point. And if we take a look at our copy, now we can see that we got rid of those null characters. And we're just doing our copy with no problem whatsoever. Great. Now let's also try it with that text big file. Now this one took 9 milliseconds, and I'm also going to indicate the file size. So file size copied was 1 gigabyte, right? Yeah, it was 1 gigabyte. So let's try the same thing with our little streaming thing that we set up. So I'm going to copy text big.txt. Let me just confirm that the file size is 1 gigabyte. Yeah, it is. So I'm going to save, run the code. Now it will take a while. Well, it took around 2 seconds, but let's see if it was successful. I definitely can't open it, but if we take a look at the file sizes, so text copy is now 1 gigabyte. So we copied this text big over to this text copy, and if you take a look at the file sizes, they do match up. But what we did is that we significantly reduced our memory usage. So let's try it again and take a look at our memory usage. You can see that it's around 20 megabytes, and it doesn't really go above that point. We're not sure because it exits quite fast, but it's around that. Now let's also try it with text gigantic. So gigantic. Now notice that actually this took 2 seconds. So let me just add these in. So copy it is 1 gig, memory usage around 20 megabytes. or let's just say 30 megabytes, and execution time was 2 seconds. Now it's definitely slower than this solution, because here we're moving all the file in our memory and then we're just doing one write. So it's quite fast, but the memory usage is really awful. But here we're doing multiple writes. We have set it up as stream, but well, our memory usage is significantly lower and we're not limited to the file size. I mean, we could do this on a file that's like 1 terabyte in size, 100 gigs, doesn't really matter. So let's also try it with text gigantic and see if it works, or see if we're going to get an error. Well, it's definitely going to take a while, but memory usage is around 30 megabytes and it doesn't really go higher than that. And my disk usage, yeah, bytes read 6. If it gets to 10, we're done. Let's also take a look again at the memory. So it's around 36 megabytes, 30 megabytes, I should say. And we're done. So let's take a look at the file sizes. The text gigantic is 10 gigabytes and text copy is also 10.9 gigabytes. So we are copying the file correctly without any issues. All right, so this little code here, as you can see, is a little streaming thing that we set up. So we keep reading from a source and we keep getting the chunks and then we write them to a destination. Now technically we don't have a buffer that we put the data in and then we pull it out, but you can imagine that this is somehow similar to that streaming thing that we did. Now let's also try this but using streams. I'm first going to copy this code and paste it, and also I have to comment it out. So we're getting our source file. It should be text. Let's first try with text big and then text copy. Now we don't need any of this logic. Instead we need to create our read stream and our write stream. So read stream equals wait, actually just source file dot create read stream and a const write stream equals, now this is going to be where we are copying our file in, so it's going to be dest file dot create write stream. Alright, so with these two in place, now rather than trying to use the data events on this read stream and get the chunks and then write them to the write stream and also handle the draining and pausing and resuming this read stream, what I'm going to do is to just use something that Node.js already gives us, which is piping, which just does the same thing that we talked about. It will read from the source and it will write to a source, and it will automatically handle all these back pressuring, all these draining and resuming and pausing. So when using pipe, let me just show you how it works. So you just put in your read stream first and you call the pipe method on it. And for the destination, you have to specify a writable stream. You cannot specify a readable stream. It has to be writable. Now you could also specify a duplex stream and a transform stream, which they both also implement a writable stream, but the point is it should be a writable stream. And if you put a readable stream in the pipe destination, it's not going to work. So I'm going to say write stream. So what happens here is that this is read stream. So this pipe method will automatically read from the stream, and those chunks that it gets, it's going to write them to this destination. Now you could also chain these pipe methods like this and then put another writable like this, or another duplex or another transform, and then keep piping like this. So if you're doing this again, if you want to chain, you can't do it this way because this writable is just a writable. This should return a readable stream. So if you want to do this, these streams that you have in the middle, they should be transform or duplex, which they both implement a writable and also a readable. So I can't put a write stream here. It's going to return an error because there's nothing to read from a write stream, only to write to. So let's just quickly run this code and do a quick benchmark. So I'm going to copy our previous solution and just paste it here. So file size is the exact same file size, it's text big. Memory usage, let's take a look at that, and also execution time. So I'm going to say node copy.js, and we're done. So it took around half a second, which is faster than our previous solution, our streaming thing that we set up. And the memory usage should be fairly low. So if I try to copy it a couple of times, now in this case it's actually way faster. It looks like that my computer was just freeze for a couple milliseconds. It's actually 5 milliseconds, 30 milliseconds, which is way faster than what we were hoping for, right? Now, sometimes it gets a bit higher. Well, it really depends on a lot of things. I mean, what's going on in my computer. So results vary, but you could say that it's pretty fast. Sometimes we get to 5 milliseconds. Let me just delete the file and try it again. So I'm gonna delete, and let's try with text gigantic. So text big, gigantic, activity monitor, and if I run it, well, it was, well, actually it looks like our timing function is not right. And yep, it is not right because we need to do a callback function on this pipe. Take another look. Now let's also first make sure that it works, and then we're going to handle that callback thing. So we can't say for sure how much is the execution time because we need to see when this piping is done. There are various things we can do, so we're going to talk about them. And if we take a look at text copy, sizes, yep, they do match up. So here it's 411 and it ends here with 411, and they were both 10.9 gigabytes. Cool. So you can now come to the documentation and read the pipe thing. Piping is kind of easy to understand, nothing too crazy is going on. Well, it might look like magic, but at the end of the day, what's happening really is those things that we did previously. So it just handles these drainings and pausings and resumings for you behind the scenes. So here you could see that readable.unpipe. You could also unpipe maybe after a while. There could be some cases that you might want to do that. And here's how you could chain. And let's see. Now we could use this on.end on our readable to figure out when it's ended, and there we could run our time end function. So let's do that. So read stream.onEnd, and here I'm gonna move in my time end function, and let's try it with text big just to be able to compare it to our previous solution here. So I'm gonna run it, and well, it took around 1 second, so not that much faster comparing to our previous solution, but yeah, it's twice as fast. That's something. So I'm not saying it's our previous solution is better, definitely not this one. Don't try this in production. Definitely make use of these things that are already built for you. There's a lot of care going on behind them, and a lot of good people are working behind them, so always using something that is there could be better. Not always, but in a lot of cases. So execution time is around 1 second, I guess. It varies, but that's about it. I notice it's not 5 milliseconds as we saw previously, was because we had this time end function somewhere that was not correct. So it will take a while to complete. So I'm going to just change it to 1 second, file size copied 1 gigabyte, and memory usage is the same. Is it the same? Let's try it. Well, it could be maybe a little bit lower. 20. I guess sometimes it gets to 30. But yeah, let's just leave it at that. Let's leave it at 30 megabytes, just like before. It could be maybe a little bit lower, but a couple bytes really doesn't matter. So here is the definition of this pipe. You specify your destination, and it always have to be a writable. And you could only execute this pipe on a readable. You cannot execute it on a writable stream. And here we could see at the last sentence that the flow of data will be automatically managed so that the destination is not overwhelmed by a faster readable stream. So this is what we talked about, that the Node.js will automatically handle those things for you. And here we could see allowing chain of pipes if it's duplex or transform. So you could chain these methods like here. Now this Z should be a transform or a duplex. Let's see its definition. It's this one, zlib.createZip, well, which is a transform stream. So it makes sense. And this is how we can be notified that the piping was done. By default, stream.end is called on the destination writable when the source emits end. So this is how you can figure out whether or not the stream is done. And yeah, that's pretty much it. So let's take a look at the other things about pipe. And also, I just want to say this again. We talked about this choosing one API style, and we talked about this data events and readable events, but also piping is in this one of these API styles. So if you run this on data on a readable stream, do not try to pipe it again or use this unreadable. Just stick with one and that's it. Don't try a couple of things at the same time. It will lead to some unintuitive behavior, as it says here in the documentation. And here we can read more about these states, that if there's a pipe destination and if you remove them, what's going to happen is that I think this state will be changed to paused. Yeah, it will be changed to paused if you remove one of these piping destinations from a readable stream. So as soon as you add this, so I want to just do a quick recap. When we create our stream up until this point, this is not doing anything. It's not reading from the underlying resource. It's not giving us any data whatsoever. It's just sitting there and nothing is happening. And if I log that variable, which was read stream dot readable flowing, yep, that's it. If I log this and run it, you can see now it's null because we're not doing anything. But as soon as I start piping, it will be true. And if I unpipe, so I'm going to say read stream.unpipe and then log this again. Now we get null. Now null is our first log. Now at this point we are not doing anything with our read stream. Now at this point we start to read from it, so this property will be changed to true, which as you can see here. And right after we're going to unpipe, so we're going to remove the destination and we're going to change the read stream into paused state again. So now our readable flowing value is false. If I start to pipe again and I'll log this again, now it will be null, false, null, true, false, and then true, because we started to pipe this stream again. And here's our final file. So if you pipe and unpipe, it will resume from where it was paused. And to really demonstrate it, start with a text small. Let's run it. Now we're doing a couple of piping and unpiping like here. So we were doing an unpipe. If I run it, it's quite fast. And if you take a look at text copy, starts at 0, goes all the way up to 6 nines. So by piping and unpiping, that's how we can pause and resume reading from this read stream. You could also get this unpipe event. You can read definition here. The unpipe event is emitted when stream.unpipe method is called on a readable stream. So here, when we were calling it, we could also make use of that unpipe method on our writable stream. There's some more methods that you could just take a look here and understand easily what they do. And we also have this pipe event on a writable stream, which will be emitted when we call this stream.pipe on a readable stream, and we add that writer to its destination. And here, it's just at the beginning of the Node.js documentation, here it says a key goal of the Stream API, particularly stream.pipe method, is to limit the buffering of data to acceptable levels such that sources and destinations of differing speeds, so we could have a source that's faster than a destination. So the key goal of streams is to make it so that we're not overwhelming our available memory, especially this stream.pipe. That's what this method is doing. All right. Now in production, you shouldn't really try to use pipe. And the reason is because of the poor error handling that you have available. I mean, technically you could do some error handlings, but you have to keep running the .on each one of these streams and then manually destroy your write streams if an error happens. Now what you can do instead is to use a pipeline. So I'm going to show you the documentation first. Here you could see the pipeline method, and you have to include it first, and here's the only place that it was mentioned in the documentation. It's way better than piping. Well, it's actually basically just doing the piping for you, but it will also handle the error handling for you, and it will destroy those streams if an error happens. So you could read the documentation that says a module method to pipe between streams and generates forwarding errors and properly cleaning up, which is very, very important. And we get all of this happens in the callback when the pipeline is complete. So if in production you just run this piping and you leave the streams as be, and some errors might happen, and actually they happen quite often. Your files might just get removed for whatever reason. Something might happen in your system, and maybe you're just dealing with a network, and your network might just go down for a couple of seconds, or just for a couple of milliseconds, or a couple of microseconds. So errors do happen quite often in production, and using piping is not really recommended, because in that case you're leaving a lot of streams open and you're going to run into some memory leaks and memory issues. So always clean up when you do have an error. So you can just use pipeline and automatically let Node handle those things for you. This was recently introduced, I think it was version 10. And prior to this pipeline that it was introduced, we were using something like pump. Yeah, if I remember that correctly. So pump, this was a package that we're using to handle these errors, and you can see it was published 5 years ago. So if you scroll down, you can see that when using standard source.pipe destination, source will not be destroyed if dest emits close or an error. And you are also not able to provide a callback to tell when the pipe has finished. Well, technically you can use the end event, but yeah, it's right, you cannot use a callback to indicate that. But pump does these two things for you, so it will automatically destroy the source for you. And you can see it's a very quite popular package, 20 million downloads weekly. So when you want to use pipe, you should really take this into account and install this package instead of just using pipe, because you can see it's a fairly simple package. All it does is that you call this and you specify your source, transform, another source, and destination. Just like a pipe, the syntax is quite different, but you also get a callback function, and you could also, and it will also automatically destroy the source for you if one of these emits an error event. So this is what you should do if you want to use pipe, or just this pipeline. Now let's also take a look at the pipeline. Pipeline and pump, they fairly work in the same way. So I'm going to use this. And here we could see that stream pipeline will call the destroy method, which is really important. When you're done, you should destroy your methods. Now, if it's successful, it will automatically be destroyed for you. So when it emits a close event, maybe a read stream or write stream, and then it's done, it will automatically be destroyed. But if it's not successful, it will not happen. But pipeline will handle that for you. So that's something else to keep in mind in our previous codes that we wrote. You have to keep in mind that if something happens, you have to manually destroy your stream. Now, if it's all successful, it will be automatically destroyed for you, but if it's not, you have to take that into account. So maybe add in stream.onError and then manually destroy your stream. But anyway, let's include that pipeline first. So I'm going to say const, was it lowercase or uppercase? Lowercase. So pipeline require stream. And notice we actually haven't really used this module in this video so far, and it's because these streams that we used, like create read stream, are inheriting from this Node stream module behind the scene. So if you take a look at the source code, you will see that they are inheriting from this. So if you want to implement your own streams, which is something that we're going to get into in just a minute, you have to include the stream. Maybe if you want to create a readable stream, you have to include the readable and then inherit from this readable, which is something that we're going to see in just a minute. But yeah, this is the module. We forgot to talk about it until this point, but we're going to see this module a lot more from now on in the video. So let's just use pipeline. I'm going to comment all these out. All you have to do is just call the function, specify your source, which is read stream, and just chain. You can add in as many streams as you want here. But you have to make sure that these streams that come in the middle they should be either duplex or transfer. You cannot put a writable stream here, because if you do, it will try to read from this and write to this, which is not going to happen. Or if you try to put a readable stream here, now this works fine from S2 to S3, but from S1 to S2, it will not work because it's a readable stream and you cannot write to it. So that's something to keep in mind. So let's try this and our error. Now you could also use it like a promise. So you have to include it from this. So node stream / promises, just like this file system module that we did. But I'm going to stick with callback right now. So I'm going to just log the error. All right, let's run it. And also let's move our time end log here. And well, cool. So you can see, well, we get undefined because we don't have an error right now. So you could just say if error, do something with the error, and if not, just log that the pipeline was finished. But this will now handle all those cleaning ups for you. So if something goes wrong here, it will destroy those streams and you're good to go. You could also use pump, which is quite popular and quite light. I encourage you to always take a look at the source code, at the GitHub account, and see what's going on. So you always go to the issues and always take a look at the source code. So we can see that the last commit was 2 years ago, which is not really that bad because, well, it's now really stable. It was published many years ago, 5 years ago, so really a lot of bugs are fixed. But the source code is quite simple. It's just one index.js file. And yep, it's really simple. So we have some of those destroying things going on around. Destroyer, we have this destroyer function which destroys this stream, and if you just search more, you could see that if something happens, it's going to destroy these streams for you automatically, as you can see here. So something else to keep in mind. Now, something else that I forgot to say, another useful function that you can use for error handling and cleaning up is this finished function. So using this one, whenever a stream is no longer readable or writable, or has got an error or was closed unexpectedly, you can use this function to handle your errors and do all the cleanings, as you can see here. So it's also something else to keep in mind when you are working with streams in production. Error handling and cleaning up is very important when you're dealing with the streams. So do keep in mind this pipeline function and also this finished function. And also this pump. Alright, so that's all that we need to know about piping. Definitely always check the documentation. I don't mention all of the things, that way the video would be really long, but we covered the core concepts, so you should now feel free and feel really comfortable to just come to the documentation, read everywhere that we have this pipeline, piping, read stream, write stream, and we're pretty much done with these sections. Now, we have to talk about a duplex stream and a transform stream. We just mentioned that a duplex is a stream that you can write to and read from, and a transform is a stream that will, just like a duplex, so it's inheriting from duplex, but it's also transforming the data somewhat somehow. But we're not going to use these two right now, just like we did here. We're not going to use the API consumers because honestly there's only just the zlib and crypto modules that use these two. So the FS module is not really using the duplex and transform, but what we're going to do is to implement them ourselves. So we're going to include them and then inherit from them. So we're going to move on to the next portion of the documentation. So API for stream consumers, this is how you could use a stream that's already written for you, be it in the Node.js documentation or a package that you install that will give you some streams. And the next API is how to implement your own streams. So we're going to first learn how to implement our own writable stream and then readable, and then we're going to learn how to implement a duplex and a transform, and then learn how to use a transform and a duplex stream by learning how to use our own streams that we created. And so now let's move on to this section. Alright, so now let's talk about how we can implement our own writable streams. So I'm going to close all these open files, and I'm going to create a new directory here, and I want to call it a custom writable. And inside of it, I'm going to create a new file called custom writable.js. And just to be consistent, let's just change its name to use a dash instead of camel case. So like this. All right. Now, the way that you can implement your own stream is first by including that stream that you want to implement. So in this case, we're trying to implement a writable stream, so we have to include the writable stream, and it's capital W, from that stream module. So node.fs, node stream, like so. Now we have 4 streams available. We have readable, we have writable, and we have duplex, and we also have transfer. So we're going to use all these and implement our own streams, but right now let's focus on the writable stream. So you first have to include that particular stream that you want to implement, and then you have to create your own class. Now, if you're not familiar with JavaScript classes, please pause the video right now and go and learn how they work. It's really important to understand that. And if you don't know JavaScript classes, it's still fine as long as you understand JavaScript object prototypal inheritance. That's all you need to know. Now we're going to use a class syntax, which is just a syntactic sugar for that object prototypal inheritance. Now if you go to the implementation section, you usually see that, if I can find something here, you see the example first using a class and also without using ES6 features. So you could also implement your own streams just by using normal JavaScript. So you first have to define your function and then make it inherit from this writable that you're going to include. So we have both options. In this video, we're going to focus on the class-based syntax, but
feel free to use this one if you feel more comfortable with this one. It doesn't really matter. So I'm going to define my class, and I'm just going to call it simply write stream, which extends or inherits from that writable object that we included right here. So now that we've defined our class, what we need to do is to call the parent constructor. So we need to use this super function. Now if you're using pre-ES6 syntax, it just means that in your function you need to call the writable object that you just created. So you need to call it and pass this, which refers to this function, to that writable constructor. So this is basically all that this super does. It just calls the parent constructor and passes this to that. So when you use .call, what you're doing is that you are saying that change the this difference of that function to this reference. It is really something related to JavaScript and will take a while to explain, so I'm not going to do it. So if you are not really understanding this part, just read about super and this, and you are going to be good to go. Alright, so I'm going to define my constructor, and I'm going to accept some options. Now in this stream, what we're going to do is to just implement that fs create write stream that we just did. So just to make it more easier to understand, I'm going to change it to fs file write stream. So we're going to create this stream, and then just like before, here in our write many code, we should be able to use it like this. So we should be able to call .write, .end, use the drain event, and so on and so forth. But now we have more control over how our object works. So what we need to pass is one high watermark value. I could also not pass it, and the default one would be that 16 kilobytes, but let's just do it. And also a file name, because we're going to specify what this stream should write to. Now in the constructor, I'm going to call that super function, and rather than just passing all the options that are passed to the constructor, what would be better is to just specify specifically what we want to pass to our parent constructor. And if we want to take a look and see what are all the options that you could use, you could see them all right here. So you could use this high watermark value, you could use default encoding, object mode, emit, close or not, and a couple more. So if you want to see the complete options, take a look at this portion of the documentation. So now in this case, I'm just going to specify the high watermark value, and that's it. Now let's also save the file name. So this dot file name equals file name, and let's now open the file up first before we try to write to it. All right, when you are implementing your own streams, you first have to, well, do this inheritance and then set up your constructor. But after you do these two things, there are some specific methods that you have to implement. And you could see the list right here. They must implement one or more specific methods. If you want to implement a writable stream, for example, you have to implement maybe write or write end, or maybe both, and also the final, which is for our final write. Now for reading, you only have to implement this read. You cannot implement this read when you are implementing a writable stream. And for duplex, you have to specify all of these, but we're now focusing just on the writable stream. So you have to first implement this write method, which will be called whenever you write stream.write, and that's it. So if I initialize my stream here, so I say const stream equals new file write stream like this, and I could optionally pass my high watermark value, or I could just not, and default will be 16 kilobytes, and I'm just going to specify maybe 1800 like so. Now just like before, we could write to our stream like this, so stream.write and then our chunk, so we could say buffer.from whatever, so this is some string, and then we could say stream.end, maybe this
actually buffer from our last write, like so. So when we do this, when we write to our stream, this method here will be called write. Now, this method accepts 3 arguments. One is the chunk that we're writing, another one is encoding, which if we don't specify, it's going to be a buffer by default, and the last one, and which is quite important, is our callback. So here we're going to do our write operation, and then when we're done, we have to call the callback function. So when we're done, we should call the callback function. Now, the callback will accept only one parameter, which is either an error or just null. So if you don't specify anything and just call the callback, it indicates that you are done writing and it should move on. Now, when you run this write, and then you immediately do another write, now, while this is happening, so before you call the callback, it's going to buffer the data. So when I do double writes, and I don't let this write to finish, and that means not getting to the callback, it's going to buffer. But if it does get to the callback, and then I write again, it's not going to buffer. So if I maybe put this callback in a set timeout function, and that's going to write maybe after 5 seconds, and that 5 seconds until I call this callback, all the things that I write to my stream is going to be buffered. So when we invoke this callback function, what's going to happen is that we're going to get that drain event on our data, on our stream, excuse me. All right, actually drain. So when you call this callback, what's going to happen is that Node.js might emit a drain event for you. Now, one thing that I really want to make a huge emphasis on is that you should never ever emit these events from your child classes. So I shouldn't ever do this. So say this.event, maybe error or drain or things like that. You shouldn't do this at all right? If you do this, you're going to run into some issues. So never ever emit events from your child classes. Let the methods do those things. For example, here when you call this callback, it's going to emit this drain event for you, and you shouldn't do this explicitly. Now the same is true about overriding these methods. So you shouldn't really just say write like this and then overwrite the original method. Instead, you should use _write. Okay, so this is how Node will be notified that this is going to be your implementation for write. Never ever do this. Okay, this is really bad practice, and I don't even know that it's going to work. So it's really advised against in the Node.js documentation, so do not do this. And also one more thing, do not try to call these methods explicitly in your code, so never do this. Okay, it's again super bad and it's not really advised. You should just use those methods that you have available when you were talking about those stream consuming, and do not ever try to call these explicitly in your code when you're using your streams. Just use it as you would with any other normally stream object. So a couple points that I wanted to put an emphasis on. Now let's try to do our write. Now before we do our write, there is one more method that we can implement, which is called construct, which has a callback. Now this is a pretty important method, and this will run after your constructor runs and before the stream gets to the write method or any other methods that you are going to implement, such as the final and destroy. We're going to implement these in just a minute. So this construct will run after your constructor is complete and before you call this callback. So if I do a set timeout, and in that set timeout I'll call this callback,
And the set timeout might have this 5 seconds duration. So what's going to happen in this case is that this write is not going to happen after 5 seconds. So this will call my constructor, and then after my constructor is done, my construct method will kick in. Now, until I execute this callback, all the other methods will be paused. Now, some of the things that you can do in the construct method would be initializing your data, maybe opening a file or opening a resource or whatever, and also do some asynchronous code. So let's try to open the file that we're trying to write to here in the construct method. So I'm going to first include the fs module. So const fs equals require node.fs, and we're going to use the callback version. So I'm going to say fs.open. I'm going to first specify my file name, which is right here, and the flag, which is going to be w, and my callback function. So we're going to have an error and our file descriptor, which is just a number, and we need to use this file descriptor later on when we want to write to our file or read from it. Actually, in this case, we're only going to write, but also when we want to close a file, we have to use this file descriptor. So when we open our file, what we're going to do is to first check for error. If we have an error, we're going to call the callback function and pass the first parameter to be that error object. So if you just call this callback and don't pass anything, it will indicate that the construct was successful, and we will move on with our rest of the code. But if you do pass an error to it, the stream object will automatically handle that for you and exit the stream and indicate that, hey, we have an error, we cannot construct our stream. So else, if we do not have an error, what we're going to do is to save this fd variable to our stream object, because we're going to need to use it in all the other methods. So I'm going to define a new variable here, so this.fd, and I'm going to initialize it to null, because when we were just starting out, we don't have a file descriptor, but when we get to this point, we will have a file descriptor, given the fact, of course, that our open was successful. So this.fd equals that fd. And then when we're done, we're going to execute the callback like this. So I'm going to write some comments here. This will run after the constructor, and it will put off all the other methods until, let's say it will put off calling all the other methods until we call the callback function. And here I'm going to say no arguments means it was successful. And if we do pass an argument, it means that we did have an error. So if we have an argument, or if we call the callback with an argument, means that we have an error and we should not proceed. All right. So this is our construct method, and now in our write method, let's just call the file descriptor and see what we have. All right, so this.fd, and it's not a function, so let's just log it. So console.log this.fd, and let's also comment out these final and destroy. Just write to it once and see if we could get the file descriptor. So I'm going to open up my terminal. I'm going to navigate to custom-writable, and I'm going to run the code. And it looks like we have an error. Let's see what the error is. Path arguments. Well,
yep, we're not passing a file name to it. So let's do that. So file name should be, let's also create a file, and I'm going to call it text.txt. So this is going to be the file that we're going to write on. So file name text.txt. All right. Now let me run it again. And now we do get our file descriptor, which is, as I said before, is just a number. Now in our write, what we can do is to just write to that file. Now notice that if we do this, it's not really going to be helpful at all. I mean, it's just like that first solution that we wrote right here, right? We're writing every single time that we receive some amount of data. So what we can do instead of just writing every single time is to maybe write whenever we reach the high watermark value. So let's just do this pretty quick. So in my constructor, I'm going to define a new variable, and I'm going to call it maybe this chunks, and which is an array. Now we were going to receive these buffers, so this chunk is a buffer, and we're going to push it into this chunk. And we're going to check its size and say, if the size reaches that high watermark value, then we're going to empty it and write all the data down to our internal resource, which in this case is just a file. So let me also define another property. So this dot chunks size maybe, and it's going to be initialized to 0. So we're going to increment this value by whatever the size of the buffer is that we're pushing to this chunks. So let's now do a bit of checking. So actually, let's first, let's just push this chunk to that. So this chunks dot push chunk, and then this dot chunks size, I want to say plus equal to chunk dot length. So I'm going to push that buffer into my chunks, and then I'm going to increase its size. All right, and then I'm going to do a check, and I say if this chunks size is greater than this dot writable high watermark. So if that's the case, we're going to do our write and empty this chunks. So I'm going to say fs.write. So we have to first specify our file descriptor, which is this.fd. And with that in place, we have to specify our buffer, which is going to be all those chunks, but we need to concatenate them together so that we have one single buffer. So we can use the buffer.concat method to do just that. So I'm going to say buffer.concat this.chunks, and then my callback function, which is going to have the error as its first parameter. And what I'm going to do here is to say first check for the error. If we do have an error, just like here in our construct methods, we're going to call this callback and pass that error in. It indicates that we have an error and we should not proceed. So I'm going to say, if we have an error, just return callback and error. So just call the callback function and pass this error object in. Now if we don't have an error, we're just going to say this.chunks equals an empty array again, and this.chunks size equals 0. And then we're going to call our callback function like this. And if we don't get to this if statement, so else, if our chunk size is less than the high watermark, we're just going to call the callback function, and that's it. All right. You know what? Let's just for fun also figure out how many writes we're doing to that file. So I'm going to define a new property here and call it this dot maybe a number of writes, and I'm going to initialize it to just 0, or let's just name it writes count. All right. and I'm going to use it every time I do a write. Before I call the callback function, I'm just going to say that ++ this dot writes count. And I'm going to say ++ because this is slightly faster than this. Not that much, but because we're doing a lot of writes, we have to try to save as much time as we possibly can. So saying ++I is faster than saying I++. Now, I'm not going to explain why. Google it if you want to know, but, well, that's a fact. It's really related to JavaScript and nothing to do with Node.js. Alright, so our write function is pretty much done. So let's run the code and see if we can get this buffer into this file. So I'm going to run it. First check if we don't have an error. So, no, we don't have an error, but let's try to open the file and see what we have. And as you can see, we don't have anything. And the reason is we're only writing when our chunk size gets to the size of this watermark value, which we define it to be 1800. Now, something else that we have to do is to implement this final code. So this is going to run after our stream is done. So here, we're going to grab all this value and just write it, right? So I want to say, and actually the first argument is callback, so we need to call this callback when we're done, otherwise Node will not be notified that we are done, and we'll just keep waiting or return an error or something like that. So I'm going to say fs.write, just like before. I'm going to specify the file descriptor, and then buffer.concat, and it's going to be this.chunks, and then a callback function, and its first argument is going to be error. So if we have an error, we're just going to return and call the callback function, but with that error object like this. Otherwise, we're going to set the chunks to be 0 and also call the callback function like this. Now, if we run this, if you open that text.txt file, well, we're still not going to get it. And the reason is this is only going to get called when we call the end function. So we have to do this, right? So we have to call this end method, and when you do, it's going to notify this final method, and then we're going to do our write. So if I run this now we're going to get our writes. Now notice that this is slightly different than create read stream, because in that case, when you're using create read stream, every time you write, even if you don't call the end function, you're going to write to that internal resource, which is the file in this case. But here, we're not doing that, but you know, it's up to you. You could do something like that maybe. We're trying to do this to make it faster, but I don't really recommend doing this in the real world. Just use the fs create read stream. It's better than this code that we're writing, but this is just for educational purposes only. It's only meant to teach you how to use the stream objects themselves and create your own streams. Now we can also implement the destroy method, and here it indicates how to destroy our stream and to do some final things if we want. So here I'm going to log how many writes we did. So I'm going to say number of writes, and it was this dot writes count. And then I'm going to close the file. So if we have the file descriptor, we're going to say fs.close this.ft and then error. Now, this destroy will be called with two parameters. The first one is error, and the second one is the callback. So you have to call the callback, otherwise it's not going to be done. And here as the last callback, all I'm going to do is to just say callback either this error or that error. So if closing returns an error, I'm going to call the callback with that error object. Otherwise, I'm going to call it with the error object that was passed in. If no error object was passed in, it's totally fine. We're just going to move on. And else, we're just going to call the callback with that error object. Now this could be null, that's totally fine.
If the stream is destroyed completely and without any issues, this error object will be null. But we do have to call the callback. Now also, one more point, you should never do something like this. Maybe say throw error or new error or things like this. Never ever do this. If an error happens, what you should do is that you should pass it to the callback as its first argument. And that's all. That's how you handle errors where you're implementing your own streams. So every time you have an error, just pass it to the callback and Node.js will handle it for you and do the rest of the things that it needs to do with the stream itself. Again, the same is true here. Every time you have an error, just pass it to the callback and do not ever try to throw an error or emit an error event like this. This is very bad practice and it's not really meant to be used this way. So never ever do this. Now this final event will be called before the stream is about to be closed. And after it's done running, when you call the callback, it's going to emit a finish event. So we could say stream.onFinish, and I'm just going to log stream was finished. So let's run it. And we can see that stream was finished. If we take a look, we have our writes. And we get number of writes 0 because we're only incrementing it here in our write, but we're actually doing the write here in our final. So it's expected we're going to get it to be 0. And I need to remove one space here to make it more consistent. All right. Now we get this finish event because we call this end and we implemented this final method. If I don't call this callback, so if I just comment this out and run the code again, you can see that we're not going to get these logs, because if you don't call this callback, this finish event is not going to be emitted and you're not going to get to this point. And also, you can't even get to this destroy function, because this destroy will only happen after you are done with this final method. So we saw that we didn't even get this number of writes log. So let me just uncomment this callback, and I just noticed that here it should be 2 of these characters and not 1. The or tag should have these 2. Alright, so at this point we're pretty much done with our Writable Streams. So now this stream that we're getting is just like if you run something like this. So const stream equals fs.create write stream. So technically we should be able to do everything that we can do with this stream using also this stream. So what I'm going to do right now is to just run our first code, which was this write many, but now using this custom class that we just created. So I'm going to go to this write many file, and I'm just going to copy from this point up until actually all the file. So I'm going to copy it all, and I'm going to paste it right here. Let me just zoom out a little bit. So I'm going to paste it right here. I'm first going to remove all these code. I'm going to paste it. And let's remove all these logs. And also move the require statements at the top. And I'm just going to name it fs promises. And let's also do an update here, wherever we were using a promise, which is the only place. And now, rather than trying to get my stream like this, I'm just going to paste this code there. So I'm going to cut it out and paste it here. All right. So this should just work fine. And let me also change it back to, let's just not specify the high watermark value to make it to the default value. And this is our number of writes, which we're doing how many? It's right now at, let's just try 1 million. So 6 zeros. I have to remove one more. And yep, this is pretty much it. Stream.end, stream.write.
train and finish. And we're also timing our code. So we're writing to this test.txt file, which is right here, and I'm going to delete it and run the code and see what we're going to end up with. Alright, so let's run it. Node custom writable.js, and we're done. And number of writes, you can notice that it's 481. And where is our, oh, we have 2. So what's going on? Yeah, we have an issue here. Actually, we don't need to open the file at all. Why am I doing this? Why did I change it to this? So we don't need this. We don't need a file handle. We're just creating it like this, and we don't even need to include this fs promises. My bad, sorry. So let's delete all these files. All right, and now let's run it. We have file handle close. Yeah, that's right, we don't need to do it here. We're closing the file handle here in the destroy function, actually methods. Now every time a function is associated with a class, it's called a method. And every time it's just a standalone function, something like this, this is called a function. So I keep using these two terms interchangeably, but that's really how it should be. So a function is just a standalone function that doesn't belong to any class, but a method is a function that is for a class. So that's something that you probably need to know, but don't really focus too much on it. I might just use these terms interchangeably. All right, now let's run it again. Should work now. And yep, cool. So let's now take a look at our text file, and we were getting that same exact file. And it's working pretty good. We implemented our own stream. Rather than using fs.createWriteStream, we're using our own file WriteStream object. And if you want to compare the speeds, well, here, this code ran, did we put it? Wow, we forgot to write these for this one, but I assume they're pretty much the same. You know what, let's try it. So I'm just going to put the execution time. So let's say execution time and number of writes. How many writes should we do? Well, let's not do 1 million because it's quite fast. So let's instead do 10 million. So 7 zeros, right? So 3, another 3, so I just have to remove 1, and now it's 10 million. And I'm just gonna put it right here. Let's move them down here. So number of writes, this, and execution time. So let's measure how fast this code will run. So I'm going to navigate to this write many function, actually write many file. So write many, and I'm just gonna execute that code. It'll take probably 2 seconds. Yep. So this took 2 point. Let's run it 3 times and get the average. So 2.7, 2.6, and well, we could just say 2.7 seconds. Like this. Now here we're running it for 10 million times, but here we're running it for only how many? For only 1 million times. So let's do the same thing with our custom writable, and we should have 7 zeros here, so I have to put 1 more, so now it's 10 million. And let's now run it and see how fast our code will be. So I'm going to navigate to that folder, custom writable, and I'm just going to run the code. Should be fairly similar. Yeah, it's 2.3 seconds. Well, I guess it's a little bit faster, but still stick with that create read stream rather than trying to do it. It's like this. It's probably faster because we're saving them here in this chunks array, and then we're doing the concatenation. We're not really making use of that internal buffer that much, but I don't know. Let's also measure the memory usage. So it's around 56 megabytes. So memory usage is also the same thing as before. Now if I just put one more 0 here to make it run a bit longer, so it would probably be around 20 seconds now. So let's measure my memory, and yep, that's around 30 megabytes, 50 megabytes. So we have a good memory usage and also a good speed time. If I take a look at disk, you can see that we have written like 800 megabytes, and if it gets to around 1 gigabyte, it'll be done, and now it's done. So this is our custom writable, and what did I do? Right, so I'll save and close this. All right, so this is how you can implement your own writable class. Now, some of the points that you have to learn is that you first have to extend from this writable object, and then you have to implement these methods. Now, there are some best practices and something to watch out for. For example, not throwing an error here, or not calling the functions here. I mean, for example, not calling, I don't know, this dot write, or here you shouldn't run this dot underscore write. You should always use your stream just as you would with any other streams. So there are some best practices, we talked about them. They are also mentioned in the Node.js documentation, so I highly recommend you to read that as well. And I guess we're pretty much done. And also one more point here, if you are implementing your own streams, you will find a lot of packages out there that are using this, so they are implementing their own packages. Something that I can just say off the top of my head would be Busboy. It's a package that is one of the dependencies of Malter, which is used for uploading files. So if you take a look at the source code, you're going to see that it is implementing its own writable and readable streams. We're going to take a look at some of those packages at the end of the video, but right now this is all that I want you to take from this part of the video. And also here we're writing to a file, but you could really do anything you want. You could maybe write to a network card, you could, I don't know, write to another process. It's all up to you. And we're going to see more examples later on in the course as well. Now let's also take a look and see how many times we're draining here. So I'm going to just use a variable and define something here, maybe let d equals 0, and then just increment it. So each time we do a drain, we're going to increment this value by 1. And right here in our finish event, let's just log maybe number of drains and log that d variable like this. And if I now run it, let's also change it back to 10 million. Actually, just 1 million. If I run it, you can see that number of drains 480 and number of writes 481. Now, number of writes should be one more than this. Actually, you know what? Let's just put something else here. So every time we write, let's also increment that writes count as well. So let's also increment it in our final. So now it should be 482. Yep, that's right. And we're draining 480 times, which is the same as before. If you recall from here in this write menu, we logged how many times we were draining, and it was somewhere 480, I guess, 481. So we're draining with no issues whatsoever. If you want, you could uncomment this draining and then try to just keep writing to the stream, and you're going to see that we're going to get some memory issues. So you have to also drain these custom streams as well. It's not really that different from a consumer stream, something like this fs creates read stream or fs create write stream or things like that. So a stream is a stream, and you always have to take care of things like draining, error handling, and things like that. All right, so now we're pretty much done with a custom writable. And now let's see how we can implement a custom readable.
Now, uploading a custom readable is quite similar to this one, so I'm not really going to explain much. We're just going to write the code, and it should be fairly easy for you to understand because we're having the same functions, we have the same constructor, the same construct methods. Now we don't have this write, instead we have read, and we also have, and I think we don't have this final in Readable Stream, but we do have this destroy method. So let's quickly implement our custom readable as well. So I'm going to create a new, actually let me first close these open file, and now I'm going to create a new folder called custom readable. And here inside I'm going to create a new file called custom readable.js. So I'm just going to speed up. It's fairly similar to that previous code that we wrote, implementing our custom writable function. So this one is fairly easy. So we first have to include the object. So const readable equals require node stream. And let's also include the fs module. So const fs equals require node fs. And now I'm going to define my class. I'm just going to call it file. What did we call it here? It was file write stream. So file read stream extends readable. So what we're trying to do is just like before, we're trying to implement fs create read stream, but instead just using our own custom class. So we're going to have our constructor here. We're going to specify the high watermark and also the file name. And here we have to call the parent constructor and pass in our functions, actually our options, whatever we want, and then our file name, which should be the file name that's coming in from the instructor, and then our file descriptor, which is just null from when we're just starting out. All right, now I'm going to use the construct method. It will accept a callback. And I have a typo. All right, and here I'm going to first open. So open this dot file name, and flag should be read, and error and file descriptor, just like before. Now here, if we have an error, let's just return callback and call the callback with that error object like this. If we do not have an error, let's just set the file descriptor and also call the callback, which is very important. If you forget this, if you forget calling the callback, you're going to have some issues. All right, with the construct method in place, let's now implement the read method. Now, when you're implementing a writable stream, you would implement the write method or the write env method, or both. But when you are implementing a readable stream, you have to implement a read method. You cannot implement a write method here. In fact, my Visual Studio Code will not even give me that suggestion. But if I try to add this read method, here I have it. Now this read method accepts one parameter, which is the size. So we could say read 4 bytes or read maybe 10 bytes or whatever. So here we have to read from our source, which we're going to create right here. And let's create a file. Actually, let's move this text.txt file over to that file. So it's our small file. So I'm just going to copy it and paste it right here. So we're going to read this file and get different chunks out of it. So I'm going to first create a buffer. I'm just going to call it buff, and it's going to be buffer.alloc. Now, whatever the size is, we're going to create a buffer of that size. And then let's now read the file. So fs.read, the file descriptor to specify what is that opened file that we're going to read from, and then our buffer to fill it in with this data that's going to be returned. And then we have to specify an offset, which is going to be 0,
Now the length is going to be size because that's how many bytes we need to read, and position should be null. And then we have our error object and bytes read. So here, what we need to do is to just push something into our internal buffer. So let's first say if we have an error. Now in this case, there's no callback to call it and pass the error as its first arguments. The way that you need to handle errors here in this read method is just by calling the destroy method like this and passing the error object. And I'm going to return it. Right? So this is one difference that you need to keep in mind, which is different from that writable stream and that write method that we were implementing here. Now, if we don't have an error, what we need to do is to say this.push. Now, whenever I push here, so if I push a buffer, that is going to get added to my internal buffer. And most importantly, this event, the data event, is going to get fired. So let's first create an instance off of this object. So I'm going to say const stream equals file read stream, and actually new file read stream, and I'm going to pass in the file name to be text dot, actually in a string, so text.txt, and now we could add the data event right here, and we're going to get different chunks. So let's just lock the chunk for now, and let's just push something here. Let's push maybe a simple string, so buffer.from maybe string, something really simple. And let's actually put it right here and comment out these code. Now if I run the code, let's see if we're going to get an error. So I'm going to navigate to custom-readable, and now I'm going to run the code. Well, it keeps happening over and over again, and the reason is we are not indicating that this is going to be done. We keep pushing, and every time we push, what is going to happen is that we're going to emit this data event, and then when it's done, then we're going to run this method again, and we're going to push again. Now what we can do to indicate that this method is done and get to the, was the event end? Yeah, it was. Sometimes it's confusing between end, finish, close event, and all of these. That's why I don't recommend you memorizing them, and just take a look at the documentation every time you want to use them. But yeah, it was .end, if I'm not mistaken. Yeah, .end. Actually, not .end, but an event that its name is end. So here, we're not getting any arguments, and it just indicates that we're done reading. So I'm going to just log in. Stream is done reading. If I execute it, we're not going to get to that point because, well, we're not pushing null to our internal buffer. We're just pushing, and pushing. So it's going to run infinitely. Let me just exit out of it. I hope it's not freezed. Well, I can't exit. I guess it was freezed. I don't know. Yeah, here we go. All right. So if I just push a null, so I'd say this.push null, and let's do it after maybe a couple of seconds. So set timeout, and I'm gonna push something. Actually, I'm gonna push this null after 1 second. Now let's run this code, and after 1 second, we should now get that done event. Actually, it won't work. I don't know what I was thinking, because every time this whole method is running, and we're not really going to get to this point. So rather, what we can do is to, specify a variable here and then add it, and then check if we get to that point, just push null. So if I, instead of this, just push null, and now we're just going to get that end event. So stream is done reading. We're not really actually reading anything, so we're not getting this data event at all. So this is how this read method works. There is no callback to call. You just indicate the state by pushing, and that's all. If you push null, it indicates that we're done. Otherwise, it keeps going, and it keeps emitting this data event, and yeah, life will go on. So let's just go back with our code. Now at this point, if we don't have an error and we read a chunk of that file, and now we have it in our buffer because we filled it here in this function, now what we need to do is to just push this buffer into that internal buffer of this stream. So I could say this dot push. Now what we can do is to say if bytes read, which is this argument, is greater than 0, it means that we read something. We're going to do something on this buffer, because remember, in our previous code that we wrote here in the copy, sometimes we get this buffer and sometimes we have some zeros at the end, right? And if we just try to write it, we're going to get some weird null things in that file. So what we can do is to just remove all those zeros, and one way we can do it is to just use the subarray method, and it accepts a starting index and also an end index, which is going to be bytes read, right? Now otherwise, if bytes read or bytes read is not greater than 0, or it's 0, we're just going to push null to indicate that, hey, we're done. We're not going to push anything else. So let's just take a look at this method. So I'm going to run node, and I'm going to create a buffer. So buff equals maybe buffer.from text. And now we have our buffer, which has 1, 2, 3, and 4 bytes in it. If I call that subarray method, I can specify a starting index and also an ending index. So if I specify 3, now my buffer is going to lose its last value. Or if I just specify 1, I'm just going to get the first item. So it specifies to get the elements starting from 0 all the way up to this index. So that's what this subarray does. So if we have a buffer like maybe this, and then a couple of zeros. So in this case, bytes read will be 3, right? So we specify that we want from index 0 up until bytes read, which is 3. So up until this point. And then we're going to dismiss all these zeros. So we have a buffer that's just the right size. Okay. And well, actually I think we could have done the same thing here in copy. So instead of doing all these crazy things, we could have just used that subarray method and make use of that bytes read, and you know, just subtract those failed bytes. Yeah, we should have done that. But anyway, it's also valid, so if you want, feel free to try it again, but using this method. And I guess our code will be even faster just using subarray. But anyway, so now that we're pushing to our internal buffer and we're actually reading something, let's also try to, actually let's just run it and see what we're dealing with. So I'm going to save, and I'm going to run the code. And yep, looks like we have read all the file. Let's just run the toString. So toString UTF-8. And yeah, all is good. We read the whole file, and at the end we got this log. So we also emitted this end event right here. Now in the destroy method, here, just like before, we have an error and a callback. And here we could say if we have the file descriptor, just go on ahead and close that. So fs.close this.ft, a callback with an error object. I'm just going to do it like this. So return callback. If you don't specify those curly brackets, it's going to automatically return this expression that's going to come after it. Error, or that other error from this first parameter here. And what else? If we just don't have this, let's just call a callback with that error object, like so. So notice it's really similar to that thing that we did previously in custom writable. We have destroy, we don't have final, but we have destroy, we have construct, and it's fairly similar to that one. The only difference is this read method and also this push. And I'm just going to put down a comment here and say null is to indicate the end of the stream. All right. And yeah, you can see that it works pretty darn similar to that create read stream that we used before. Now, feel free if you want, use it with this read big code, just like we did before with that write mini. Try to copy this whole code, and instead of using create read stream and create write stream, use our custom classes. So use files read stream, if that was the name, yeah, file read stream, and also file write stream. So you could just change these two, and that's it. All the rest should work just like before. And actually, well, there's one small difference here. We're using the high watermark value, which is by default 16 kilobytes, but fs create read stream uses 64 kilobytes. So that's one slight difference, but you could use both. Now, again, in production, don't try to reinvent the wheel. This is just for educational purpose. Sometimes you really have to implement your own streams, and it's really useful. But if it's already implemented, especially in the Node.js source code, just use that one. I mean, we could have some issues here. You know, we are humans, we make mistakes. Their code is really, a lot of people are watching the code and a lot of people are constantly working on it. If there's a bug, they keep fixing it. But if you just come up with something, it could definitely be worse than that solution that many people have been working on, and it's been there for years. People have been testing it, so that's something to keep in mind. But well, yeah, here's how you can implement a readable stream if you want. Now you can come here and read the documentation, and you should be able to understand all of it. So where is it? Here, implementing a readable stream. Here you can again see all the options that you can specify in the constructor. And if you scroll down, and again, you can also not use ES6 and not use the class syntax, and then just do it using the classical JavaScript format. Here we have construct, and here we can see that it really emphasized that this construct method must not be called directly. Okay, it may be implemented by child classes, so it's not really mandatory to use this construct, but you could. And if you do that, this is what will happen. So you shouldn't ever do something like, you know, say stream.construct or something like that. It will automatically be done for you. So after you call the constructor, after this is done, the construct method will kick in. And here's that method that we talked about. You only specify a size, which is number of bytes to read. And when you're done, you just push a chunk. Destroy, readable.push, chunk. And this is that thing that we saw. So we have that read, and then we push something. We push a chunk, and then you could also read what's happening here. And if you push null, it means that it signals null chunk, and it means that our stream is now done, and we're going to get that end event. Now when we have an error while reading, we should just use this destroy method. And here's one more example that you can see. Alright, now we're pretty much done with this custom readable class. And now let's talk about a duplex and a transform stream. Now, a duplex stream is just like a writable and a readable. So let me just first quickly create a new folder and call it custom duplex. Now, we're not really going to spend a whole amount of time here because we already understand all the things we need to understand. Now, we only have this duplex in JavaScript because if you see here, JavaScript does not have support for multiple inheritance. So this class is there, which extends both a readable and a writable class for you. So if we had something like maybe class my custom duplex extends maybe writable and readable. So if we had something like this in JavaScript, we wouldn't need to have this duplex in the first place. All right, so when you're implementing a duplex, you have two different streams, and these two parts work independently from each other. And so when you're implementing a duplex stream, you have to specify the write, which is here. And also in addition to this one, you also need to specify your read method. So you're reading from one place and you're writing to another place. Now these two places could be completely different from each other. All right, so let's see how this duplex stream really works. So let's say that this is our duplex object. Now this duplex stream has a readable internal buffer and also a writable internal buffer. So a duplex stream has two buffers, comparing to a writable and a readable stream, which only have one buffer. A duplex has two internal buffers. Now, these two sides of this duplex, a readable side and a writable side, they are totally separated from each other. Okay, they don't have to be related to each other at all. So they could maybe read from one source and write to another source. They don't have to be any relation whatsoever. Now, in the readable side, you push data like this. So you call stream.push data, just like that we saw in that _read method. That's how you push data into a readable stream. And the data could come from maybe source.txt. So you read from this source and then you push, and then you get the chunks here in the chunk variable. And you could really do nothing with that chunk. You could just let it be there, or you could maybe log it to the screen or do whatever you want. So you don't really have to do anything with this. You don't even have to call this on data. You could just keep it in a paused state, and that's totally fine. Now again, in the writable side, you write using stream.write. So you push the data in that internal buffer, and then once it's filled, you're going to get the data out, and maybe you could just write it to whatever.txt file or any other destination. So these two sides are not related to each other at all. They could be related. You could set it up in a way that they could be related, but they don't have to be. You could read from a file maybe, and you could write to a network card, or you could write to another process. They don't really have to be related to each other at all. So you could maybe change this readable to a paused state, and while it's happening, write to your writable side, or maybe keep it flowing and also keep writing to it. These are totally separated. Now there are some use cases where a duplex would be useful. Now in Node.js, there's one module that's using it, the net module TCP sockets, and we're going to see that later in the course. But I guess that's the only place that we're using duplex in Node. But something that's really interesting here, if we say that we are getting the data into our readable internal buffer like this, so we're reading from one source. Now, rather than just using a data event and just maybe logging the chunks or something like that, if we try to write those chunks to our writable internal buffer like this, so we get the chunks out and then we write that to our writable internal buffer, and then we get the data out. Now this is a special case of a duplex stream, and it's called a transform stream. So If you do this with a duplex stream, you're going to end up with a transform stream. Now, a transform stream is just inheriting from duplex, but its _write and _read methods are set up in a way that would just pass the data around between these two internal buffers. Now, technically, if you just pass the data around and don't do anything with it, you still have a transform stream, but it's usually called a pass-through stream because you're just passing the data around and you're not really doing anything with it. But if you do some operations here in this passing around, maybe compressing the file or encrypting the file, or I don't know, maybe if it's a text file, just making all the letters uppercase or something like that, well, in that case, it would really be a transform stream, but it doesn't have to be like that. You could just pass the data around and it's still, well, called a transform stream. But this is how a duplex and a transform stream work in Node. Now, let me try to quickly implement a custom duplex stream. Now, I'm going to do a lot of copy pasting because it's really same to this custom readable and custom writable. Feel free to just watch me do it, or if duplex is still not really making sense to you, you could do this as well. So I'm just going to copy this portion, paste it in, and instead of including the readable, I'm going to include duplex. And let's now define our class right here. So class, I'm just going to call it duplex stream. Let's see how fast I can do it. Extends duplex like this, and then we're going to have our constructor. And what else? We're going to have our construct method, but our constructor will now accept some different things. So in our constructor, we're going to accept maybe a writable, high watermark, and also a readable high watermark. Now again, you could see these options here in the implementation where it says implementing a duplex stream. Here you could see that we have readable high watermark and writable high watermark. So we're going to pass these two. And also we're going to have two different file names. So readable, maybe readable file name, and actually just read file name and write file name. And in our super, we're going to pass in this one and also this one. And we're going to now set our variables. So this dot read file name should be read file name, and this dot write file name should be write file name. And we're going to have read ft and write ft like this. And we can now also have the chunks and chunks size. So let's also grab these two from our writable. So I'm going to grab the two. We're not going to do this write count, but just these two chunks. And now we have our construct. Now we have to first open maybe our readable. It doesn't really have to be in any kind of special order. And oops. If we have an error, just return the error. Else, just save the read ft into that ft. And I'm going to call it read ft like this. I'm going to pass it in. And then if it is successful, let's have some callback else. So fs.open. It will be better to use promises at this point, but who cares? Let's just move on with it and implement this duplex stream as fast as we can. So this dot write file name mode should be right, and we're going to have our callback error and write ft. If error, just callback error. Otherwise, set this write ft equals write ft. and call the callback with no error at all. With no arguments whatsoever. All right, so this would be our construct method, and let's now also implement our write. I'm just going to copy the write method from here. So I'm going to copy this and paste it right here. We're going to get the chunk encoding callback, and let's see, writable high watermark value. Writable high, just want to make sure that we are getting that correctly. Yeah, we have this property available on it. Now we're checking for the writable length. We're writing, we should write to write ft buffer dot concat this dot chunks. If error, just return, otherwise just do the callback, and that's it. That's just pretty much it about. And also we don't have this writes count, so I'm going to remove it. So this would be our write method. Let's now copy the read method. So I'm going to copy this one over as well. We're going to read, but from read ft, like this. We're going to get the buffer, and we're just going to push it to it. But we do have access to this push method, just like before. And we also need to, well, we don't need to do anything else here in the read. Let's also specify our final, which is for the writable side. So I'm going to copy the final, and I'm going to paste that in. We have our callback. We should write to write ft the buffer, this chunks of an error. We don't need to increment the writes count. We no longer have that variable, and this is pretty much it for the final method. Let's now implement destroy. Now in the destroy, I'm not really going to close the files. I'm just going to, just call the callback, and that's it. Let's just keep it as simple as possible. So I'm going to say callback, maybe error. Now technically you should now here close those files, but we're just trying to create something as fast as possible. So let's now use this duplex stream object. I think it should be working fine, but we might have some errors, but let's give it a shot. So const duplex equals new duplex stream, and here I have to specify read file name. So let's create two more files. So read.txt and another one, and I'll call it write.txt. So read file name should be read.txt, and the next parameter is write file name, which should be write.txt. Right, now we have our duplex. Let's just run it and see if we get an error. So navigate to custom-duplex, and I'm just going to run the code right now. Yep, we have an error. Let's see what this error is. The path argument must be of type string, or well, we have a problem here in read file name. So let's see what's happening. Yeah, it looks like I have a typo. Yeah, I have added an E here, which shouldn't be. And let's see if we are done. Yeah, we're done. So we're now creating our duplex stream, but let's try to write some things to it. So I'm going to say duplex.write. So I'm going to say buffered from this is a string, maybe try a couple. So I'm going to say 0, 1, 2, 3, and let's also end it. I'm just going to say end of write. All right, let's give it a shot. No error, and if you take a look at file, now we have some string in it. We should also be able to insert a character like this. Yep, we can. So yeah, we're writing some things to our duplex stream, but at the same time we could also read from it. So I'm going to say duplex.onData. We're going to get the chunks and let's just log it. So I'm going to say log chunk .toString UTF-8. Now we're not going to get anything at this point because, well, this read file is just empty. So if I just put in something, so this is some text and more and more and more. Let's try it again. All right, now we're reading and we're also writing. So we read and we write. So this is an example of duplex. Now this read destination could be maybe on another hard drive really, or in any other location. They don't have to be in the same directory or anything like that. Or we can also not write it all to a file and instead write to our network cards or write to any other places. It doesn't have to be related to read. They are totally separated, all right? So this is one quick example of this duplex stream. I know it sometimes might be confusing, but now that we have implemented this, it should now be pretty darn simple for you to understand. All right, so that's about custom duplex and duplex streams. That's pretty much all you need to know about duplex. And now let's create an encryption and decryption application. So I'm going to create a new folder and call it encrypt dash decrypt. Come on. All right, encrypt decrypt. And let's create a new file and just call it encrypt decrypt. Actually, just, you know what? I'm just going to call it encryption.js. All right. Now here, let's try to implement a transform stream that will encrypt our data. All right. So now I just want to make something extra clear. Encryption and decryption. So these two are the opposite of each other. So encryption and decryption and compression, and I don't know what it's called the other way around, maybe unzipping. So oh, we have a helicopter passing by, so let me just wait for it to go by. Hopefully it's not ruining my voice. Alright, it's pretty much gone. Alright, so where were we? Encryption and decryption and compression and hashing and salting and decoding and encoding. These are completely separated from each other. Now, they are really similar to each other because we're in all of these, we are dealing with the binary data. We're dealing with the zeros and ones. Now, if we encrypt the data, we're making it into something that no one else can really decipher what's going on unless they have access to what we did. Now, the decryption is just the other way around. So if you encrypt a text, some data, so maybe, you know, this is data. If you encrypt it, we're going to get some gibberish. So if someone tries to read it, they're not going to understand what's happening unless they run it through your decryption application, and then they're going to get the original data. All right, so this is what encryption and decryption is. Now, compression, what you're trying to do is to compress a data. So if you have maybe a pattern like this, so we have 0, 1, 1, 1, 1, 1, you could do something and say, okay, I'm going to convert all of this into maybe just a 1 and maybe a 0 and a 1. So you are technically reducing down the number of bits that you have in that file. So you are compressing the data. Now, we usually compress data when we are sending the requests and receiving the responses. So that's one good example to compress. So we're dealing with zeros and ones. Now in encryption, it's the same thing. Maybe you could just take each value and add 1 to it, and then you could end up with something that is not really decipherable by a normal person. Now, hashing and salting, it's different from encryption, but I'm not really going to get into it too much right now. You hash something, you make a password into something else, and you also have this code that you use to, you know, switch between that. Actually, you can't go back. So if you hash something, you cannot go back. What you can do is to get an input and hash it again, and if you do get the same values, it means that, you know, your password was okay. And salting is something related to hashing. It's not the opposite of hashing, but it's something that you use in hashing. Now, encoding and decoding. Now, here when you encode or decode, you are getting some zeros and ones, and you are converting it to something that is understandable. Maybe you are converting it into an image, or into a text using a character encoding, or into a video file, or into a PDF file, or whatever else that you want. So you have to create an encoding application and say, all right, every time I see these, maybe display a pixel at location maybe 23, 400, maybe 409. So every time I get this binary value, I'm going to display this at this location, and whatever binary comes after it, that is going to be my color code. So I'm going to display here maybe a color code that's red. So it could be something like an image encoding or decoding. Now for string and characters, it's just like that one. You say that every time I give this value, I'm going to display T on my screen. I'm going to display G or 3 or a new line character or a new tab character or just a space or whatever. But this is the concept of decoding and encoding. So all these are some important computer science topics, and you should know about all of them. Pretty much all of them are really important. Now in Node, encryption and decryption and hashing and salting, these two are done using the crypto module usually, and compression is handled using the zlib module. So here we have zlib, here we have the crypto. Now you don't really have to use these modules. There are some other modules you can use as well, but you could also use them. And for encoding and decoding, well, we saw the infamous buffer. So buffer is heavily used here, but actually we just have text encoding in Node.js, right? So we don't have an image decoding and encoding in Node. We don't have a video encoder in Node. Maybe you could install some packages out there, or you could implement your own. It's really up to you, and it's not that hard. Well, yeah, it definitely takes some time, but Node.js can handle it if you write the code. So you could say the buffer, set the buffer in a way to, you know, return an image to you or something like that. So you need to understand these and also be able to distinguish between them. But right now, we are trying to create an encryption application. So let's see how we can do it. So I'm going to first include the transform object from Node stream like this, and then I'm going to create my class, and I'm just going to call it encrypt. Which actually extends transform like this. Now, when you are implementing your transform stream, well, we talked about that a transform is just inheriting from duplex, but you're not going to really implement the write method and the read method and construct method and things like that. If you do that, there's a really good chance that instead of using a transform, you should use a duplex. Instead of a write method and a read method and, you know, destroy method, all of these are done for you in the transform class. So they're all done for you. You will inherit all of them, and you don't really have to worry about them too much. All you have to do is to implement the underscore transform method, and that's all you need to worry about. Now, the transform method accepts a chunk, and that is what we write to it. Right, so just like before, you say stream.write. If you say encrypt.write, you're going to get it here in the chunk. And well, you're also going to have an encoding just like before, which if you don't specify, it's going to be a buffer. And just like before, just like an underscore write, we also have a callback. Now, what happens here is that when you're done with the data, you could do two things. You could either push, so you could push the data in, and if you do this, you're just passing the data around, right? So if you do this, it's just like that underscore read method we pushed. So now this is going to become a source of reading for the next stream that's getting its data from this encrypt class. All right. So you could either push, or you could just call the callback and specify the chunk and some errors. What was the parameters? Let's just take a look at the documentation. Where is it? Transform. So it should be somewhere here. I mean, duplex, so transform. Yeah, it's right here. So we could either push, or we could just use the callback right there. So if you use a callback, your first parameter is going to be your error parameter, and your second one is going to be the data that you're going to pass around. So you have both options. So either this or this. Feel free to use whatever that feels more intuitive to you. I'm just going to use push here in this case. So yeah, just like that, we have our transform stream. Now we're not really encrypting anything, but let's just give it a shot and see if it works. So I'm going to create my encrypt class. I'm going to say encrypt. Actually, in this case, it's more like a pass through. So, but let's just give it a shot. So encrypt equals new encrypt. And notice that we don't even have to call the construct method. All of this is done for you. All you have to do is to just specify this transform method, and that's it. Now, something else that I'm going to do is to just put two files here, one to read from and one to write to. So I'm going to create a new file, say read.txt. This is some text to read later. And I'm also going to create a file called write.txt. All right. Now let's include the fs module. So node fs/promises and that thing. So async and immediately invoked. So const read file handle wait fs.open, and the file was called read.txt. We're going to read from this, and next one is going to be write file handle fs.open write.txt w. Now with these two in place, let's create our stream. So read stream equals read file handle dot create read stream, and write stream is equal to write stream, write file handle dot create write stream. Okay. And now what I'm going to do is to just pipe these two together. Let's also move our encryption inside. And now I'm going to pipe them together. So I'm going to say read file handle dot pipe. While in production, remember that you should use the pipeline instead of just pipe. So I'm going to pipe it into my pass through stream, or more precisely my transform stream. And then I'm going to pipe the result out to the write stream. So write stream. Looks like it's not recognizing this, so we have a typo somewhere. Yeah, it should be read stream, not read file handle. So we're getting the data from one stream, we're piping it to our encryption transform stream, and then we're getting the result out and we're piping it to write stream. If I run this, my write text should have the content of this read.txt file. So let's give it a shot. So I'm going to go to encryption, encrypt, decrypt folder, and just run the code. So node encryption.js. We have one error, which is read file handle pipe. It's not a function. Looks like I forgot to save. Let's try it again. Cool. So we don't have an error. And if I take a look at write.txt file, you can see that we passed the data around from read to write. So it's kind of like copying. Now what you can do is to just log the chunks right here. So chunk.toString and UTF-8. And here we can see the chunk. So this is how you would implement a transform stream. We just implement this function, actually I should say method, and you get the chunks and you push it around to become available to be read for the next stream, and then you do the pipe like this. But now let's actually do our encryption. So the way you can encrypt the data, now if you think about it, we're getting our buffers and the values like this. So this could be one buffer, so something like this. So A4, maybe 1A, 11, or 20, and so on and so forth. So if this is our buffer that we're getting, because this chunk is just a buffer, right? And each hexadecimal number, you know, that corresponds to 4 bits, and also it's actually a number. So this 34 is just a number. If I open up my calculator, if I switch to base 16 numbers, which is basically just hexadecimal, and if I put that number, what was it? Yeah, 34. So I just put in 34 in. Now here we can see the number of bytes that we have occupied, which is 8, of course, because each hexadecimal number corresponds to 4 bits. And also, if you just want to fill all of them, you should use the F, because if you use it, it means 15, and actually just one F, it's 15, and it occupies 4 bits and it fills all the 4. So if I just keep putting Fs, I'm going to occupy all of these. But our number, which was 34, now this is 52 in decimal. Right, so 52, the way you count, right? 1, 2, 3, 4, 5, 6, and all the way to 9, 10, 11, and so on and so forth. So this hexadecimal number is just another way to represent a decimal number. Okay, hopefully that's really clear for you right now. Now, number, what was this number? 52. Okay, so 52 as a number is totally different from 52 as a string. So these two are not equal to each other whatsoever. They're totally different. This 52, oh, there's another helicopter passing by. So we'll just wait for a couple minutes until it goes away. All right, we're clear. So 52 as a decimal number is totally different from 52 as a string, right? 52, it corresponds to number binary 34, and everywhere you go, in any computer, any Linux machine, this is the number that corresponds to 34. Doesn't have to do anything with any character encoding, with any operating system, with anything. This is how it is. But this string, it could be many different things. It depends on how you want to represent character 5. So on Linux, this could have one binary value. On macOS, it could have another binary value, but actually we should say on different character encoding. So if macOS and Linux, they both use UTF-8, this 52 will have the same binary number in both devices. So here it depends on what character encoding we use, and then we're going to get some zeros and ones. But as a number, it does not have to do with any of these things. It's just a number. So hexadecimal 34 is equal to 52. All right, so with this in mind, one way that we can encrypt our data is by modifying these values. So something that we can do is to maybe say add 1 to each one of these. Now remember, they're just numbers, right? So we could add, we could multiply, we could divide, or anything. Now if we add 1 to all of them, technically what we're doing, we are encrypting our data. All right, so let me just show you how this works. So I'm going to just do this pretty quick using our buffer. So rather than just logging my chunk, I'm going to say, actually I'm going to loop through my buffer. So I'm going to say let I equals 0, I less than a chunk dot length plus plus I. And what I'm going to do here is to say if, we're just going to add 1 to each element of our buffer. So I'm going to say if chunk I. Now, the highest value that a buffer could hold is 2 Fs, right? And 2 Fs is equal to 255. So if it's 255, let me just show you on my terminal. So node, I'm going to create a buffer. I'm just going to call it B, and I'm going to say buffer from, string. So this is now my buffer, and it holds these values. So something that I can do is to add 1 to the first element and say buff 0 equals to buff 0 plus 1, right? And if I log the buffer again, instead of 73, I have 74. And this value that is returned is the value, but in decimal and not in hexadecimal, all right? Now, if I try to convert my buffer back to a string, so to string, you can see that it's now TT string. So it doesn't make sense at all. It's not string, it's modified, right? So that's how one way we can do to encrypt our data. Now, if one value is 255, which is the highest value that a buffer could hold, because we only have 8 bits in each one of the elements. Now, if I try the same thing, but instead of adding 1, I try to add maybe 1000, what is going to happen is that this number will be returned, but if I log the buffer, well, I'm having 5C. Now, 5C is, so 5C, it's 92. So it's disregarding all value that it has, right? So I'm going to get something that really doesn't make any sense. So you shouldn't really try to add a value to each element that will make it bigger than 255. Now, generally, if you transform the buffer into, instead of using 8-bit for each element, you try to use 16-bit for each element. So now we have 8 bits, but rather than 8 bits, you start to add 8 more bits to your buffer. So each element is now represented using 16 bits. Now, instead of 255, you could use 65,000 for each number. So now you could really do some crazy things. So you could really multiply a number by a prime number, maybe a huge prime number, and subtract, do some divisions and things like that, and really come up with something that no one could figure out and break and get to your original data. So let's try to first add 1, but I'm just simply going to say if it's not 255, because we don't want to change the base of our buffer at this point. If it's not 255, just simply add 1 to it. Because if we add 1 to a value that's 255, we're going to lose some data, and then later on we're going to have some hard time recovering that data in our decryption class. So if this is the case, just say chunk I equals chunk I plus 1. Really, really simple. So this is basically what we're doing. We're adding 1 to all these values in our encryption. And the result is that we're going to have a data that is encrypted. So once we're done, just push the chunk in, and that's it. And you could optionally also call the callback function. So let's try this and see if we are actually encrypting our data. So we're reading from this. This is our text. This is some text to read later, and we're writing to this. So let's run our code and first make sure that we're not getting an error. So node encryption. All right, it's done. And if I take a look at write, well, you notice that we're now getting some gibberish. It doesn't make any sense at all. But the neat thing here is that if you run it now through a decryption, so if you read the 0s and 1s, and if you subtract 1 from those values, so you read it in a buffer, in a unit 8 buffer, and you subtract 1 from the values, you're going to get the original text. So let's do that pretty quick. So I'm going to create a new file and call it decryption.js, and I'm just going to paste this in. So I'm going to copy all the code, I'm going to paste it. Instead of encrypt, it should be decrypt, like this. And so new decrypt, read stream. Now we should read now from our encrypted file. So, well, I wish I had called them encrypted file and decrypted file, but let's just do it. I hope it's not really that confusing. So we're reading from write now, and we're writing to, actually let's not write it at all. Let's just, no, let's write it. So we should pipe to our decryption transform stream. Now this will decrypt my value, and I'm going to get the original data. Now I also need to do a check here. So I have to say if chunk I is not equal to 255, if it's 255, we haven't really touched it. But if it's not 255, we're just going to subtract 1. Now this way we're going to get the original data. So we're going to subtract 1 from all the values. Actually, now we have a different value, so we should technically say -1. And FFF, because it's the last value, we're not going to do anything with it. Let me also change it here. So we shouldn't add 1 to FFF, because then we're going to lose some data. And then a 4, if you add 1, I guess it should be a 5, -1, and 11 should be 12, -1, and 22 should be 23, -1. And adding hexadecimal numbers is a little bit different. So let me see if I did it correctly. So 23 plus 1 should give me 24. Yep, that's right. But if you try to add maybe 1 to A, you're not going to get A1. You're going to get a number that's after A, which is B. All right. You don't really need to know all of these. Just understand how this transfer method works, and that's it. We're doing this pretty much for fun, but the concept is the same. So now let's run our decryption application and see if we can decrypt this data. So I'm going to say node decryption, and well, looks like it's not working. Let's change it to maybe decrypted decrypted.txt, and we're going to write to it. So read and write. And let's also create a file and call it decrypted. Am I spelling that correctly? Yep. Actually, it should be decrypted.txt. It's empty. Now we're reading from this write. Actually, it's now lost. So let's quickly generate that data again. So node encryption. Now we have some encrypted data here in this write. This doesn't really make sense, but let's now try it with the decryption. So node decryption by run it. Now we're getting the right data. Now notice here we're getting some weird characters, but that's totally fine. We don't really care what they are, right? You could get a value that's not really defined in a character encoding. Now here we're trying to open an encrypted file using a character encoding. So you could end up with some values that don't make any sense whatsoever to a character encoding application. So you don't really have to get everything as a string, right? You could get some weird stuff like these. And here you can see that says, actually it doesn't have anything to do with that, but yeah. So now we're reading from this read. We're encrypting the data and writing it to this write.txt file using encryption.js. As you can see here, we are subtracting 1 from all the values. And you know what? I think I'm doing something, no, incorrectly. In encryption, now when we were encrypting, we are just removing 1 from each value like this. And then when we're decrypting, we have 34. Now this FFF is untouched. We have 84, and then we just add these ones to it. And then we're going to end up with the original data. Right? Yeah, that's right. So this is our original data, 34. After this encryption, we just add 1, and then we're going to end up with 34 again, which is our original data. Now you could try it with any string. You could really, let's try to encrypt one of those big files. So text small, not text gigantic, because I don't want to sit down and watch this happen for minutes. So I'm just going to try this with text small. I'm going to paste it in, and I'm going to change the name to read. So I'm going to first delete this read and change the name of text small to read. Actually, yeah, read.txt. Now let's run our encryption first. So node encryption.js. It's done. Now if you take a look at write, it does not make any sense whatsoever, right? But let's try to decrypt it. So let's try to read from this write.txt file and write to the decrypted.txt file. So now I'm going to run my decryption application. So node decryption.js. It'll take a second, and now if you take a look at decrypted.txt file, now we have the original data. So it's really, actually, we don't. And we have a slight problem here because we're not getting the exact values. You know what? I think it's because here in encryption, we should either check for 1 and then, so we should do it the other way around. If it's not 255, we should add 1 here, right? And in decryption, we should subtract 1, right? Yeah, that's right. Otherwise, we have to check for 1 and not 255. So my bad. So now if I try this, so let's first create our encryption file. So node encryption. Now if you open up the encrypted file, which should be in write.txt, well, now we're not getting those weird characters, but even if you do get some weird characters, again, that's totally fine. Now we can read these values, so it's not really that crazy, but, well, let's now run the decryption application. All right, now if I take a look at my decrypted.txt file, all right, so I had to pause it over a sec to really figure out what's going on. Now, this is really not going to work because you have to call the callback function after the push, or you could just use callback and pass null as the first parameter and then data as the second parameter, like this. It will work without any issues. So instead of just pushing it, I'm going to call the callback. Same for encryption. So callback null and then chunk. And let's now try it. Now, this one was also our problem. We should add in encryption and remove from decryption because we're checking for 255. But also this was another problem. So my apologies. So if I remove my decrypted file and also my write file. All right, so now I only have this read.txt file, which starts from 0 and goes to 6 nines. Now let's try to encrypt it first. So node encryption.js. Now we have our encrypted file right here, and let's now also decrypt it. So node decryption.js. Now we have decrypted file right here, which is exactly the same as the file that we started with, right? We go all the way to the end. It's 6 nines. And if you check the file sizes, so we encrypted the read, we got the write, and then we decrypted the read and we got the decrypted text. So these two should be exactly the same, and they are. So 698 and 698. And they're both 7.9 megabytes. All right, so I know that in this encrypt decrypt application, we got confused a little bit because, well, this was a bit confusing first, reading from write.txt. I should have named these better, but now, well, we have our encryption and decryption application. Now, in the real world, you're not going to decrypt or encrypt the data just by adding 1 to it. A hacker could just easily figure this out. So they could just play around a little bit, and quite fast they could figure out, hey, you had added 1 to all the numbers, so they could reverse that process. Now, real-world encryption and decryption applications would really use some gigantic prime numbers here and then do a lot of discrete math stuff to really be able to decrypt a data so that no hacker could really encrypt it or really break it down and figure out what was the original data. So HTTPS is one example of encryption, and we have so many more out there. Like so many VPNs, they are encrypting the data. Messenger applications, they are also encrypting. So when they send the data, they encrypt and then they decrypt on the target mobile. So if somebody somehow attacks this network and be able to sniff these packets that we're sending, they're not going to be able to figure out what was the original message because we are encrypting. All right. Now, sometimes they could just figure out how to decrypt, but that will take a lot of time to do. Now, I just ran the application, but with text gigantic. So this read.txt is now 10.9 gigabytes, and it ran well, pretty good. It was quite fast, I think around 1 minute, and the memory usage was really low, around 30 megabytes. And I also took a look at this decrypted, and as you can see, I just ran this command cat decrypted.txt, and we are decrypting and encrypting without any issues. So it's working really good, and you can really see that we could really get crazy with streams and do some really impressive stuff, if you will. You could do compression, encryption, and so many other things as far as your creativity goes, and you can do a lot of things with streams. Now, one idea that I could give you right now that could be quite good to work on, maybe take it as a challenge. Also try to log to the user how much of the encryption is done. So if you try to encrypt a file that's 10 gigabytes like that text gigantic, it will take roughly around a minute to complete. So I want you to take it as a challenge and log to the screen how much it's done. So you could log maybe something like this. Decrypting maybe, and 65%, and then decrypting maybe 69%, and then decrypting maybe 72%, and go all the way up to 100%, and then log to the screen that decryption was done. And you could also do it the other way around for decoding. So decoding 65%, and well, definitely you're going to start from 0 and you're going to go all the way up to 100%. So take this as a challenge and do it. Now you should be able to do it with the current knowledge that you have. Now I'm going to give you a couple hints. What you can do is to get the total file size out of your read file handle. So this read file handle has this stat, I guess. Yep, it's called stat. And in there's the file size of that file. So you get the total file size. So let's say the total is 7 million, this number. Okay, so it's a pretty big number, but let's just make it something reasonable. So I'm going to say 300 billion, if I'm reading that number correctly, but it doesn't matter. So you're going to get the total file size, and what you can do here is to, in the constructor, define a new property and call it maybe total bytes read, something like that. And here, every time you get the chunk, get the length and add it to this total bytes read. So you keep incrementing this value every time you run this transform method. And also in the transform, add an if statement. So say if, something like that, that says every 1,000 times that I run this method, I'm going to log to the screen the percentage. You shouldn't try to do a log for every method call, because in that case you're going to get a whole bunch of logs, which is really not useful. Instead you should, define a variable and say how many times we read this. We're calling this method, so it should start from 0, and every time you call this function, increment that by 1, and also do an if statement to say if it's divisible by maybe 100,000, just log to the screen the percentage, and you can get the percentage like this. So you get the bytes read. Let's say it's this value. So this is how many bytes you read. You divide it by the total file size, and then you just multiply it by 100, and then you're going to get the percentage. So take this as a challenge and do it, and do share me the results. I'll be glad to take a look at your code. Also, I might post a solution on my GitHub or on my LinkedIn
or I might not, I don't know, but take this as a challenge and really try to do this. It could be a cool project to work on to, do an encryption and decryption, and also keep logging to the screen how much of that encryption or decryption is done. Alright, so we're pretty much done with streams in this video, and definitely from now on we're going to see a lot more of streams in the course. And not just in the course, actually, in other videos that I might publish here on this channel, we will definitely use streams. We will have some videos that we're going to build some cool applications, and then we're going to use some third-party packages. So they're not really technically part of this course, because in this course we're just focusing on the native Node.js modules and on the Node.js itself without installing anything really, but we will have those kind of videos as well, where we will install some packages and build some real-world applications. And both in the course and in those videos we will see a lot more of streams. Alright, so before I end this video, I'm going to just give you some final notes and also talk about how you could learn more about streams and build on your current knowledge of streams. Now, there's something that we didn't talk about in the video, and that's streams in object mode. Now, typically when you're using streams, you're handling some binary data in a buffer, but you could also have streams in object mode, which is another mode for a stream. Now, if a stream is in object mode, rather than using buffers to move data around, and by data here I mean zeros and ones, we will move JavaScript objects. So think of it, for example, like a database that you have, and you have some large JSON data, some large objects, maybe gigabytes of objects, and you want to move them to your node process. Now, that would be a good place to use streams in object mode, because you are moving a huge amount of data that is a JavaScript object. Now, you could create a stream, and when you are creating a stream, if you specify the object mode, it will be in object mode. Otherwise, if you have a stream and you want to switch it to an object mode, it's not safe. And also, when you create a stream in object mode, the high watermark value will now be, instead of 16 kilobytes, it will be 16, and I guess it will mean 16 number of objects. And yeah, here you can see for streams operating in object mode, the high watermark specifies a total number of objects. So we're not really going to talk about object mode, but I just want you to know this and keep this in mind, because sometimes you will see some examples of streams in object mode. Nothing is really different, everything is just the same. You have readable, you have all those methods, you can implement a stream that will operate in object mode, but now instead of just some zeros and ones, you're having some JavaScript object. So I'm sure that by just you reading the documentation and creating some simple applications for yourself and doing some experiments, you will also understand streams in object mode. Now, I could also give you an example where this object mode is used. If you know this PG package in Node, which is here, now you could use this Node Postgres to interact with a Postgres database in your Node application. So you'll just install this, and well, we don't have an example here, but if you take a look at its website, you'll see how it's used. So basically you just run some queries like select all from users table or something like that, and then you will fetch some data from your database. Now typically if you want to fetch a huge amount of data, like 100 megabyte of data or a couple of gigabytes of data off of your database, what we would do is to use some things like limiting and offsetting and keep making different queries to your database and get different data at different times, and then maybe do something with them. But you could also do that using streams. Now, Node Postgres doesn't use streams, but there is this package, I think it was called PG Streams Node npm. Let me see if I can find it. PG query stream, I think it was this one. I think it was this one. I'm not quite sure what the name was, but here we can see that receive results rows from PG as a readable object stream. Yeah, I think this was this one, PG query stream. So if you install this one, when you run a query like this, you're going to get the results, but in a stream. So this query here is now, actually, you get the query and then you create a stream off of this query like this. And then you were going to get this stream, and you could just use it like any other stream. So you could use the end, you could pipe it, you could do anything that we really talked about in this video. So it's really similar to all the other stream consumers objects that we have in Node and in other packages that we have available. And also, I encourage you to read the source code and see what is happening. You take a look at the issues, and you could take a look also at the source code, which is a great way, by the way, to learn more about streams. You could just read these source codes, some of the well-known packages out there that are using streams, and you will see how they are implementing their own streams and also how they are using streams. I think this package should be heavily dependent on the streams object. Let's just try to search for stream, see what are some of the places that it's being used. Concat streams. Now here we also have a lot more packages that are there to help us deal with streams better, so that's also something else I encourage you to take a look at. Something like concat stream, which is here. It's pretty popular, 15 million downloads each month. We're not really going to talk about them, but I'm just going to give you some hints where you could explore more and see some of the packages. Now, a good way to learn about these is to find these packages and try to read the source code and see how they are using streams. So that's something that I highly encourage you to do. Now this one, let's go back to that PG query stream. Here we could see some other packages, maybe like stream spec. I don't really know what this is, but I think it would be pretty helpful to take a look at it and see the source code and how they are implementing their own streams and whatnot. And you could see that streams are really used in this package. Here it's using this readable from stream, and I guess it should really be inheriting from it at one point. So if you take a look at this file, I'm sure you will find something like that. So let's search it, readable, and yep, here it is. Class query stream extends readable, and this is how you could implement your own stream, something that we talked about. A constructor, destroy, read, and yep, that's pretty much it. Now another thing that I can say is busboy. I'm not quite sure if Express is using streams in itself. So I'm not quite sure whether Express is implementing its own streams or it's just using the response and request streams that are implemented by the HTTP module. So I don't really know, but if you take a look at the source code, it's just a quick search, you'll figure that out in no time. So it could either be just using those responses and request objects, or it could be implementing its own in one shape or another. But definitely something that's for sure is that a lot of dependencies of Express and a lot of other packages that are kind of in the standard Express library, they are for sure, a lot of them, using streams and actually implementing their own streams in a lot of ways. But one thing that I can just say about Express, if you try to handle file uploadings using Express, you most definitely have heard about Malter, which is something that is really, I think it's also an Express standard library or something like that. So this Malter is here that will help you to handle file uploads, but its most important dependency is busboy. Now, did I search it? Yep, we did. So busboy is also another package. The source code is pretty minimal, and I guess you could just read the whole source code in just a couple of minutes, and it only has one dependency, stream search, which is another streaming package. So you can also read about this, and this is pretty popular, 5 million downloads weekly. So stream search is a module for Node.js that allows searching a stream using, what is this algorithm? Honestly, I don't know what this algorithm is, but I think it's a search algorithm. We have so many of these out there. So yep, this is another cool package. You could look at it. It looks interesting. I haven't used this, but I might one day. I mean, being able to search a stream is kind of cool. But this busboy itself, if you take a look at the source code, so I'm going to search for busboy GitHub. Here it is. So basically you could use this busboy package to handle file uploads. And if you take a look, now this one is kind of lower level, so it's harder than Malter, but this is how I usually handle my file uploads in my Node applications. Rather than trying to use Malter or something really high level, I really try to implement everything myself. Something like busboy would really allow me to do that. So If you want to use this, you need to have some good understanding of event emitters and also streams like here .onData, .onField, .onClose. But it's really a cool package. Malter is using this. It's incredibly fast, and you can really control everything that is coming through your web server. You have pretty much full control using this package. And also, most importantly, what I really like about this is that its source code is really minimal. So if you go to lib, there's just this index.js, which is not that much, like only 50 lines. And you also have this utils, which has some functions, but this is pretty much it. And then you have types, which you have one for URL encoded, and most importantly for multipart, which is the part that handles these file uploads. And you can see that at the top it's including the readable and writable, and then it is extending these and inheriting from these. So if you look here, you will see the header parser, but there should be something that says extends right here. So file stream extends readable, and this is how Busboy is using streams to handle file uploads. The read method, and what else? The constructor, and it should also inherit from this writable, which is right here. So I highly encourage you to read these source code. They're really well written, and you could get so many inspirations by reading these source codes, and just experiment and use them and see how different packages are implementing their own streams. And you know, I'm sure you could learn a lot this way. So definitely don't stop your journey of learning streams and mastering streams at this point. Definitely read the documentation for yourself. It's a great recap. Definitely check some of these packages out, check their source code, try to install them, try to use them, maybe try to even modify the source code and then see what you could come up with. And yeah, these could be some good tips that I can give you right now. And also take a look at the Node.js source code as well and see how Node.js itself is implementing streams. So I have cloned the Node source code here on my computer, and let me just show you where the source code for streams are located at. Now, when you're just starting out and if you want to know where the code is implemented, just go to the module itself. Right at the top, almost always you'll see something that says, where is it? Right here. Source code is here in this file. And then you will open that up and see some of the other include lines, and well, you'll go to different pathways and figure out which part is implemented in what file. So let's also take a look at the Node source code. So lib streams.js. Now in the Node source code, things that we really care about, one is the source, which has the C++ code, and another one is lib, which has the JavaScript code. So let's first take a look at the streams implementation, which is in streams.js. It's right here, and you could read it right here. It's a pretty small file, but it's actually including a lot of things, so that's why it's super small. You can see require this, require that, and here's a pipeline, here's a pass through, here's transform, duplex, writable, finished, destroy, and so much more. So many things are getting included from this file. And well, what you can do is to take a look at the other source codes like here. Now for streams, so part of the code here is in this lib. So stream.js is one of them. Another location is right here, these underscore streams, but they are just including something else, so nothing really is going on here. As you can see, they're all including from this stream folder, which is right here. Now here we have this consumers, and we also have the promises version, just like FS promises and streams promises. And we also have this web stream, which is different from streams, but it's really related to streams. So if you go to the documentation all the way down, you could see something that says Web Streams API. Now we have this in Node because this WHATWG, which is kind of like a standard, it's just an organization that imposes JavaScript standards and things like that. Node.js also has this web stream. So this organization said that we need to implement streams in Node in JavaScript because we
didn't have them. And now this web stream was introduced, and now Node.js, to keep up with this JavaScript community, also introduced this. But it's not going to really replace streams. It's not something else to learn. It's actually really similar to what we discussed. So if you understand streams, you will also understand web streams. Okay, nothing is really going on here. So a readable stream and, well, a transform stream, just like before, you call this transfer method chunk. Now it's a little bit different. You have a controller, but it's really the same thing here. You change the stream in this function, but as you can see, it's really the same thing. So we also have streams in JavaScript. So for example, if you're using React, you could also now use streams, and you could read the documentation if you search for maybe streams, Mozilla, and streams API. So this one is now for just JavaScript, and you can see that you could also now use streams. So if you go to concepts, or I guess we should go to maybe use Readable Streams and see some examples. So here we can see that we have this read method. We have start. This is also how you implement your own streams. High watermark, we have the same thing here. So I could really say that with high confidence that I'm sure that you could now really easily understand the Streams API as well on the front end. And actually, let's take a look at the Stream API and just see the definition here. So if you go to Streams API and try to read this, see it says that the Streams API allows JavaScript to programmatically access streams of data received over the network and process them as desired. So something we saw before, right? We received data and then we processed them, and we did whatever we want with them. Now here we can see that it says streaming involves breaking a resource that you want to receive over a network down into small chunks, right? So just you have a huge file or a huge video file, maybe a huge image, you break it down into different chunks and then you receive the data rather than just trying to receive it all in just one huge chunk. So which is really useful, and we saw how to do it using a Readable Stream. So if you try to read a file using a Readable Stream, basically you're just breaking it down into different chunks and receiving the data in different chunks, which is incredibly useful and very powerful. So you receive them in small chunks and then process it bit by bit. Okay, so you have full control over every single bit in your data, which is amazing. I think it's really great. You could do so much work with this. So this is something browsers do anyway when receiving assets to be shown on web pages. Now this is kind of cool. So when you are opening a video file in your browser, like maybe playing a YouTube video, or when you're just actually opening a web page, you're waiting for it to load, you're receiving the data in different chunks, and I can show it to you right now. So if I open up my Google Developer Tools and I go to Network, I just disable cache and change my network speed to slow 3G, and I just do a quick refresh. Now this will definitely take a while, but you can see that I'm receiving the data in different chunks, right? For example, even this one, this JavaScript file, I'm receiving it in different chunks. So you could see how much resources I'm getting here, 1.1, 1.2, 1.4. So I'm not just receiving the whole web page and every single last one of these in just one chunk. I'm receiving them in different chunks, even each one of these items. So this image, I'm receiving this in different chunks rather than just receiving it in one huge chunk. So streams are used pretty much everywhere in computers, in your web applications, in your web browser, in your operating system, pretty much everywhere. And you can see here that it says sometimes you'll see images displayed gradually as more is loaded, right? So I'm sure you have seen some of these examples that you open a web page, you receive the first portion of the image, and then it keeps going all the way down. So you're receiving different chunks, right? That's where streams are used here. And here, most importantly, it says that, but this has never been available to JavaScript before, right? So we didn't have this streaming concept in JavaScript. Node.js introduced it, And now we also have it in JavaScript using this web stream concept, which is pretty new to this JavaScript world. So previously, if we wanted to process a resource of some kind, maybe a text file or a video file, we'd have to download the entire file, wait for it to be deserialized into a suitable format, then process the whole lot after it's received. So it's moving the whole data into the memory and then process it, which is super limiting, and we can't deal with huge files. But now using streams, it is available in JavaScript. This all changes. So it's a huge concept, and you definitely need to master it, both as a Node developer and also as a JavaScript developer. You can now start processing raw data with JavaScript bit by bit as soon as it's available on the client side, without needing to, come on, I keep opening this dictionary by doing a force touch on my trackpad, but okay. So without needing to generate a buffer, string, or blob. So now you could just receive data in different chunks without needing to, create a huge buffer or a huge blob or things like these. So this is also something else that you also should be able to feel comfortable using streams on the front end. So you can now use it with React, Angular, Vue, and whatnot, and I'm sure you will have a very easy time incorporating it into your application. Well, I shouldn't say easy time, but you'll definitely know the core concepts, and with just experimenting a little bit, creating something, receiving different errors, I'm sure that after maybe a couple hours, you'll really get up to speed and start using streams in your applications. All right, so where are we? So we were here in this web.js, which, as we said before, it's just something that Node.js also implements to be more standard comparing to other JavaScript communities, but it's not going to replace that Node streams. It's not going to be a new thing. Still, that stream is heavily used everywhere in Node. And also, if we say that it's going to replace it, which is not really going to happen, we're not going to have any kind of troubles incorporating it. Might be some of the syntax might be slightly different, but the core concepts are the same thing. Alrighty, so we also talked about this streams folder and all the files that are implementing it, but there's also this important thing. So far it's nothing really crazy, right? It's just some small files. But if you really want to see where the core implementation is, you should go to this internal, which is here in this lib, and then internal, and then we should have something that says web streams. Well, not web streams, but streams itself. So let me see if I can find that here. So internals and then streams. Now here you could see the core implementation of those streams that we talked about. For example, Duplex, if you open it up, you could see right off the bat that it's including the readable and writable, and it's inheriting from those two, right? So here is our Duplex class, and it's calling the readable constructor and writable constructor. So when you're creating a duplex stream, you're just creating both a readable and a writable, but in one single object. We have duplexify, which I guess will receive two streams, and then it will give you one duplex stream, if I'm not mistaken. I'm not sure. But yeah, here we could see the more detailed implementation of those streams. Here we have pipeline, we have readable.js, and these ones are kind of long, 1,000 lines. But yeah, this is where all the magic is happening. And also, apart from this one, so we talked about this lib right now. These files that we just saw are the only files that are implementing this stream module, but using JavaScript. There's also this other part that's implementing the even more core things of Node, but now it's really low level, and now it's in C++. So if you go to source, and if you scroll all the way down, you should find something that says streams right here, stream base, stream pipe, stream wrap. So these are more lower level, but if you are familiar with C++, you could also read them and find some cool things and some interesting things about them and see how Node is really implementing these streams, which is quite interesting in my opinion. So here we could see that we have all these files here from stream wrap and stream base. So these files are implementing the streams, but using the C++ side of Node. And the header files, .h files, are header files which basically just include the definition of the functions, and the .ccc files are implementing those function definitions that were defined in the .h files. So also feel free to read these codes if you are familiar with C++. And you can see that node buffer.h, which is C++, is also really used in streams. So yeah, you could see the source code and implementation of streams in Node in all these files. So here are for C++, and then in lib, and that internal, and also in that stream.js file, you could see all the rest. So this is kind of like a map for you to be able to navigate the source code of Node and read more about streams if you want. And most importantly, I should say, try to create applications for yourself. So now that you understand the core concepts, go read the documentation, read the source code of other packages, read the Node.js source code, and most importantly, I should say, it's for you to go out there and create your own apps. We saw how powerful Node streams are, so you really could get creative and do some really cool stuff with them. Try to handle some huge amounts of data, and don't really limit yourself to just files. You could also use networks and talk to other processes, so you really have a huge amount of power at your fingertips right now. So do some cool things with this, and I'm sure you'll get a lot more comfortable with streams as time goes by. And we will also see a lot more of these streams in the course and in the channel as well. So now I'm sure that your knowledge of streams from now on will keep improving and improving. Alright, that's it about this video. Thank you so much for watching, and I will see you in the next one.